Streaming. Good evening all of you. Welcome to Unacademy, the one-stop destination for all English medium civil service aspirants. Welcome to the Conquer Prelims 2026. The one-shot marathon on nanotechnology, defense and space technologies. Before I start the session, a very important announcement. If you are preparing for 2026, don't miss the UAI-PMT, the Unacademy All India Prelims mock test. With this you will get your All India rank so that you will know where you stand in the national competition. The test analysis and the mentorship sessions by the experts will help you to identify the gaps in your preparation and act upon them. The exam will be available both in English and Hindi, and the paper is curated by the top educators. So register now and don't miss the test on 19th April. Let us now continue with our marathon session on nanotechnology, space technology and defense technology, and starting the session with the first subject, that is nanotechnology. Before I continue with the session, please let me know in the comments whether everything is clear or not. Is my audio video clear? Is my audio video clear? Give me a second. Please let me know in the comments if my audio video is clear. Yes. Thank you so much. So firstly, what is nanotechnology? Nanotechnology is any technology or anything we do with the nanoparticles. And nanoparticles definition is any particles in the size range of 1 to 100 nanometers. 1 nanometers, 10 nanometers, 20 nanometers. Small particles. The technology dealing with small particles in the size range of 1 to 100 nanometers is called as the nanotechnology. And what is a nanometer? Nanometer is 1 billionth of a meter, that is 10 to the power of -9 of a meter. Okay, so dealing with such very small particles is nothing but the nanotechnology, right? Yes, Prerak, even I am glad to be here. Then, now what are the nanometers? Nanoparticles or the nanomaterial. These nanomaterial, which are in the size range of 1 to 100 nanometers, exhibit certain unique properties. What are those unique properties? First thing is the size itself. They are unusually small. Second thing is optical properties. For example, if any substance in the normal size is opaque, then the same substance in the nanometer size range is transparent. So there will be changes in the optical properties. It means if you take carbon, bulk carbon in the regular size, that is not transparent. But if you take nanocarbon, that is transparent. And for example, if you take bulk gold, that is gold in the normal size, regular size, that is yellow in the color. But the nano gold is in red color. So it means when you reduce the substance to smaller particle size, its optical properties will change, like transparency, color, etc. And its electrical properties also will change. For example, regular carbon if you take, carbon in the normal size, that is not a great conductor. But if you take carbon nanotubes, they are great conductors. So it means the electrical and thermal conductivity of the material changes when you reduce the size. And also there will be changes in the physical properties. Like for example, carbon in the regular size is not very hard, but carbon in the form of graphene is very hard. Okay, 100 times stronger than the steel. So its physical properties like melting point, boiling point, hardness also will change. Also the chemical properties will change. It means same substance, if you take in the regular size, it may not be very reactive. But if you change it into a smaller particle size, then its reactivity can be more. A normally reactive substance can become more reactive when it is taken in the smaller size, that is in the nanometer size. So to summarize all this information, one small point is, you take any substance in the regular size and the same substance in the nanometer size. In the nanometer size range, it behaves like a different substance. Okay. So taking the same substance in a nanometer size range is as good as dealing with a different material altogether. That is the significance of nanotechnology. Is it clear for all of you? Then, so for optical properties, I have already taken the example of gold. Bulk gold is in yellow color, whereas the nano gold is in red color. Optical properties, electrical, physical, conductivity, hardness, transparency, all properties of a material changes when we take that material in the nanometer size range. Then we have a classification of the nanomaterial. Okay, the first type is called as zero dimensional nanomaterial. Zero dimension means what? Zero dimension, it means length, breadth, depth. All the three dimensions are in the nanometer range, are in the nano range. Is it clear? Length is also in the nanometer range, breadth is also in the nanometer range, and depth is also in the nanometer range. Okay. So, all are within the nanoscale. No dimensions are larger than the 100 nanometer. Example, nanoparticles, or we can also take the example of quantum dots. Quantum dots are zero dimension nanoparticles. Is it clear? Then, one dimension nanomaterial. One dimension means for example, carbon nanotube. Okay, if you take a carbon nanotube, okay, its length is more than 100 nanometers, but the breadth and the depth are less than 100 nanometers. Okay, then it is called as one dimension. It means the count is how many dimensions are above the definition of the nanomaterial. What is the definition of nanomaterial? 0 to 100, I mean 1 to 100 nanometers. If any one dimension is more than 100 nanometers, then we call it as one dimensional nanomaterial. Next one, two dimensional nanomaterial. Like for example, graphene. Okay, if you take graphene, graphene is like a sheet. The graphene is like a sheet. Okay, if you take this graphene, assume this as a sheet, its length is more than 100 nanometers, breadth is more than 100 nanometers, but the thickness is less than 100 nanometers, because graphene is just one atom thick sheet. One atom thick sheet of carbon. Graphene is just one atom thick sheet of the carbon. So all of you answer these questions. The quantum dots are zero dimension or one dimension or two dimensional nanomaterial. Quantum dots are zero dimensional because no dimension, length or breadth or depth is above 100 nanometers. Second one, carbon nanotubes, a tube, a long tube, is it zero dimension or one dimension or two dimension? It is one dimension because its breadth and depth are very less than 100 nanometers, but the length can be more than 100 nanometers. So one dimension is above the 100 nanometers range. Okay. Graphene, which is a one atom sheet of carbon, okay, its length, breadth, both are more than 100 nanometers. So is it zero dimension or one dimension or two dimensional nanomaterial? Graphene is a two dimensional nanomaterial. Very good, thank you. Okay, now let us see what do you mean by the term allotropes. allotropes. Allotropes are the substances made up of the same atom. They are made up of the same atom but differ only in the spatial orientation. Differ only in the spatial orientation. Like for example, graphene, fullerenes, okay, diamond, graphite are the 4 allotropes of the carbon. Graphene, fullerene, diamond, graphite, all the 4 material are made up of carbon only. The composition is carbon. There is no difference. But what is the difference among the 4? The orientation in which the carbon is arranged, the spatial arrangement of the carbon. Okay. Now, out of the 4 allotropes we see graphene, fullerene, diamond and graphite. These 2 are out of our class scope because they are not nanomaterial. They are in the bulk size. So tell me, in the subject called nanotechnology, what are the 2 allotropes of the carbon that we discuss? Everybody please. And I request you all to be very active in the comment section. Feel as if you are watching a offline class and keep actively responding. Okay, and you can also give me the answers in the shortcuts. So be very active in commenting, right? Then, now, graphene and fullerene are the 2 allotropes of the carbon that are in the scope of our subject called as nanotechnology. Now let us see what is the difference between graphene and fullerene. Okay, graphene means like this. Okay, this is a graphene sheet. It's a graphene sheet. As I told you, it is just 1 atom thick. Its thickness is just 1 atom. 1 atom thick sheet of carbon atoms. Length and breadth can be anything, but the thickness is just 1 atom thickness. Okay. So this is the graphene and we call this as the wonder material. We call this as wonder material. Okay. So, if the carbons are arranged in the form of a flat sheet, then we call it as a graphene. Okay. Then, if the carbon atoms are arranged in any shape other than, it can be any shape other than the flat sheet, then it is called as fullerene. Fullerene. And any shape means what? It can be spherical or it can be elliptical or it can be like a tube. Okay, anything. It can be any shape other than the flat sheet. Okay, so this is graphene. As we have understood, this is graphene and the carbon nanotube is a fullerene. Can I call the carbon nanotube as a graphene? Can I call the carbon nanotube as a graphene? Carbon nanotube is not graphene, it is fullerene, because what is the definition? Flat sheet is graphene and any shape other than the flat sheet is fullerene. So it is cylindrical, so therefore it is fullerene. By the way, what is carbon nanotube? You all understood what is graphene, right? If the graphene is rolled up in the form of a tube, that is called carbon nanotube. Okay? If the graphene is rolled up in the form of a tube, that is called as a carbon nanotube. The rolled up sheets of graphene are the carbon nanotubes. So same graphene, if you roll it up, then it is not called graphene anymore. It should be called as a fullerene. Carbon nanotube is a fullerene, right? So, graphene is a flat sheet of the carbon atoms arranged in the form of hexagons like this. Carbon atoms are arranged in the form of hexagons. If you observe, carbon atoms are arranged in the form of hexagons. Okay. And it is an allotrope of the carbon, which consists of carbon atoms connected by single and double bonds. Okay. And it is completely open. It is completely open, right? Okay, open means what? Flat sheet. and the nested or closed fullerenes are called bucky onions. Okay, so flat sheet is graphene, keep answering, and the cylindrical one is called as carbon nanotube. Okay, and the spherical one is called as buckyball. The spherical one is called buckyball. Buckyball is, this is the buckyball. Buckyball is also called as Buckminster fullerene. Buckyball is also called as Buckminster fullerene. Okay, because a scientist called Buckminster Fuller first time identified this. Therefore, it is also called as Buckminster fullerene. Okay, that is C60. C60 means what? You have 60 carbon atoms. You have 60 carbon atoms in this. Then it is called bucky ball. And the carbon nanotubes can also be called as bucky tubes. And if you have nested and spherical, they are called bucky onions. Bucky onions means what? Multi-layered bucky balls. Multi-layered bucky balls are called as bucky onions. Multi-layered bucky balls are called as bucky onions. Okay, so now here I kept the graphene, carbon nanotubes or bucky tubes, bucky balls, bucky onions. In this, how many are graphene? How many carbon allotropes can be called as graphene? Only the graphene. Bucky tubes, bucky balls, bucky onions, all of them are called as fullerenes only, because I told you any shape other than the flat sheet is fullerenes. All these are fullerenes, right? All of them are fullerenes. Clear? Yes. Then now let us see more about the carbon nanotubes. Carbon nanotubes are the cylindrical molecules that consist of rolled up sheets of graphene, and they are 100 times stronger than the steel, but only 1/6 the weight of the steel. It means what? They are very lightweight but super strong, 100 times stronger than the steel, and only 1/6 of its weight. Okay, also they are good thermal and electrical conductors. Okay, the great conductors of heat and electricity, right? Then now the carbon nanotubes play a major role in the EPR effect. Now we are discussing the applications of the carbon nanotubes. After understanding what are the carbon nanotubes, we are now trying to understand the applications of the carbon nanotubes. The most important application is carbon nanotubes can be used in the cancer therapy. Carbon nanotubes can be used in the cancer therapy. Okay, so let us see why wonder material, Saurabh, because it is super strong. Imagine steel itself is a very strong material, we assume, but it is 100 times stronger than the steel, very flexible, great conductor of heat, great conductor of electricity, and very lightweight. Okay, and very small in size. So these properties will make it a wonder material. Good question, Saurabh. Thank you. Okay, so now let us see carbon nanotubes, how they play a role in the cancer treatment. Okay, first let us assume that this is a cancer cell, and this is a normal cell. Okay, and now if you observe the cancer cells, these cancer cells have slightly larger pores. If you observe the cancer cell, it has slightly larger pores, and if you observe the Normal cell, it has very narrow pores. So all of you look at and tell me the pore size, okay, pore size is larger in the cancer cells or healthy body cells? Pore size is larger in the cancer cells or healthy body cells? They have larger pores. Now let us assume this is carbon nanotubes. What are they? They are carbon nanotubes. Okay. And inside the carbon nanotubes, what I am keeping is a cancer drug. Okay. What is there inside the carbon nanotubes? Cancer drug. Okay. Now, can the carbon nanotubes recognize the cancer cell and specifically give the cancer drug only to the cancer cells? Are the carbon nanotubes intelligent? Can they recognize the cancer cells? No, they cannot recognize the cancer cells. But due to larger pore size, when there are cancer cells and also the healthy body cells, obviously more cancer drug, okay, goes into the cancer cells. One more cancer drug goes into cancer cells. Is it clear? Second property is, and obviously lesser amount of the cancer drug goes into the healthy body cells. Not only lesser amount of the cancer drug goes into the healthy body cells, also the healthy body cells have a mechanism called as lymphatic clearance, but cancer cells do not have. They have poor lymphatic clearance. They have poor lymphatic clearance. Poor lymphatic clearance means what? They cannot send the cancer drugs, they cannot send the cancer drug out of the cell. The cancer cells cannot pump out the cancer drugs. Whereas normal body cells can do two things. One, they receive lesser amount of the cancer drug. Two, whatever little cancer drug that reaches the normal cell will be effectively pumped out of the normal cells. Okay. With these two properties together, we call this as, the two properties together we call it as enhanced permeability. Enhanced permeability means what? The first point. Okay. Enhanced permeability means first point. They permit more cancer drug into the cell. And retention. Retention means what? The second point. That is, they cannot pump out the cancer drug out of the cell. They retain. They hold on. They retain the cancer drug inside the cell. So together this is called enhanced permeability and retention mechanism. So because of this mechanism, what is the net result because of this mechanism? Okay, the net result is the cancer cells will die and the normal cells survive. That is the end result of this enhanced permeability and retention mechanism. Okay. These carbon nanotubes will be injected into the body, Avinash. Is it clear? And what is this cancer drug? It is a toxic substance that can kill the cells. What is the major problem in the cancer treatment? The major problem in cancer treatment is not killing the cells, which anyway we can do. Killing the cells is not very difficult. The major problem in cancer treatment is protecting the normal cells, because along with the cancer cells, if our normal healthy cells also die, then it will lead to severe weakness, anemia and hair loss and lot of other problems. So healthy body cells should not die and cancer cells should die because of the cancer drug. and that is what is achieved because of this mechanism called as enhanced permeability and retention effect. Is that clear? Yes. And this is like a targeted drug delivery. It's like a targeted drug delivery. Tell me, are we using any new cancer drug here? No, we are not using a new cancer drug. The drug used can be the older drug, but it is a new way to deliver the cancer drug into the cancer cells. Is it clear? It is a new way to deliver the cancer drug into the cancer cells, specifically without destroying the surrounding healthy body cells. Is it clear? Okay, so that enhanced permeability and retention effect is already explained. Done? Now, moving on to the next concept, that is quantum dots. This is a little bit tricky. You need complete focus to understand. I will try to explain it by showing some animations, by taking some interesting examples, okay? And I need complete focus from your side. What are the quantum dots? Permeability, Ram Singh, means permitting the cancer cell into the, permitting the cancer drug into the cell, okay? The cancer cell will permit, okay? The cancer cell will say, aaja. So it will permit the cancer drug into the cancer cell. Is it clear? That is called permeability, right? Then, now what are the quantum dots? Now let us see what are the quantum dots. Quantum dots are, okay, listen each point. Quantum dots are small, very small. Already nanoparticles are small. Then what do you mean by this small? In the small also, see what, like in general, quantum particle definition is 1 to 100 nanometers, right? Whereas quantum dot is just 1 to 10 nanometers. It means quantum dots are much smaller quantum particles. Quantum dots are much smaller quantum particles. I mean, within the quantum particles also the smaller ones. Is it clear? Only just up to 10 nanometers, right? Clear? And they are semi-conducting, okay? Nanocrystals or nanoparticles. I mean, some of them are like particles, some of them are in the crystalline form also. And they are, so I hope the 3 points are clear. They are small. I mean, within the nanoparticles also the smaller ones, and they are semi-conducting. They can be either crystalline or simply nanoparticles, and they are made up of which material? Usually they are made up of silicon, cadmium selenide, cadmium sulfide. These are the material with which we can make the quantum dots. Is that clear? Size range, as I told you, is 2 to 10 nanometers. 2 to 10 nanometers or up to 10 nanometers. They can absorb the light, and when they release the energy, when they will absorb the light, when they release the light, they will release a different wavelength of the light, okay? Then, and transform it into a different color light. So here I have to tell you a few things about the waves, okay, which is very important in the next 2 subjects also, okay. What I am going to tell you now is very, very basic, very, very fundamental, but very important for nanotechnology, space technology and defense technology, okay. So most of you might already know this. So quickly tell me, look at this. This is a wave. In this wave, the peaks are called as, what do you call these peaks? They are called crest. What do you call this null, the lower side? They are called trough. They are called trough. The distance between 2 crests or the distance between 2 troughs, the distance between 2 troughs is called as, all of you please, distance between 2 two crests or two troughs is called as wavelength. That is called wavelength. Okay, and the number of this I am writing as C, this I am writing as T. The number of crests or troughs that pass, the number of crests or troughs that pass a given point, in unit time is called as, yes, that is called as frequency. Okay, so now if you observe, let us suppose this red color is that point. Okay, now look at both the waves, the wave in yellow color and the wave in white color. Okay, which wave, the A or B, in which case more crests are passing through that particular red color stick or point in 1 second? In 1 second, more crests or troughs pass through this point for which wave, A or B? B. So B is a high frequency wave. B is a high frequency. What is the relation between wavelength and the frequency? The relation between wavelength and frequency are inversely proportional. Wavelength and frequency are inversely proportional. Okay, and it means if the wavelength is more, if there is more distance between the two crests, then lesser number of crests will pass through the point in 1 second. Listen this carefully. If there is more distance between two crests, then lesser number of the crests will pass through the point in 1 second. So wavelength is inversely proportional to the frequency. And there is another parameter, that is energy. What is the relation between energy and frequency? Energy of a wave and the frequency of a wave. Energy and frequency are directly proportional. Energy and frequency are directly proportional. It means, okay, high frequency wave is also high energy wave because it can, with high energy, what kind of energy we can say? So it's like the energy because of the movement. The wave is moving very fast. So because of that it is high energy wave. Is it clear? And tell me, in the visible light we have this VIBGYOR we say. Okay, violet, indigo, blue, green, yellow, orange, red. These are all the different colors in the visible light. Okay, tell me the color depends on what? The color of light. The color of light depends on the wavelength or frequency. Is it clear? Color of light depends on the wavelength or frequency. Okay. Now, if you observe an electromagnetic spectrum, okay, in the electromagnetic spectrum, can you tell me what is the wave? Okay, first, what do you mean by the electromagnetic wave? Okay, in the electromagnetic wave, it has both electric field and also the magnetic field. A wave which is having both electric field and also the magnetic field is called as electromagnetic wave. Is that clear? A wave which is having electric field and also the magnetic field is called electromagnetic wave. Okay, then what do you mean by spectrum? spectrum. Spectrum means what? Spectrum is a range of wavelengths or a range of frequencies. Range of frequencies. Okay, means very long wavelength to very short wavelength. Like for example, very long wavelength to very short wavelength, or very low frequency to very high frequency. So it's a range of wavelength or range of frequencies. Is that clear? Okay. So tell me, in the electromagnetic spectrum, what are the longest wavelength radiations? What radiations have the longest wavelength? They are radio waves. Radio waves have longest wavelength. Is it clear? We use these radio waves in the GPS, satellite signaling, Wi-Fi, Bluetooth, okay, radars, okay, in all these things we use these radio waves only. After radio waves, what are the waves with slightly lesser wavelength? You have microwaves. We use them for the cooking purpose. Then after that we have infrared radiations. Infrared radiations. Is it clear? Then you have VIBGYOR. This is visible light. That is visible light. Okay. Then after that you have UV, ultraviolet radiations. Next you have X-rays. Next you have gamma rays. Gamma rays are the highest frequency. Okay, radio waves are the lowest frequency. Radio waves are the lowest frequency. So now tell me, in the VIBGYOR, that is in the visible light colors, which light in the visible range is having high frequency light? Okay, all of you please. High frequency visible light is violet. Okay, low frequency visible light is red. Is that clear? Low frequency is red. And you can easily remember, after infrared you will get red. After violet you will get the ultraviolet. Okay, if you forget the order, remember like this. After infrared comes red. Infrared, then red. Violet, then ultraviolet. Ultraviolet color will be towards the UV. Red color will be towards the infrared. Okay, so remember with this step. Okay, now. So, now what I am doing is, I will give you like different pieces of information. Okay, this is how usually I teach. Okay, like keeping some dots. Is it clear? While we are keeping the dots, you will not understand the final design. I mean, finally what I am going to explain will not be clear. Just make sure that each dot is clear. I mean, each point that I am giving is clear. And keep remembering the points, because if you forget where you kept the dots, you cannot complete the design. Okay, I kept the dots but I forgot the dots. How can I complete the design? So remember and understand each and every point. Remember each and every point. Then we club all the points to get the final concept. Is that clear? Okay, right. So first, these are some basics that I have seen. I have explained. Now, basically, what is our question? What I am trying to explain? When the bulk gold is in yellow color, why the nano gold is in red color? Okay, is the question clear? Answer to this question you will understand it after some time. Before that we will keep lot of dots. I mean, we will understand many basic concepts. Okay, so what is the final question that we are trying to understand? When the normal gold is in yellow color, why the nano gold is in red color? That is our question. The answer is, okay, because of a concept called as quantum confinement. Okay, see, first question. Why nano gold is red? Okay, the answer for this is due to quantum confinement. Use the word, all of you. Due to quantum confinement. Then we will get another question from this. That is, what is quantum confinement? What is quantum confinement? Is it clear? Okay, I hope the flow of thought you have understood. Right. So, what is quantum confinement? What is quantum confinement? Simple. Increase in the band gap with decrease in the size of the particles. Okay. Increase in the band gap with decrease in the size. Increase in the band gap with decrease in the size. That is the answer. Is it clear? With that we will get another question. That is, okay, what is band gap? What is the band gap? Is it clear? And final answer you will get only, like why nano particles are in red color, you will understand after some time. Okay, just follow the flow of the thought. What is band gap? Band gap is the energy difference between valence band and conduction band. Valence band and conduction band. Is that clear? Then we will get another question. Okay, what is valence band and conduction band? I mean, what are the valence band and conduction bands? Okay, so let us try to understand that. Okay, by the way, I will come back to this series of questions and answers once again. I will consolidate the final point with you. Okay, so first let us understand what is the band gap, what is valence band and what is conduction band. Is that clear? Okay, what is valence band and what is conduction band? You all know that in an atom, imagine this is an atom. In the atom you have the nucleus, and in the nucleus you have the neutrons and protons. Is it clear? What do you have inside the nucleus? Inside the nucleus you have neutrons and protons. Is it clear? Then around the nucleus in different orbitals, our electrons are orbiting like this. Electrons are orbiting around the nucleus like this. Is that clear? Okay, electrons are orbiting around the nucleus. And these circles can be called as, okay, electrons in the orbitals. We can call them as orbitals or bands or energy levels. Is it clear? The circles in which the electrons are orbiting, these circles, they are called as, tell me what are these called as? They are called orbitals or energy levels or bands. Is it clear? Orbitals or energy levels or bands. All the three roughly mean the same. I mean, we cannot go into the details of the like atomic structure now. Okay, but all the three terms roughly mean the same. Okay, orbitals, energy levels or bands. Okay, now the orbital closer to the nucleus is the low energy one. This is the low energy one. Okay, and this is the high energy band. Is it clear? Okay, the one which is closer to the nucleus is low energy and the one which is far away from the nucleus is high energy. Okay, now what happens is, complete focus here please. Now what happens is, when you give energy to this atom, when you give energy, How do you give energy to this atom? You will put some light on that, okay, some light energy. Is it clear? We are putting some light energy on this atom. Is that clear? Okay. Yes. So when you give light energy, what happens? The electrons will get excited. They will go from the low energy levels. The electrons will jump from the low energy level to the high energy level. Is that clear? What happens when you give energy to this particular atom? The electrons will jump from the low energy level to the high energy level. Okay. But when they are at the high energy level, they are unstable. They cannot stay there forever. Okay. And they will eventually fall back to the low energy levels. Is it clear? They will eventually fall back to the low energy levels. So it means, as you all know, when the energy is absorbed, the electrons go from, look at here, the electrons go from valence band, low energy. Okay, the electrons move from low energy, that is valence band, to high energy, that is conduction band. Okay, what is low energy level called as? Low energy level is called valence band. Okay, low energy level is called valence band. Okay, high energy level is called conduction band. Okay, now the next point. When the electron goes or falls back, when the electron falls back from high energy is conduction band, to low energy valence band, then what happens? Energy will be released. Is that clear? When you give energy, electron goes to the higher energy level, and when it comes back to the lower energy level, that particular light energy will be released by that atom. Is that clear? Now let us understand what is the band gap. Okay, complete focus here. What is band gap? How much energy you need to push an electron to the higher energy level? How much energy you need to push an electron to the higher energy level? Okay, that is called as band gap. If you need more energy to push an electron to the higher energy level, then it means the band gap is more. Is that clear for all of you? Right? Okay. More band gap means you need more energy to push an electron from the valence band to the conduction band. Is that clear? Thank you so much, knowledge. Okay, what is the concept of more band gap? Band gap is more means what? You need more energy to push the electron to the higher energy level. Okay, that is conduction band. Or more energy released when the electron falls back from the conduction band to the valence band. Okay, so is the concept clear? More band gap means what? More energy is needed to go up and more energy is released when it comes back. That is called more band gap. I hope you are understanding each point and also remembering each point, because then only you will understand the final point. Now, let us try to understand what is quantum confinement. What is the meaning of the term quantum confinement? Okay, to understand quantum confinement, we should first know the meaning of the term quantum. Quantum means what? The smallest unit of either matter or energy. Okay, so quantum simply means what? Small particle. Okay, confinement means what? Confinement means what? Okay, look at here. Why electrons run around the nucleus? Why not protons? That is the basic design of the nature. Even I don't know that knowledge. Okay, that is the basic design. Yeah, Les, your point is also correct. Probably the nucleus could have been designed by the nature as negatively charged, but one thing, electrons are very lightweight when compared to the neutrons. Neutrons come under the category called baryons. They are very heavy weight. Okay, and electrons are lightweight. That could be one reason. Okay, so now coming back to this. Okay, quantum means what? Very small. Confinement means what? Look at this animation, all of you. Okay, let us suppose that box is an atom. Imagine that box is an atom and the ball which is jumping inside is electron. Okay, tell me, when the particle is big versus the particle is becoming small. Look at the animation once again. Now the particle is big and it is becoming small. As the particle size decreases, as the particle size decreases, the electrons gets confined, means congested. Congested means not free to move. Not free to move. Is that clear? Yes, clear? Okay. When the particle size decreases, the electrons will get confined, congested and not free to move, like a crowded bus. Okay, then imagine this is a bus which is very crowded. There are so many people. A crowded bus, right? Now, okay, this is a vacant bus. There is a lot of space, very few people are there. So, like a lot of space is there. Okay, A, B. Tell me, in which case you need more energy to push one person. I want to just push one person like this. Okay, in which case I need more energy to push the person. Yes, all of you? In which case I need more energy to push the person? In the case of A, here I need more energy to push. Why? Because there is no space for him to fall down. But here, if you just push like this, he will fall down. You just push the person like this, he will fall down. But here, there is no place for him to move ahead. So if you want him to fall down, you have to push him very strong. So you need more energy to push. Is it clear? So with the same example, if you understand, you will understand that, okay, when the particle size is very less, the electrons gets crowded. The electrons gets crowded, okay, means confined. So therefore you need, tell me, you need more energy or less energy to push the electron to the higher energy level? You need more energy or less energy to push the electron to the higher energy level? You need more energy to send the electron from the valence band to conduction band, and same way more energy is released, okay, when it falls back. when it falls back. Do you agree? Okay. When the particle size is very small, you need more energy to send the electron from the valence band to conduction band, and more energy is released when the electron falls back. Okay. Now look at this image. Okay, complete. Now I am like giving you the final design, final output. Okay. So here, due to quantum confinement, what happens is, due to quantum confinement, larger particles are red color, smaller particles are blue color. Did you notice? The smaller particle is blue color. The smaller particle here is blue color. The larger particle is red color. Right? Thank you so much, amiable. Done. Why like that? Why the larger particle is red color? Simple. Okay. Now let us connect all the dots. Okay. Simple point. If the size is less, then what happens? There is more quantum confinement. There is more quantum confinement. It means what? It is more crowded or congested. Because of that, what happens? More energy, okay, more energy to send electron from the valence band to the conduction band. Okay, because of that, what happens? More energy is released when the electron falls from conduction band to the valence band. So more energy is released. More energy, okay, means, okay, now you have to remember from this, in the electromagnetic spectrum, more energy is red light or violet light? More energy is red light or violet light? All of you? More energy is towards the blue side, blue, indigo, violet. So that is the reason why. More energy is, I repeat, size is less. So the electrons are more congested like this. Size is less. So the electrons are more congested like this. You need more energy to push the electron to the conduction band. More energy is released when the electron falls back. More energy means which light? More energy means blue light. That is the reason why when the size is less, smaller size, blue color light. Okay. Now exactly opposite. Okay. When the size is big, there is a lot of place. The electrons are not congested. The electrons are free to move. So you can easily, less energy is needed for the electron to go into the conduction band. So less energy is released when the electron falls back into the valence band. So less energy light means red color light is seen. So that is the reason why larger particles are seen in the red color. This concept is called as quantum confinement. Okay. So now let us check all the questions. Why the nano gold is in red color? Due to quantum confinement. Clear now? What is quantum confinement? Increase in the band gap due to the decrease in the particle size. Okay. Then what is band gap? The difference between the energy difference between valence band and conduction band. And what are valence band and conduction band? Valence band is a low energy level and conduction band is the high energy level. Okay. Then comes the question, why the larger particles are in the red color? Okay, because low energy light is released. Why smaller particles are in blue color? Because high energy light is released. That's all. Is it clear? So this is the reason why the quantum dots are in different colors. I hope it is clear for all of you. Then what are the applications of the quantum dots? After understanding quantum dots, first one, quantum dot LED, QLED TV. Okay, any of you have a QLED TV in your home or have seen it in a showroom or in a friend's home? Okay, so let us try to understand what is a QLED. Okay, why gold is in smalls. See, K. Vijay, why gold is in small size? Because we made it into that size. Okay, and atoms also, different atoms have different sizes. Is it clear? We have willingly taken the gold in the smaller size. Is it clear? Okay, and smaller size particles are not red, larger particles are red. Look at this picture. This is larger particle. Okay, means less confinement means less congested. So you need less energy to push or less energy released. Less energy means red light. Less energy light is red light in the electromagnetic spectrum. Is that clear? Okay, why nano gold is in red color? Because of this reason only. Summer, is it clear? Because nano gold is slightly larger. Okay, your doubt is when compared to bulk gold, it is smaller. When compared to bulk gold, it is smaller. But when compared to nano silver, nano copper, okay, nano aluminium, okay, nanoparticles of the other material, it is larger. Is it clear? I understood your question. Summary, is that clear? Okay, nano gold is larger, not larger than the bulk gold. You are not comparing it with the bulk gold. When compared to other nanoparticles, it is larger. Okay, nano gold is larger than other nanoparticles. Please note this important point you people raised. Nano gold is larger than some other nanoparticles and of course smaller than bulk gold. Okay, of course smaller than the comparison is not with the bulk gold. Okay, so what is quantum confinement here? Quantum confinement means, okay, like redder the light, simple point, redder the color, if larger the size, and vice versa. Is it clear? Okay, the larger it is, the redder it is. It means if it is slightly larger, then it is green. Very small, then it is blue. Much smaller, then it is violet. Is it clear? Violet one will be very small. Is that clear? Yes, correct. K. Vijay, correct. Okay, so the rule is larger the size of the particle, redder will be the color. No need of red color as such. Redder. Redder means what? Redder means in the whip jar. In the whip jar towards the red side. Okay. Redder does not mean red color as such. I mean indigo is redder than violet. I hope it is clear. Indigo is redder than violet. Blue is redder. Okay. Blue is redder than indigo. I hope you understood. Redder means what? Towards the red color. Okay. Right. So the rule is larger the size of the particle, redder will be the color. If you further reduce the size, yes, it will go to indigo color. Okay. So from this what we can understand? We can change the color by changing the size. Do you agree? We can change the color by changing the size. Means color is in our control. We can have multiple colors. I hope it is clear. We can change the color by changing the size of the particles. So it means color of the quantum particles is in our control. Tell me, how can you change the color of a quantum particle? How can you change the color of a quantum particle? By changing the... How can we change the color of a quantum particle? By changing its size. Very good. Thank you so much. Now comes the applications. In the applications, first one is QLED TV. Okay. In the QLED TV, simple. Okay. When you watch a TV, do you want bright colors and multiple colors? The more colors you have, the better resolution you will get. So therefore, in the TV screen, if we use quantum dots, then what happens? Because in the quantum dots, okay, color can be controlled. Color can be controlled or changed by changing the size of the particles. So therefore, more colors possible. More colors means better resolution. Better resolution. Okay. So bright, okay, screen. Bright, vibrant, colorful screen. That is QLED TVs. Is it clear? Next one, labeling the biological molecules. Labeling the biological molecules. Okay, for diagnostic purpose. Let me explain this. Now I am explaining this. And all of you quickly get used to the pattern in which I teach. I will put the dots and then finally connect the dots. Understand each dot, keep remembering the dots, then you will understand the final point. Is it clear? Okay. How they will change in the size? They will not change in the size, Archana. We will change it. We will change the size so that we will decide the colors. I decide the colors I want to watch. I means not the person who is watching the TV, the one who is manufacturing the TV will decide what colors you should watch in the TV. Is it clear? Qubits quantum dots are not the same, Vijay. Okay. Now coming back to this. Now I am explaining the applications of the quantum dots. First one, QLED TVs. Second application of the quantum dots, labeling in the diagnosis. Let me explain that. Labeling in the diagnosis with the example of hepatitis C. Is it clear? Okay. Right. Now, and this is a marathon session. And marathon session means, you know the meaning of the word marathon? Marathon means something which we do in the long duration. So this class will be approximately 6 to 8 hours. Even I don't know exactly how much time it will take. Around 6 to 8 hours. 8 p.m. I will give you the dinner break for approximately half an hour. Okay. And this class will run up to approximately 6 to 8 hours duration. Don't keep counting the minutes. It is an opportunity for you. Make the best use of the opportunity. Don't focus on the time. When an old lady is standing here and shouting, the younger people and energetic people comfortably sitting in your places should be much more enthusiastic than us. Right? Okay? Right. Now. So now we are discussing applications of the quantum dots. In the applications of the quantum dots, the first one is QLED TVs. Is it clear? Okay, first one is QLED TVs. And the second one, labeling in the diagnostics, I told you. Labeling in the diagnostics. So let me explain what does it mean. Labeling in the diagnostics means what? Look at here. Okay. Imagine this is a Petri dish or a glass test tube, okay, On that what we have taken is, okay, and also I have a limited color palette here, okay, and any background I take, I mean if I take white background, then also only 2-3 colors will be visible on. I can use only 2-3 darker ones. And if I take a black background, then also only 2-3 lighter colors I can use, okay. So please don't say don't use red color, don't use this color, don't use that color, because I have to show you the variation between different things. I will have to use all the colors that I have in the palette. So kindly cooperate. Okay, right. Now, let us suppose this is the hepatitis C RNA where in the patient's sample. Is that clear? In the patient's sample. Okay. It means let us suppose I got a doubt whether I have hepatitis C or not. Then I have given my sample. My sample is kept in the test tube like this. It is the RNA of that hepatitis C virus. When will my sample have the hepatitis C viral RNA? Only if I have hepatitis C infection, isn't it? If I don't have hepatitis C infection, then in my sample, the viral RNA will not be there. Why do I have viral RNA if I don't have the infection? Am I a virus? Is it clear? Understood? Now, so this is hepatitis C RNA. Then, now what we do is we take the probe. What is this? This is probe. Okay. Probe means what? Something that we use to test. Okay. Probe means investigation, testing. That is the meaning. This is also an RNA. It is also made up of an RNA which is complementary to the hepatitis C RNA. This is complementary. Complementary to the hepatitis C RNA. Is that clear? Then it will bind if I am positive. It means only if I have hepatitis C infection, then my sample will have the hepatitis C RNA. Then when we add the probe will bind to that RNA. If I don't have hepatitis C, my sample will not have hepatitis C RNA, then the probe will not bind to it. Is it clear? Then what we do is we keep, okay, nano gold particles. What are these dots? These dots are nano gold particles. Why are we using the nano gold particles? Look at here. Nano gold is used for labeling. Labeling means for visualization. For visualization. What is exactly deciding whether I have hepatitis C or not? Nano gold is not deciding whether I have hepatitis C or not. The probe is deciding. Okay, because if I have hepatitis C, then the probe will bind to it. Then why am I using the nano gold? So that I can see the result. So nano gold is used to see the result. I mean for the result to be visible. It means for the result to be visible. Is that clear? Okay. Right. For the visualization purpose, we use this nano gold. So I hope you understood this point in the applications we are discussing, like labeling biological molecules in vitro. In vitro means this is in vitro labeling. This is in vitro labeling. In vitro means what? In the laboratory or in the glassware. Okay, in the glassware, like in a test tube, something like that. I hope you understood. I don't have a place there. Okay. So in vitro means in the laboratory. In vivo means inside the living organisms. So both in vivo, in vitro, nanoparticles, I mean quantum dots can be used for labeling purpose. Okay, then interesting application, inks and polymers in the paper currency. You have 2000 rupees notes, okay, and currency notes can be made duplicate, that is counterfeit notes. How do they do the counterfeit notes? They take the color Xerox of that. When they take the color Xerox, if the counterfeit note should look natural, should look the same like the original one, then they have to use the same colors that the government used for minting the notes, isn't it? The one who is making the, if I am making the counterfeit notes, then I have to use the same colors which are used in the original note. But in the original currency note, if you use quantum dots, I told you in the quantum dots the color can be finely regulated. How to regulate the color of the quantum dots? By regulating their size. Okay, with slight increase in the size also the color changes. As I told you, the larger the particle, the redder it is. Okay, and we don't have only 7 colors like whip jar, we have thousands of millions of shades of colors you have. Okay, if you increase the particle size by just 1 atom size, okay, with that what happens? The color, the shade of it will change. Is it clear? So guessing exactly which colors the government used will become impossible for the people who are making the counterfeit notes. So the currency cannot be made duplicate, currency cannot be copied. Okay, so that is the reason why we use them. Next one, in the solar panels. So let us suppose in the space technology we use rockets and spacecrafts. For the rocket to travel, it needs fuel, and if you want to fill up more fuel in that, then the size of the vehicle increases, and we don't have such heavy vehicles. Okay, our heaviest vehicle we have is GSLV. It cannot carry like large quantities of the fuel. So we should use solar panels. You might have heard that our Chandrayaan-3's rover, okay, used solar panels. That is the reason why the Chandrayaan-3's rover slept after 14 days, because the lunar day was completed, lunar night started, so there was no sunlight, so it slept. So it means from that example it is very clear that we use solar panels in the spacecrafts or in the satellites. Is it clear? Now tell me, in a satellite when we are using, okay, Archana, I will tell you. Okay, so one small tip to better use of my class, if one term is not clear, for a moment just keep it aside and quickly keep following the next point that I am explaining. Okay, the point that you left, you can ask me a little later once I stop completing that point. Okay, then, so what I was saying, in a satellite we use solar panels. Is that clear? We use solar panels in the satellites. Why? To reduce the fuel. But can we use very large solar panels in the spacecrafts? No. Okay, so like solar panels, quantum dots are small size, so therefore they have high surface area. They have high surface area. It means what? Okay, a smaller solar panel, a smaller solar panel made up of, a smaller solar panel made up of quantum dots, okay, has more surface area. How it is possible? Just simple, look at here. If the particle size is small, okay, if the particle size is small, around 36 dots I have taken here. Okay, for the same 36 dots, I need this much large, okay, panel. I hope you understood that. Is that clear? Okay, it means if the particle size is big, you need this much size to fit 36 particles. But if the particle size is small, you need only this much size to fit the 36 particles. So therefore, this one behaves as efficiently as this one. So smaller solar panel can generate more electricity from the solar radiation. That is the reason why we can use quantum dots in the solar panels. Is that clear? Smaller panel can generate more electricity from the solar radiation. So we use quantum dots. Why? To decrease the size of the solar panel. Okay? Right. Applications in the healthcare. Applications of what? Applications of quantum dots. Okay? Applications of quantum dots in the healthcare. Antibodies attached to the carbon nanotubes are being prepared to detect the cancer cells. Okay? Let us suppose you have a cancer cell. It's a cancer cell. On the cancer cell you have a unique antigen. You have a unique antigen. It means normal cells don't have it. Is it clear? A normal cell don't have that. Only the cancer cells have it. Is it clear? Then what we do? We make an antibody for that. What is this? This is an antibody. Antibody for the unique antigen. Okay. So now tell me, if the antibody is bound to the cells, okay, you have injected this antibody into a patient. If the antibody is bound to a cell, what does it mean? It means that that antigen is present. It means that cancer is there. It means that the person is suffering from cancer. Because only cancer cells have this antigen. Do you agree with this? I repeat, I injected these antibodies. Look at here. I injected these antibodies into a person, into a human being's body, or into a sample. Is it clear? Into a test sample. I have added these antibodies. If the antibodies are bound to the cells, what does it mean? It means that the person is suffering from the cancer. How can you say that? Because only cancer cells have that antigen. Normal cells do not have. So it means this antibody can bind only if the person is having cancer. Okay. The antibody is bound to the antigen. Okay, cancer is there. But how to know, listen this carefully, how to know whether the antibody is bound to the cancer cell or not? So we use nano gold. We use nano gold for visualization, okay, or to see the result. Is it clear? That is labeling. That is labeling. Okay. So now look at this. Antibodies attached to the carbon nanotubes are being prepared to detect the cancer cells in the bloodstream. Okay. Nanoparticles are used to deliver the drugs, radiation and light emitting substances. Okay, this point I have already explained, that EPR effect, if you remember, enhanced permeability and retention effect. Okay, nanoparticles are used to deliver the drug to the cancer cell, but not only the drug. Okay, that can also be, I said that it is a cancer drug, but it can also be a radiation emitting substance, a radiation emitting substance, or a light emitting substance. Okay. So, radiation emitting substance means what? See, for the cancer, we have two types of therapies. Okay, radiotherapy, chemotherapy. If you want to do the chemotherapy, then package the cancer drug. If you want to do chemotherapy, then package the cancer drug into the carbon nanotubes. If you want to do radiotherapy, radiotherapy means what? Okay, radiation, burning the cancer cells with radiation. Which radiation we use for that purpose? We use gamma rays for that purpose. If you remember the electromagnetic spectrum, highest frequency, highest energy radiations are gamma rays. Only gamma rays have that much energy to kill a cell. Okay, so tell me, what are the radiations used in the cancer therapy, cancer radiotherapy? Everybody? What are the radiations used in the cancer radiotherapy? Very good, gamma rays. Okay, so here what you do is you package, what is this? This is a gamma rays emitting substance. A substance that emits gamma rays. A substance that emits gamma rays. Is that clear? So, the carbon nanotubes will take them inside. The carbon nanotubes will take it inside. So, inside the cancer cell, it will emit the gamma rays. Inside the cancer cell, it will emit the gamma rays. Okay, then the cancer cell will die. Eventually, the cancer cell will die. So, not only are the nanoparticles used only to deliver the cancer drug? No, you can deliver cancer drug or radiation emitting substances or light emitting substances, any of them, to kill the cancer cells. Okay, normal cells also will take them up, but in lesser quantities, and moreover they can push them out. So therefore selectively the cancer cells will die, whereas the normal healthy cells will survive. Okay, I remind you, we are discussing the applications of the quantum dots, applications of the quantum particles in general. Okay, so nanoparticles are used, okay, to deliver the drugs, radiation and light emitting substances to specific type of cells such as cancer cells. Is it clear? Nanoparticles based gene delivery systems also. Okay, in our another marathon session where I discussed biotechnology, I spoke about the GM crops, genetically modified crops, and the gene therapy. For gene therapy, genetically modified crops, you have to send a gene into a cell. Is it clear? It means we can pack gene in the carbon nanotubes. Okay, we can pack the gene in the carbon nanotubes and deliver to a particular cell. Is that clear? Deliver to a particular cell, right? Next, nano robots can be programmed to do the surgeries. Okay, these days using artificial intelligence and nanotechnology, we can do precise surgeries. It means even a skilled surgeon, okay, slightly the hand can shiver, slightly a small jerk can sometimes lead to the death of the person also in certain minute surgeries. So we can use nano robots which are controlled by artificial intelligence to do these surgeries. This kind of nano robots can be of two types. First one, controlled robots. Controlled robots means, okay, I send a nano robot into the body. And I will keep controlling this nano robot from outside. How? Using the remote controllers, using Bluetooth, remote controllers, okay, using different methods we can control it. Means from outside I am controlling how the nano robot is moving inside the patient's body. Okay, they are instructed from outside and relay the information to the cell. Okay, example, PillCam by Medtronic company. A company called as Medtronic made a PillCam. What is PillCam? Did you hear about endoscopy? Endoscopy colonoscopy. Okay. Colonoscopy means what? Sometimes our large intestine may have some piles, fistulas or tumors or cancers or something. So we have to see that. How we will do? We send a tube from the anus, okay, to see that. At the end of the tube they will attach a small tube. At the end of it they will attach a camera. Okay. If they want to see if there is any ulcer or a tumor inside the stomach or esophagus, they will put that tube into the mouth. Both are painful and very frustrating tests. Do you agree with this? Imagine sending a tube into your mouth, then esophagus, stomach, like that till here. It is very painful, isn't it? So, that is a difficult test. Simple solution is a pill cam. Pill cam means what? It is a small camera, just like your tablet, only this much sized substance, like a tablet, like a capsule. Like you take some Dolo 650, you will just take that camera into your mouth and drink some water, just the way you take a tablet, Then that pill cam will travel from the mouth and come out through the anus. Is it clear? It means what? While it is traveling throughout your alimentary canal, it is video recording what is happening inside your alimentary canal, in your mouth, esophagus, stomach, small intestine, large intestine. If there are any ulcers, tumors or any changes, that can be recorded by this. So not painful. It's just like taking a tablet. How it is possible? Using the nanoparticles. Means we use same material but in the smaller size range. We use same material but in the smaller size range. Is it clear? And the other type of robots are autonomous robots. These are artificial intelligence, AI powered. They take their own decisions. They know what to do. You don't have to control them from outside. I repeat, nano robots, simple small sized robots. How to make small sized robots? Using nano material. Is it clear? What are the types of nano robots? Two: controlled robots, uncontrolled autonomous robots. Controlled robots, we are controlling their movement from outside using the remotes. And autonomous robots, they are AI powered, they are capable of taking the decision. So they know what to do inside. You don't have to keep giving commands to it. You don't have to control them outside. So these are nano robots. Hepatitis C diagnosis, I have already explained. Right? Next application is hepatitis C diagnosis. Is hepatitis C diagnosis clear? If the person is having hepatitis C, then the person's sample will have the hepatitis C RNA. Then when we attach a probe, the probe will bind to that. The probe will bind, but we cannot see because the probe is also RNA and the hepatitis C genetic material is also RNA. They both are transparent. So we use nano gold particles to see the result. This is how we use nanoparticles in the hepatitis C diagnosis. So should we use it only in the hepatitis C diagnosis? No, we can also use it in the COVID, in the coronavirus RNA. If my sample is having coronavirus RNA, what does it mean? I am COVID positive. If I am COVID positive, my sample will have the coronavirus RNA. Then we add a specific probe to that, which is labeled with the nano gold, so that you can see whether I have COVID-19 or not. This test is much faster than the RT-PCR test. Within a few minutes, within some 10 minutes, you can give the result. Similar test, it is written here, like similar test developed for COVID-19 as well. Is that clear? Then nanoparticle based vaccines. First of all, what do you mean by a vaccine? For example, if I have to give a measles vaccine, Will the vaccine contain a medicine for the measles virus, or the vaccine contain the measles virus itself? Everybody please. Will the vaccine contain a medicine for the virus or the virus itself? The virus itself, right? Okay, so that it means what? What is vaccination? You are showing that virus to your body. Exactly. For example, some COVID-19, it is a new virus. I don't have antibodies for it. It means I don't have defense molecules to kill that. Okay. And if the virus really comes into my body, I don't have time to manufacture that defense vehicles. Is it clear? Right. So therefore, I should be ready with the weapons before the war is declared. So therefore, what I will do is, I will inject a small sample of that coronavirus so that my body will produce the antibodies. Then if the virus really comes, I will be ready to fight. That is a concept of the vaccination. More clearly, I explained in the biotechnology marathon. By any chance, if you people missed it, do watch it without fail. Okay. Now, so in that vaccination, obviously, if I inject the complete coronavirus, I don't know whether I will really get the coronavirus infection or not. But the vaccine will cause infection in my body in the name of vaccination. If I really inject the coronavirus, it is dangerous. So what we do? We inject a dead virus or inactivated virus or a subunit. Subunit means what? Only one part of it. Okay, or only the genetic material in that. It means we don't take the complete. A virus will have a protein coat and the genetic material inside. Okay, so we don't take the virus, we take only the genetic material. That is called mRNA vaccine. Okay, now look at here. This is a nano. What is this? This is a lipid nanoparticle. Lipid nanoparticle. And what is there inside? Okay, inside this you have, it's a lipid nanoparticle, and inside the lipid nanoparticle you have the coronaviral mRNA. So this is nothing but an mRNA vaccine. Is that clear? What is this? This is an mRNA It is an mRNA vaccine. Okay. Coronavirus mRNA. I want to inject. But how do I inject? mRNA is very delicate. If I directly inject it, it will be degraded in my body. So I will package it inside a lipid nanoparticle. Lipid nanoparticle means nanoparticles made up of lipids. Lipids means fat, like a fat bubble. Inside that I am packaging this mRNA and then injecting it. Is it clear? So all of you tell me, why I don't inject that mRNA directly into the body? Why don't I inject that mRNA directly into the human body? Because the mRNA is very fragile, very delicate. So I will package that mRNA in a lipid nanoparticle. Lipid nanoparticle means nanoparticle made up of the lipids, that is fat. Is it clear? Okay. And this is an example for the vaccinations. We can use this in the vaccine manufacture. Is that clear? Right. Very good. Next, HIV drug combination efficacy enhancer. Okay. Let me explain this. Okay. Look at here. Imagine this is a HIV infected cell. Okay. What is this? HIV infected cell is having nanoparticles used at commercial level. No, nanoparticles used at the commercial level for testing also. Okay. Summer, this testing is not like our Bhavini reactor testing or some like NGLV, new generation launch vehicle testing. Okay, not that testing. This is diagnosis. We do diagnosis also at the commercial level. So, summer you asked me, is it used for testing or at the commercial level? My answer is, it is used for the testing at the commercial level. It means we do diagnosis in the commercial diagnostic laboratories. Okay, so they take money from you and tell you the result, whether you have COVID-19 or not, whether you have hepatitis or not. Is it clear? So they are used at the commercial level, right? Then, now coming back to this, HIV, drug combination efficacy enhancer, and I am explaining it, what it is. Okay, it is a HIV infected cell. Are you all following? Then, on this HIV infected cell, there is something called as lactoferrin. Lactoferrin receptor. Lactoferrin receptor. Whereas normal cells do not have it. Is that clear? A normal cell do not, no lactoferrin receptor. Is it clear? Okay. Now what you do is, okay, complete focus here. Okay, what is this? This is lactoferrin nanoparticles. What are they? They are lactoferrin nanoparticles. Okay, and what I am keeping inside that? The HIV drug. Inside this, what I kept? This is nothing but the HIV drug. Okay, now tell me, I packaged the HIV drug in the lactoferrin nanoparticles. Lactoferrin nanoparticles means what? Nanoparticles made up of a substance called lactoferrin. What is lactoferrin? Is immaterial for us. That is a name of a substance. Is it clear? I made nanoparticles with lactoferrin. So can I make a nanoparticle with anything? Yes, I can make a nanoparticle with any substance. Okay. So nanoparticle is just about the size of it. Okay. It is not about the properties of it. Any substance in the world I can make nanoparticles with that. So I made nanoparticles with lactoferrin. Inside that I kept the HIV drug. So now tell me, this HIV drug packaged inside the lactoferrin, okay, will it bind to the normal cells? Cells which are not infected with HIV? Yes, everybody? Can the HIV drug packaged inside the lactoferrin nanoparticles go into the normal cells? No. Okay, can they go into the HIV infected cell? Yes. Okay, means instead of using the HIV drug normally, if you package the HIV drug inside the lactoferrin receptors, its efficacy will be enhanced. The drug's efficiency will be enhanced. Okay, so answer this question all of you. HIV drug loose. Okay, this is HIV drug. HIV drug, but it is loose. Loose means not in the nanoparticles versus the HIV drug in the nanoparticles. Okay, in which case the HIV drug is more efficient? In which case efficiency of the drug is more? When you package it inside the lactoferrin nanoparticles. So this is a HIV drug combination efficacy enhancer. Efficacy enhancer. Lactoferrin receptor will enhance the efficiency of the HIV drug. I hope it is clear. Next, solve this question. This is a previous year question from the year 2015. It's a question from 2015. Solve this. What kind of questions you can get from nanotechnology? With reference to the use of nanotechnology in the health sector, which of the following statements are correct? Okay, first, tell me whether the first statement is correct or not. targeted drug delivery is possible? Yes. Example HIV and that lactoferrin. Nanoparticles as carriers. Okay. Next, nanotechnology largely contributed to gene therapy? Yes. Okay. The gene can be packaged. The gene can be packaged inside the nanoparticles to deliver into a specific cell. To deliver into a specific cell. So 1 and 2 both are correct. C is the right answer. Is that clear? Then next, applications in the energy sector. Applications of the nanotechnology in the energy sector. Okay. Superconducting carbon nanotubes as cables for energy distribution. Tell me, in general in the electrical wires what we use? We use copper. In electric wires, right? But the problem with this is copper is a very soft metal, okay, which is not strong enough. So therefore, in the case of heavy winds, rain, the electrical wires can be broken and can lead to accidents, lead to the death of some people and all that. It can fall on the people, it can fall on the vehicles, can lead to electrocution, etc. Okay. So, in the place of copper, if you use carbon nanotubes as electrical wires, remember they are 100 times stronger than, not copper, 100 times stronger than steel. Okay, and have more conductivity than copper. More conductivity than copper. Stronger than steel, conductive than copper. So, best material to make the electrical wires. Okay, next. In the solar panels, which I already told you, why do we use quantum particles in the solar panels? To decrease their size. To decrease their size. Next, nanomaterials can improve the capacity and safety of the lithium-ion batteries. Okay, now let me explain the lithium-ion batteries first. Okay. Okay. In a lithium-ion battery, we use normal lithium-ion battery uses graphite as anode. Okay. In a lithium-ion battery, the lithium ions will move between, okay, anode and cathode. Between them, the lithium ions will keep moving between the cathode and anode. In a regular lithium-ion battery, we use graphite as the anode. But in the place of graphite, if you replace the graphite with graphene, then what is the advantage? You can have much sleek cell phones or TVs or tablets, okay, or lightweight. Where do we use lithium-ion batteries? We use lithium-ion batteries in the cell phones, laptops, okay, tablets, electrical vehicles and all of them. So all of them can be much smaller. For example, okay, if your your EV car is giving you some 200 kilometers mileage per one battery charging. Okay. Now what you can do, if you use the graphene in the place of graphite in that battery, your car battery, if you use graphene in the place of graphite, then what happens? Small battery can work like a big battery. Is it clear? So even a small battery can give you more mileage. In the place of graphite, if you use graphene with the same sized battery, you can travel for 500 kilometers. Is the difference clear? Okay. So you can make lighter vehicles. Okay, you can make lighter vehicles that gives more mileage. Okay, you can have much sleeker cell phone. I mean, in future the cell phones will be like this. In future the cell phone will be as sleek as a paper. Okay, why? Because what gives a thickness to a mobile? Thickness is also because of the battery inside. If the battery thickness can be reduced, the mobile phone's thickness also can be reduced. Is it clear? Okay. So that is how we can use lithium ion batteries in the cell phones, laptops, tablets, electrical vehicles. Basically, what are lithium ion batteries? Lithium ion batteries are nothing but the rechargeable batteries. Chargeable batteries. Is that clear? Okay. I repeat, lithium ion batteries are nothing but rechargeable batteries. We use them in mobile phones, tablets, laptops, electrical vehicles and all. In all of them, we have a anode and a cathode. The lithium ions will be moving between the anode and cathode when we charge them and discharge them. Okay, and usually in a regular lithium ion battery, the anode material is graphite. Instead of graphite, which is a bulk material, if we use graphene, which is a nano material, then the battery size reduces. So small sized battery, a thin battery can give you more lifetime. Okay, so more mileage or more time you can use the mobile phone with one charging, like that. Okay, so that is in the lithium ion batteries. Next one. Okay, scientists in IIT Kharagpur made piezoelectric nano generators. What do you mean by piezoelectric? Piezoelectric means generating electricity through movements. Okay, it means, let us suppose I am using a mic here. Imagine inside this mic, if I keep the piezoelectric material, then what it can do? It can use the vibrations of my thought. I am shouting like this. So vibrations will be there. This vibrations, this movement, this mechanical energy is converted into the electrical energy. Is it clear? They can convert the movements such as walking, speaking, swallowing, etc. From this movements, I mean when mechanical stress is applied, that can be converted into electricity. Such material are called as piezoelectric. Small sized piezoelectric generator can be kept in the collar mic, so that as I speak, I will be generating electricity. Is it clear? Okay. Yes, Devendra. Okay. Then moving on to the applications of nanotechnology in the agriculture sector. Applications of nanotechnology in the agriculture sector. Okay. See, at 6:10, I will give you the first break. Okay, I will give you the first break, but this is only 10 minutes duration. Okay, then again at 8:10 I will give you, okay, around at 8:10 I will give you the second break. For this is around 20 minutes duration till 8:30 or so. Okay, I will give you the second break. So in 10 more minutes you will get the second break. And after the break, we will be covering the space technology. Okay, after the break, we will be covering space technology. Of course, nanotechnology will not be completed in 10 more minutes. We may slightly continue with the nanotechnology, but briefly we will shift to the space technology. That is the plan. Okay, then applications in agriculture, pesticides. Nano encapsulated slow release fertilizers and pesticides. Simple. Okay, what is this? This is a nanoparticle. Nanoparticle. And what am I keeping inside? Inside what I am keeping is either a fertilizer fertilizer or a pesticide. Because of that, what happens? They will be slowly released. They will be slowly released. Okay, like for example, when you get some infection, when you take a capsule, the drug inside the capsule will be slowly released after going into your body. So same way, these pesticides and fertilizers will be slowly released in the soil, slowly released into the soil. What is the advantage because of this? Lesser amount of the pesticide, okay, or fertilizer, okay, can be effectively used. Is it clear? I mean, instead of like can be used. I hope it is clear. Okay, if I directly use the pesticides or fertilizers, I have to use them in higher quantity. But if I package them into the nanoparticles, then they will be slowly released into the soil. So therefore, even lesser quantities of the fertilizers and pesticides, you can do the agriculture. So what is the advantage of this? We can reduce the soil pollution. We can reduce the soil pollution. Okay, next one, sensors. Okay, around 10-15 minutes back, like one of you were asking me, ma'am, what are the sensors? Is it clear? Let me explain what is the meaning of the word sensor. Okay, sensor is something which is used to sense. Sense means detect. Okay, I'm capable of sensing it. I can sense that the temperature is low. I can sense that there is humidity here. I can sense that there is hepatitis C RNA here. I can sense that there is COVID-19 RNA in this. Is it clear? Sensing something means detecting something. Okay, so now tell me, is it a sensor? I mean, is this probe a sensor? Everybody, especially who got that doubt, I'm using a probe to detect if hepatitis C RNA is present or not, or to detect if coronavirus RNA is there or not. So is this probe a sensor? Yes, everybody? That probe is nothing but a sensor or the probe. Is it clear? Okay. And what do you mean by biochemical sensing? Okay. Biochemical sensor. Biochemical sensor means if a biochemical, okay, biochemical means what? It is chemical and also biological. I mean, it is there in the living organisms and it is a chemical substance. Like for example, a protein or an antibody or an enzyme. Okay. Antibody or an enzyme can be called as a biochemical sensor. Tell me, in this hepatitis C or the COVID-19 case, what is it a biochemical sensor? The probe is a sensor. Why the probe is a sensor? Because it is sensing whether the hepatitis C RNA is present or not. And the probe is also a biochemical sensor because it is an RNA. RNA, ribonucleic acid. It is basically an acid. It is a chemical. And it is a chemical in the living organism. So it is a biochemical substance which is used as a sensor. That is nothing but biochemical sensor. Is the word biochemical sensor clear? Okay. Now, nanosensors can monitor the plant's growth, nutrients, pest, soil conditions, etc. Just like that probe is sensing whether the hepatitis C virus is there or not, same way, some biochemical sensors can sense if a plant is infected with a pathogen or not, if a plant is infected with a pest or not, if a plant is having sufficient nutrients or not, if the soil is having some pollutants or not, all these things also can be sensed or detected using the nanoparticles. Is it clear? When certain nanoparticles, I am repeating, when certain nanoparticles are used in the agriculture, they can sense or detect if the soil is having a particular nutrient or not, or a particular pollutant or not, or if the plant is having a particular pathogen or not, if the plant is infected by a particular pathogen or not. Okay, so these kind of things can be sensed or detected in the agriculture. Next, food processing also, we can use nanotechnology in the food processing. Okay, edible nano coatings, then you may get surprised, do we have edible nanomaterial also? Of course. Nanomaterial is not about what is the material. Nanomaterial is only about what is the size of the material. Any material can be made into nanoparticles. Remember that point. Is it clear? Okay, so what you can do is nano-sized coatings on the food. Like for example, on the fruits, apple you have. On the apples you can give a coating with a nanomaterial. Because of this, what happens? The apple looks bright color, or because of this nano coating, it will act as a protective layer on the apple so that the apple's shelf life can be increased. Okay, same way you have some soft fruits like tomatoes, mangoes, etc. A mango is a soft fruit. If you give a nanomaterial coating on that mango, then the mango looks bright yellow color. On the top of it, the shelf life of the mango increases. The mango will remain hard. Is that clear? You can also give that nanomaterial coating on vegetables, on meat products, on the fish. Why do we use? For two reasons. One, to increase the shelf life. Two, okay, to make them look attractive. Is it clear? The apple looks much brighter red color, meat looks much bright red color, vegetables look much bright yellow color or so, like that. Also to extend their shelf life. Next one, plant stress tolerance. It means nanomaterial can promote the stress tolerance by stimulating the detoxification pathways. Okay, I hope this is clear. Now focus on this point. Okay, here what they can do, nanoparticles trigger detoxification, means they trigger, okay, the process of sending out the toxins. The process of sending out the toxins. Is it clear? So, for example, I have some toxins inside my body and I am sending them out. Okay, it means what? My stress levels will decrease. Stress is not only the psychological stress we take. Okay, any toxins in our body is also a type of a stress. Is it clear? Okay, so by sending these toxins out, it is nothing but stress tolerance. Stress tolerance increases. I repeat, when we use certain nanoparticles in the agriculture, then they will trigger the detoxification pathway in the plant. Now the plant will get detoxified. The detoxified plant is stress tolerant. It can tolerate the stress better. Is that clear? What is detoxification? Archana, I explained it now. Okay, the process of sending out the toxins. Toxins ko bahar bhejna. Okay, the process of sending out the toxins. Is it clear? Next, gene transfer in the GM crops, I already told you. Nanoparticle based gene delivery can be used to make the GM crops. Genetically modified crops. For example, we have BT cotton. For that, we have to add a gene called CRY1AC. How do I send this gene called CRY1AC into the cotton plant? Using the nanoparticles as carriers. Okay, we use nanoparticles as carriers to transfer a gene to a particular plant cell so that that plant can be converted into a genetically modified plant or genetically modified crop. Is that clear? Any doubt till this point? Gene delivery, look at here. These are the nanoparticles, isn't it? What is this? Nanoparticles. On that what we have done? The DNA is added. DNA. What is that DNA? Gene. The gene is added on to the nanoparticle and that nanoparticle goes in. It means the gene goes into the plant cell. Now the plant cell is a genetically modified. Is it clear? Now this is a genetically modified plant. Is that clear? This is a genetically modified crop. Done. Next one, nano urea. Same, simple, urea only. Take urea, make fine particles with that. I told you already, you can make nanoparticles with any substance. Make the nanoparticles with urea here. Okay, it is essentially the liquid urea in the form of nanoparticles. Normal urea is in the form of granules and we put the granules into the soil. But here it is nanoparticles urea in the form of a liquid. This liquid is directly sprayed on the leaves and it gives 30 to 50% more yield when compared to the normal urea. Okay, when you use nano urea, the crop yield will be 50% more compared to the case when we use normal urea. Is it clear? And also it is much cheaper. Benefits, it improves the yield. Soil health is also better because you can reduce the urea content. Is it clear? Okay, and it has also been tested for biosafety. Nano urea is safe for the human beings and the other organisms and also reduces the import cost of urea. It means half liter bottle of nano urea, half liter bottle of nano urea is equal to some approximately 100 kgs bag of normal urea. Okay, so when you put 100 kgs urea into the soil, you are contaminating the soil, you are polluting the soil. But when we use nano urea, lesser urea can give more yield. Okay, and it is less costly, it is cheaper when compared to the regular urea. Nano urea is cheaper compared to the regular urea. Okay, then next, with that we completed applications of nanotechnology in the health sector, applications of nanotechnology in the agriculture sector. Next we have to see applications in the electronic sector. Actually 3 completed: health, energy sector, agriculture sector. We completed the applications of nanotechnology in 3 sectors. 4th sector is electronic sector, that we will continue after a small break. Okay, so let us meet again at 6:25, right? And take a small break, come back with much more energy levels and much more focus levels. Thank you. తెలుసు ఇది
రెండిట్లో వస్తుందో లేదో చూసుకోలేదు ఒకసారి మళ్ళీ చెక్ చేయండి అట్లాగా.
You're able to hear me? Summer, after this I will do the space technology, then we will go to the defense technology. Right. Hope my audio video is clear. Okay. Now let us see applications in the electronics sector. Okay. In the electronics, we can use nanotechnology for drastic reduction in the size. As I already told you, like we can use the battery size. For example, lithium ion batteries. Lithium ion batteries that are smaller. When we use that, we can make much sleek or slim cell phones or TV screens, right? Okay. Same way, nano transistors, nanomaterial used in the processor, nanomaterial used in the hard disk, storage devices like hard disk. Okay. So, nanomaterial used in the phones, computers, in their processors, transistors, storage devices, batteries. In all these things, if we use nanomaterial, size of the electronic goods will reduce. That is the application. Is it clear? Next. Researchers at Stanford University made an OLED TV with graphene as a transparent electrode. Okay. Then you may ask me, what is the difference between OLED and LED TV, right? I will give you 2-3 different concepts here. Look at here and keep responding. First, I am telling you what is an LED. LED means what? Light emitting diode. It means two electrodes. What are they? Cathode, anode. Is it clear? Now if you observe, look at here, what is this? This is cathode. Tell me, what is that? Cathode. And this is graphene. What is this? This is anode. We are using graphene as anode. Is that clear for all of you? Okay. And now, what is a light emitting diode? Okay, it will LED emits light, therefore it is called light emitting. Okay, when an electric current, it emits light in response to an electric current. Okay, when an electric current flows between the two electrodes. Is it clear? You have a cathode here, you have an anode here. Between the cathode and anode, if an electric current is applied, then it will emit the light. That is called light emitting diode. Is LED clear? Is LED clear? Right. I repeat, you have a cathode here, you have an anode here, and it is a diode. It is a light emitting diode. It emits light when an electric current is applied between the two electrodes. That is called a light emitting diode. Okay. Now let us suppose here in the place of graphene, if I use graphite, okay, is it a LED TV with nanotechnology or normal LED TV? Yes, instead of graphene, look at here, instead of graphene, if I use graphite as anode, is it a LED TV with nanotechnology or normal LED? A normal LED. A normal LED uses graphite as anode, whereas LED with nanotechnology, LED with nanotechnology uses graphene as anode. Is that clear? So tell me, that is a normal LED. Then in an LED you will have some light emitting layer between the two electrodes, light emitting diode. You have a light emitting, what is there here? Light emitting layer between the two anodes. Okay. If that light emitting layer is an organic material, then it is called OLED. Is it clear? Okay. So if the light emitting layer between the two electrodes is an organic material, then it is OLED. Is that clear? What is OLED? Between the two electrodes there is a light emitting substance. If the light emitting layer is an organic material, then it is called OLED. Is that clear? And what do you mean by an organic material? Organic material means, keep responding so that I will know whether you are following or not. Just keep responding, keep saying yes, no, something. Okay. So what is an organic material? Organic material is something which is made up of carbon and hydrogen. Okay. Any material which is made up of carbon and hydrogen. Now I will ask you a few questions. Answer these questions. Okay. Now here I am not using the organic material. I am using a normal material, not organic material. Okay. Not an organic material. Is that clear? And I am not using graphene here. I am using graphite. Then what kind of a TV is it? Okay, three options. OLED with, think and answer, no hurry. OLED with nanotechnology, or normal LED with nanotechnology, or normal LED without nanotechnology. A or B or C. OLED with nanotechnology, normal LED with nanotechnology, normal LED without nanotechnology. A or B or C. Everybody please. Right. That is normal LED without nanotechnology. Now look at here. Now look at this. I am using organic light emitting layer. I am using organic light emitting layer. Now tell me, is it okay OLED with nanotechnology, OLED without nanotechnology, or normal LED without nanotechnology? It is OLED organic light emitting diode TV, OLED TV, but no nanotechnology. Is that clear? Now look at here. I am using organic light emitting layer. It will make it OLED, organic light emitting diode. And I am using graphene here, means with nanotechnology. Is it clear? Now, okay, I am using organic light emitting diode and I am using graphene as the anode, not graphite. I am using graphene as the anode. In that case, it is OLED with nanotechnology. Is that clear? And this type of screen will be very thin screen. Okay, you can even have a television screen like a curtain. You can just roll it up, just like a paper thin, like a curtain, just like a blanket, like foldable, flexible, very thin. TVs are possible with this in future. Okay, at present we don't have such blanket like TVs which you can fold and keep aside, but in future we can also get televisions like this, phones like this. Okay, so this is the role of nanotechnology in the electronics. Okay, nanotechnology in the electronics, what all we have seen? Reduction in the size. How? Battery size can be reduced, transistor size, processor size can be reduced, storage devices like hard disk size can be reduced. Is it clear? And by using the like graphene in the place of graphite, LED screen thickness can be reduced and much flexible. Graphene is very flexible also. Flexible, very hard, lightweight, very thin screens are possible for the cell phones and TVs. Okay, this kind of cell phones and TVs are possible. Clear for all of you? Next. With that, we completed applications of nanotechnology in the electronic sector. Health, agriculture, energy, electronics completed. Now let us see applications of nanotechnology in the textile industry. Applications of nanotechnology in the textile industry. Can we proceed? Okay. What we can do is, number one, we can take any, if you remember I told you that in nanotechnology the substance doesn't matter, we can use any substance, size matters. So take a water repellent substance, means hydrophobic substance, water hating substance. Make it into nanoparticle size. Give a coating to the water. Then what happens? Look at that. Look at this animation. Waterproof shoes. Why? Okay, a water repellent material is used to coat that shoes. It is an invisible coating. Can you see that coating on that shoes? You cannot see the coating because it is nanometer size range, but it will give water repellence. It means a cotton shirt I can wear. On that, if I give a coating of water repellent material, then a cotton shirt will act like a raincoat. Okay, it will repel the water. I will not get wet inside that shirt. Is that clear for all of you? Keep responding, please. Done? Okay. So in the textile industry, water repellence. Next one, anti-static properties. What is anti-static property? Keep responding, please. Anti-static property means what? You know, static electricity. Like in the winter season, when you comb the hair will stand up like this. Or sometimes when you touch something, you will suddenly feel as if you got an electric shock, a small shock. That is because of the static electricity. Okay. Then especially silk cloth will give the static electricity, silk, plastic, etc. So now on a silk dress, you can give a nano coating with the anti-static material. The material which do not have the static electricity. Take such a material, make nanoparticles out of it, use it as a coating, then that silk cloth will not give you that electric shock. It will be comfortable to wear. Done? Clear? Then wrinkle resistance. Okay, some cotton cloths, what is the problem with the cotton? It will get easily wrinkled. Okay, then give a nano coating so that it will not get wrinkled. Is it clear? Give a nano coating on that so that it will not get wrinkled. Next, strength enhancement. Imagine you give a graphene coating, okay, carbon nanotube coating on a cotton shirt. And these nanomaterials are very strong, isn't it? So therefore your cloths, your shirt's strength also increases. Your shirt will not be easily torn. Okay, strength enhancement for your clothes. Is it clear? Next one, in the computing also we can use that. Okay, computing how? I'll show you. This is called smart shirt. Okay, this is called smart shirt. This smart shirt is woven with carbon nanotubes. Okay, it is woven with carbon nanotubes. Why this is used? This is used to constantly monitor the ECG, electrocardiogram. Okay, ECG. Normally, like if we get any doubt about how healthy our heart is, heart functioning, we will get a ECG done. Okay, for that ECG it will take some 10-15 minutes. But if there is a heart patient, sometimes what happens is in that 10 minutes the heart is working normally, but maybe in the other timings the heart is not working well. So sometimes the doctor recommended 24-hour ECG monitoring. So can the patient sleep on that bed for 24 hours? It is difficult. So if he wears this smart shirt which is woven with the carbon nanotubes, okay, what they will do? They will give the ECG signals, they will send it to a nearby monitor. I can wear that smart shirt so that I can keep moving in the room. Okay, these carbon nanotubes will keep giving this ECG signals to a nearby monitor in the room. Is it clear? So like this, in the textile, in the computing also we can use nanotechnology. Carbon nanotubes can be used in the smart shirts. Is that clear? Then antibacterial odor control. I mean this nanomaterial, some nanomaterial will have antibacterial properties. Is it clear? Certain nanomaterial like nano silver can kill the bacteria. Okay, it means these clothes you need not wash. Okay, this type of clothes you need not wash because they have nanomaterial that can kill the bacteria. It means they will never smell bad even if you do not wash. Okay, and then optical displays. If you observe the optical displays, it means, for example, I have a handbag. I want my handbag to have bright colors so that I can use quantum dots in that. Quantum dots. Already I explained how quantum dots can give bright colors. Okay, so that is how bright colors bags, bright colored clothes are possible. These are the applications of nanotechnology in the textile industry. Done? Then now moving on to nanoparticles can be used in the sports. Nanotechnology in the sports. Lighter, stronger, more durable bicycles, tennis rackets can be made because lightweight and stronger. For example, if you use carbon nanotubes, graphene in the racket, then what happens? The tennis racket will be much lightweight and much stronger. Okay, stronger lightweight bicycles can be made. Silica nanoparticles can be used in the running shoe to improve the comfort and stability. Okay, nanotechnology can create fabrics that can repel the water. See, sportsmen when they run fast, okay, they will sweat more. So water repellent clothes like this, I have already shown the water repellents. Water repellent shirts will make them feel comfortable. Is it clear? So that they won't get wet with their sweat. Okay. Prevent mold and bacterial growth and eliminate the bad smell from the sportsman's clothes. Okay. Same way nanomaterial can be used in the protective gear. That is, for example, you are you're doing some sports biking, okay, race, okay, sports racing cars, okay, and you are prone to accidents. So then you have to wear a protective gear. In that protective gear, if we use nanomaterial are very hard, okay, like graphene can be used in that, it is very hard, so that okay, you will not get easily injured. Nanotechnology can be used to make flexible, lightweight, wearable devices like smart watches and all. Okay, drug delivery can be improved, so that how drug delivery is related to sports. Sportsmen will get injured, so they should quickly recover because next match can be there. So for a quick recovery, the drugs must be working very efficiently. So for the effective usage of the drugs, they can be delivered using the nanoparticles. Okay, is the connection clear? Next. Okay, then applications in the defense sector, like for example, Baba Kavach. Look at this. This is called Baba Kavach. Okay, this Baba Kavach is made using the extremely hard boron carbide ceramics. This boron carbide ceramics is the nanoparticles. They are hard pressed with carbon nanotubes. Okay, boron carbide ceramics hot pressed with carbon nanotubes and composite polymer. Okay, this is the material used to make that Baba Kavach. Okay, and that is much lightweight. Okay, Baba Kavach is like much lightweight and very hard. Okay, it is designed to protect our soldiers even against AK-47 hard steel bullets. Okay, and they are much cheaper and lightweight and much stronger. Okay, lightweight means if a normal bulletproof jacket is 17 kgs, a normal jacket is 17 kgs, whereas Baba Kavach is only 8 kgs. Okay, so for the soldiers it will be much more comfortable, convenient. Okay, because lightweight and also much stronger. A normal bulletproof jacket may not protect the soldiers from the AK-47 bullets, but the Baba Kavach can protect them from the AK-47 bullets. So lightweight, much more stronger, means much safer for the soldiers, plus cheaper, almost 50% the cost. Okay, so that is the advantage of Baba Kavach. Okay, then here I have given summary. Okay, this is not a new content. I have given summary of the graphene, carbon nanotubes, quantum dots, quantum gold particles, okay, gold nanoparticles, silver nanoparticles and their applications. Only silver nanoparticles we did not discuss before, so let us check what is given here. Silver nanoparticles are strong antimicrobial properties. I already told you silver nanoparticles can kill the bacteria. So when we use silver nanoparticles coating on my shirt, then what happens? The silver nanoparticles can kill the bacteria. So bad smell will not come from the shirt. You don't have to wash the clothes. Is that clear? Okay, antimicrobial properties, also high surface reactivity, antibacterial coatings, wound dressing. We can use nano silver in the wound dressing. For example, I get a wound and you do the dressing with a bandage. In that bandage, if we use nano silver, then the wound healing process will be faster. I repeat, I got injured and you will use a bandage for the dressing purpose, And in that, if we use nano silver particles, because they have antibacterial coatings, in the wound dressing, the wound healing will be faster. In the textiles, when we use nano silver, they are odor resistant. We will not get bad smell from that dress. We don't have to wash them frequently. Okay, and we can also use them in the water purifiers, water filters, and medical devices. These are the applications of nano silver. Applications of nano gold, quantum dots, and all already completed. This table will just summarize the topics that we have already discussed. Like for example, gold nanoparticles used in the drug delivery, cancer therapy, biosensors. Sensing means sensing or detecting the infections and all. Okay, rapid diagnostics like hepatitis C, COVID-19, etc. So like that, go through this table. Okay, and now some other miscellaneous applications of nanotechnology. Okay, we can make lightweight, strong vehicles. Nanoscale films on eyeglass, specs, okay, and window glasses, car window glasses. On that, if we use nanoscale film, so that it is invisible on the car glass, but it will block the UV radiations. Imagine in a summer afternoon, we are driving a car and we are prone to very high intensity UV radiations. So, if our car windows, car glass and all, on that if you put a nano coating on that, UV radiations will be blocked, you will be safe inside the car. Same way, specs, okay, car windows, home windows, computer screens. From the computer screen, I will get blue color light. Blue color light will lead to eye problems and headache when we use it for a longer duration. So, on the computer screen, if we put a nano film, which is UV blocking properties, with UV blocking properties. Is it clear? Okay. Same way, like nanoscale titanium dioxide, zinc oxide can be used in the sunscreen. Usually, we don't prefer to use sunscreens. We know that we have to use sunscreen, but we don't use. Why? Because it feels very greasy, very heavy, as if you kept a coating on that. Especially, I don't like the sunscreens. I never use them. Okay, but in the sunscreens, if we use titanium dioxide and zinc oxide nanoparticles, because we are using nanoparticles, the sunscreen will be invisible, lightweight, invisible. You will feel as if you are not wearing a sunscreen at all, but still more effectively it will block the UV radiations. I repeat, in the cosmetics and sunscreens, when we use nanoparticles made up of titanium dioxide and zinc oxide, then they are invisible on the skin, feels lightweight, but will block the UV radiations more effectively than a regular sunscreen. Is that clear? Next, water treatment. That is, nanoparticles are small sized. Small sized filter will effectively filter out the pathogens. So, we can use in the water purifiers, water purifier and air purifiers. Water purifiers and air purifiers as filters due to their small size, as filters due to their small size, right? Next, solve this question. Consider the following statements. Other than those made by human beings, nanoparticles do not exist in the nature, right or wrong? Other than those made by human beings, nanoparticles do not exist in the nature, wrong. So, can you tell me some nanoparticles which naturally exist in the nature? Example, viruses and atoms of most of the elements like hydrogen atom, carbon atom, nitrogen atom, etc. Most of the atoms are nanometer size only. Did we create the hydrogen? Did we create the carbon? No, they naturally exist. So other than those made by human beings, nanoparticles do not exist in the nature is a blunder, not correct. Is it clear? Next, nanoparticles of some metal oxides. Example, titanium oxide. Titanium oxide can be used in the manufacture of cosmetics. Yes, metal oxides. Example, can be used in the cosmetics. Examples, sunscreens. Nanoparticles of some commercial particles which enter into the environment are unsafe for the human beings. Correct. Nanoparticles are not safe for the human beings. Why? Because they penetrate into our cells, our brain, our heart, etc. and cause harm. Is that clear? So 2 and 3, D is the right answer. Okay, titanium oxide causes cancer. Titanium oxide can cause cancer. Okay, so these sunscreens are harmful to us. Okay, clear? Of course, they are very harmful. Titanium oxide can cause cancer. Skin cancers can be caused. Okay, then now with that we completed the applications of nanotechnology. Okay, and what we have seen lot of applications of nanotechnology. Then what are the problems due to the nanotechnology? What are the problems? Problems due to nanotechnology. Okay, first one, they can cause cancers and they can harm the animals and humans. Then you can have ethical problems because you can have small secret cameras possible, secret cameras, secret mic possible, privacy related issue. So privacy related problems. Okay, security related problems, like say for example small weapons are possible, isn't it? Small weapons are possible. Then you can have economic problems, that is nano divide. Nano divide means what? Rich people can use the nanotechnology, poor people cannot use the nanotechnology. Is it clear? Rich can use nanotechnology, poor people cannot use nanotechnology. And also they can delay the flowering in the crops. Okay, so they will also affect the crops. Delay the flowering in the crops, so delay the crop. Affect the health of the human beings and animals, can cause cancers and other health issues. Okay, cancers and organ failures also possible. Organ failure, cancers possible. Ethical and privacy related issues like secret cameras, secret mics can be made. Security issues, that is smaller weapons, invisible smaller weapons can be used. Economically, it can create nano divide, that is rich people can afford the nanotechnology, poor people cannot afford. Okay, so in the agriculture they can delay the crops. So these are some problems due to the nanotechnology. Done? So now moving on to the second technology in today's class, space technology. Okay, this is the third marathon session that I am taking in this. In the first marathon session I have completed biotechnology. In the second marathon session I completed, okay, biotechnology was completed in the first session. In the second session we completed nuclear and ICT, information and communication technology. Today we are supposed to complete nanotechnology, space technology and defense technology. Okay, so we are now left with space technology and defense technology. Clear till now? So moving on to the space technology. Done. First, in the space technology, first we have to understand what is an orbit. How an object orbits around something. Okay. Then here, imagine this is the planet Earth, some planet. Okay. Then this is the orbit around the planet. This is the orbit around the planet. Clear? Complete focus, please. And quick responses so that I can complete it fast. Orbit around that planet. Clear? Now, imagine this is a satellite. It's a satellite. This satellite is having momentum in this direction. Momentum. Momentum means what? Mass into velocity. Okay, mass into velocity, right? Okay, it means how fastly that particular satellite is moving. And this will give a centrifugal force. This will give centrifugal force. Centrifugal force means what? That is away from the center. Away. I mean pushing out, outward. Okay, that is outward. Okay. Then the second force is the gravitational force. The gravitational force. And this gives centripetal force, that is inward force. Okay, inward force. It is either this one is either outward or kind of in the straight line. So better thing is, okay, that is in the straight line. That is called momentum. Momentum gives a force in the straight line. Gravitational force is pulling it towards the center. Okay. Now all of you quickly tell me, if the gravitational force is more than, the momentum of that satellite, then what happens? The satellite crashes onto the planet. The satellite crashes onto the planet, isn't it? Then, if the gravitational force is less than the momentum, I mean if the momentum is more, then what happens? The satellite escapes into the space in a straight line. Okay, the satellite escapes into the space in a straight line. But when the gravitational force is equal to the momentum, then the satellite orbits around the planet. The satellite orbits around the planet. Is it clear? So this is the rule. So now tell me, okay, so this is the reason why the satellite's momentum should be high, momentum or velocity should be high for, okay, closer orbits or distant orbits. Yes, you have a low Earth orbit. A satellite in the low Earth orbit should run faster or slower? A satellite in the low Earth orbit should run faster or slower? Velocity is high for closer orbit. Why? Because if the orbit is closer to the Earth, It means gravitational force is high. To overcome the gravitational force, the velocity also should be high. Okay, I repeat, if the orbit is closer to the earth, the gravitational force is high. To balance this, the velocity also should be high. So a satellite in the low earth orbit orbits very fast, and a satellite which is far away from the earth will orbit slow. Okay, so this is basically about the orbit. Done? If the orbit concept is clear, our next concept is the types of orbits. Can we proceed? Types of orbits. Right. In the types of orbits, the first one is called as low Earth orbit. The very first one is called as a low Earth orbit. Low Earth orbit means, okay, it is 160 kilometers to 2000 kilometers. It means, for example, if this is the Earth, okay, this one, this one, this one, this one, all are low Earth orbits, say 200 kilometers, 500 kilometers, 1000 kilometers, okay, 1800 kilometers, all these are low Earth orbits. Is that clear? And complete focus, please. Then they can be any angle. It means, look at here, we can have a low Earth orbit parallel to the equator, and we can have a low Earth orbit at a slight angle, like this also, like this also, like this also, like this also, or like this as well. Is it clear? Means what? Low Earth orbit is very simple. Low Earth orbit 160 to 2000 kilometers, and any angle, they can make any angle to equator, and they can move in any direction, north south or west east. Is it clear? Look at here. Okay, if the low Earth orbit is parallel to the equator, okay, now tell me the satellite is orbiting in the west to east direction, and if the low Earth orbit is perpendicular to the equator, then the satellite is orbiting from the north south direction. Is it clear? If the low Earth orbit is some 45 degree to the equator, then it is orbiting in the southwest direction to northeast direction. Okay, if the low Earth orbit is like this, then it is orbiting, then the satellite is orbiting northwest direction to southeast direction. So any direction okay, any height okay, okay, any angle okay. Only one rule is above 160 kilometers, below 2000 kilometers. That's all. That is low Earth orbit. Clear for all of you? Very good. So, low Earth orbit is completed. Then, okay, medium Earth orbit. Okay, that is also same. That is same, like any angle, any direction. Is that clear? In these 2 points, a medium Earth orbit is exactly like a low Earth orbit. Done? But the height is 2000 to 35,786 kilometers. You can have a 10,000 kilometer medium Earth orbit, 5,000 kilometer medium Earth orbit, 8,000 kilometer medium Earth orbit, 30,000 kilometer medium Earth orbit. Any height, any angle, any direction, just like a Leo. Okay, this can also go north to south or west to east or northwest to southeast or southwest to northeast. Okay, any direction okay, any angle okay. But only difference between LEO and MEO is 2000 to 35,786 kilometers height. Is the MEO clear? Okay. Next one, third type, polar orbit. Polar orbit is a type of LEO, okay, which is, I told you that it can go in any direction, LEO can go in any direction. Okay, this particular LEO is also called as polar orbit. Is that clear? North-south LEO is polar orbit. So now tell me, are all polar orbits LEOs? Are all polar orbits LEOs? Yes, yes. And I understood why you said no. I mean, your logic is correct. Okay, you may ask me, ma'am, like they can go at 3000 kilometers height, then it is not LEO. But angle can be north-south. I mean, an MEO can also go in the north-south direction. So this is also polar. Okay, but not like that. The word is not used. Logic-wise correct. But terminology wise, we don't call them as polar orbits, we call them as MEOs only. Polar orbit word is used only for the LEO. Is it clear? Terminology wise. So it passes over the Earth's poles, useful for mapping, surveillance and environmental monitoring. For those purposes, we use the polar orbits. Is it clear? Okay. Then. So now, are these concepts clear? LEO, MEO, polar. Is it clear? Polar orbit term is mostly used in association with LEOs. Is it clear? Other orbits, even if they are polar, I mean even if they go north-south direction, we don't use the word polar. Okay? Polar orbits are mostly used. It means like normally roughly you can even call MEO, this one also as a polar. There is not a big blunder. Because most commonly the term polar orbit is used only for this one, not for this one. But if you use polar orbit term for this one, it's not a blunder. Is it clear? I repeat, there is an MEO which goes in the north-south direction. Can we call it as polar? Logically, yes. But frequently the term polar is not used in this context. Is that clear? Right. So MEO, LEO, polar are completed. Now let us see the sun synchronous orbit. Sun synchronous orbit. Okay. Synchronous means what? Okay. Fine, I will explain the sun synchronous, but before that let us complete an easier one, that is geosynchronous. Let us complete first. Done? Geosynchronous. And I could not show you these animations even in the comprehensive course. Is it clear? It is in fact much more consolidated than the comprehensive course, because in the comprehensive course I will have to use the PDFs. In the PDFs I can't show you these kind of things. Okay, whereas here I am using the PPTs where I can show you such things. Right? Okay. Now, so this is a geostationary orbit. Geostationary orbit. Okay. Let me explain the geostationary. GEO. Geo stationary. height is 35,786 kilometers. Is that clear? Yes, Avinash, correct. Height is 35,786 kilometers. Okay. Angle fixed 0 degree to equator. 0 degree. It means parallel to equator. Is that clear? Parallel to equator. Okay. GEO. Okay. 35,786. GSO. Also 35,786. Okay. GEO. Parallel to equator. Okay. Here no need. I mean any angle possible. Is that clear? Right? And GSO means what? Geosynchronous. Geosynchronous. Then speed. Okay. Speed wise, speed same as, okay, it's the satellite's speed of revolution, okay, is equal to the Earth's speed of, okay, rotation. Okay, it means what is the time taken for the Earth to rotate around its own axis? The time taken for the Earth to rotate around its own axis is 24 hours. Okay. And the Earth is, please observe the Earth, what the Earth is doing. Earth is rotating and the satellite is revolution around the Earth. Is it clear? Okay. The time taken for the Earth rotation is equal to the time taken for the satellite's revolution. Both are 24 hours. Is it clear? So because of this, what happens? It looks static. Okay. When you see from here, it looks as if the satellite is moving, but the satellite looks as if it is not moving when you see from any one particular point on the Earth. Okay. Is the geostationary clear for all of you? The height of the geostationary 35,786 kilometers and angle is, it is parallel to the equator. Okay, means always in the west to east direction only, same direction as Earth. Okay, direction same as Earth, that is west to east direction. Direction is same as Earth, that is west to east direction. Okay, but here any direction is okay. Any direction, that is north south okay, west east okay, east to west okay, southwest to northeast okay. Any direction is okay. Any angle is okay. But the speed must be same as that of Earth. It means 24 days to complete one revolution. Clear till now? Okay. So, why this is called geosynchronous? In this geosynchronous, the word geo means Earth. Synchronous means what? Matching. Synchronous means matching. It is matching with Earth. Tell me in the geosynchronous, what is matching with the Earth? Direction is matching with the Earth, or angle matching, or speed matching? For a geosynchronous orbit, what is matching? Speed or direction or angle? Fast please. Okay, matching only the speed. Okay, matching only the speed. Whereas geostationary, speed and also the direction. Okay. So here GSO only speed. Here what is matching? Speed and also the direction. Done? Now tell me, are all GEOs, geostationary orbits, geosynchronous orbits, are all GEOs the GSOs? Yes or no? 24 hours, okay. 24 hours, that is a slip of my tongue, that's fine. 24 hours of course. All GEOs are GSOs. Correct. All geostationaries are geosynchronous, because see here speed is matching, so it is synchronous. But all GSOs are not GEOs. All geosynchronous are not geostationary, because only speed matching. There is no rule that the direction must be matching. Okay, if the direction is not matching, I will tell you a small example. Let us suppose, this is Einstein's favorite example. You are traveling in a train. Okay, you are traveling in a train. Train A, 60 kilometer per hour. Okay, and going towards the north. Okay, and train B is also 60 kilometers per hour and going towards the north. Then when you are sitting in the train A, a person sitting in the train B looks as if he is moving or as if he is static. Yes, everybody? Moves static or moves as, like looks as if they are moving. So looks static, but if the train C is moving 60 kilometers per hour, but going towards the south, then it looks as if it is going at, it looks as if it is going at 120 kilometers per hour. Is it clear? It looks as if it is running double fast, double speed. Is it clear? So when this particular satellite looks as if it is static, only if speed is same, direction is also same, then only it looks static. If speed is same but direction is opposite, Earth is going west to east, it is going east to west, then it looks as if it is traveling with double speed. Okay. So all geostationary orbits are geosynchronous because they move with the same speed. GEO, obviously they will move with the same speed. But all geosynchronous need not look stationary from the earth. They may look as if they are traveling at a double speed when we see from the earth. So all GSOs are not GEOs. Okay. Is the geostationary and geosynchronous concept clear? Yes? Any doubts in the geostationary and geosynchronous? No. Okay. So on the whole, geostationary or sorry, geosynchronous means what? Same speed as Earth. But now sun synchronous. Sun synchronous. Okay, now all of you answer this question. If geosynchronous means same speed as Earth, sun synchronous must be same speed as sun. Sun synchronous is same speed as sun, correct or wrong? Everybody? By the way, Devendra Kumar, geosynchronous, there is no rule that different direction. Okay, is it clear? Only same speed I said. Direction can be same or different. Both are okay. There is no rule that a geosynchronous should definitely go in a different direction. Is that clear? Speed should be the same. Okay, and direction can be same or different. Direction can be either same or different direction. That is the reason why. Okay, all GEOs are GSOs. Is it clear? It means some of the GSOs. Okay, I hope it is clear. Don't think that in the GSO the direction should not match. There is no such rule. Any direction means same direction is also possible. So therefore, some GSOs, some geosynchronous orbits are geostationary orbits also. Is it clear? So it means geosynchronous orbits is a larger group. It's a larger category. And geostationary orbits are a type of geosynchronous orbits. Is that clear for all of you? Devendra? Right. Geosynchronous means any orbit, okay, any direction, any angle. So that's a larger category. In that particularly same direction, okay, that is called geostationary. Yes, clear for all of you? In any direction, what all comes here? It can go north, south. It can go north, south, west to east, east to west, south, west to northeast, etc. Any direction is okay. And this particular GSO is also a GEO. It means GEO is a type of GSO. GSO is a larger category. Done. Now, leave the geostationary and geosynchronous. Now come to the sun synchronous orbit. Sun synchronous orbit. Okay. Geo means what? Earth. Meaning of the word geo means earth. Okay. Synchronous means matching. So sun synchronous means sun matching. Can I say like this? Geosynchronous means same speed as Earth. So sun synchronous must be defined as same speed as the sun? No, wrong, blunder. That is not the meaning of the sun synchronous. Agreed? That is not the meaning of the sun synchronous. Why? Because the sun is not moving. Sun is not moving with respect to the earth. Okay. Is the sun static in the space? No, sun is moving, but not with respect to the earth. Sun is orbiting around a black hole at the center of the Milky Way galaxy. Is that clear? With respect to the earth, sun is not moving. We are moving around the sun. So this sentence is meaningless. Sun synchronous orbit, satellite will orbit at the same speed as the sun is a blunder. That is not the definition. Understood? All GSOs are GEOs. No Devendra, opposite. All GEOs are GSOs. All geostationary is a small category. All geostationary are geosynchronous. Okay, because if it is a geostationary, same speed, same direction, means obviously same speed. So geostationary is definitely geosynchronous because same speed. Okay, but if the direction is also not matching, then it is not geostationary. Geosynchronous means just speed should match. And the direction may match, may not match. Whereas geostationary means speed, direction both should match. Is it clear? Like for example, you have some 10 friends. Okay, you have some 10 people. Let us think like this. You have 10 people as friends. In that 10 people, okay, friends or somebody, in that 10 people, okay, your subject is also same. I mean, you both are, all the 10 people are preparing for UPSC just like you. Okay, all the 10 people are preparing for UPSC just like you. Okay, but 5 of them, okay, are also preparing with the same optional as you. Say they also have the same optional with which you are preparing. Is it clear? Then which is a bigger category? Okay, the 10 people are the bigger category. Only one parameter matching. They are also writing the same exam, but the other parameter not matching. Is it clear? So like that, here what happens? In the GEO, speed should be the same, direction is also same, but here only speed must be the same. So which is a bigger category? There you have 10 people who are preparing for UPSC, but only 5 of them are preparing with the same optional as you. So GEO, both are matching, is a smaller category. All geostationary are definitely geosynchronous, but all geosynchronous are not geostationary. Every time the speed matching, they need not look static when you see from the earth. That is the meaning of that. Devendra, clear? Pakka 100%? Then, now come to the sun. See, if you have any more doubts with the geostationary, geosynchronous, please complete them, so that I will go to the sun synchronous. If I go to sun synchronous, then think only about sun synchronous. Is that clear? That is a pattern with which you have to listen. Any more doubts related to geostationary, geosynchronous? Any more doubts related to geostationary, geosynchronous? No, right? Then after that, if you get some doubts, hold on, you can ask me later. Okay, now completely focus on the sun synchronous. Now my question is, geosynchronous means same speed as earth. So sun synchronous means same speed as sun. Can I say like that? Sun synchronous is same speed as the sun. Can we say like that? Fast everybody? No, because sun is not moving. So what do you mean by same speed as the sun? That is a meaningless statement. It is a blunder. Why this is not the definition? Because sun is not moving with respect to the earth. That is not the meaning. Then what is sun synchronous? Okay, synchronous, sun means sun, synchronous means matching. It means sun synchronous means, okay, matches with the solar time. Solar time, it means matches with the sun's position. Is it clear? Now check here all of you. I'll explain the sun synchronous. Look at here. This is day. Do you agree? Because it is bright. And this is night. Okay? Because it is dark. Done? And what is this border line? This is dawn. Do you agree? Dawn. dawn. For example, 6 a.m. Is that clear? And look at that, can you see a satellite which is coming like this? Can you see this one? Right, can you see that? The satellite which is going like that, is that clear? So, look at that, that is crossing this particular place always only at, this satellite is crossing this particular line always at the dawn. Is it clear? Always in the early morning. Never in the night, never in the daytime. Okay. So, every day you can see that at 6 a.m. Again 7 a.m. if you see, you can't see that satellite. 8 a.m. no, the satellite is not visible. 10 a.m. not visible. 8 p.m. not visible. 10 p.m. not visible. Okay. 12 midnight not visible. 5 a.m. not visible. 6 a.m. Again you can see the satellite. So every day you can see the satellite exactly at 6 a.m. Or every day you can see the satellite exactly at 12 noon. That is called sun synchronous. Is it clear? Fixed position with respect to the sun. Is it clear? Fixed position with respect to the sun. Is that clear? Now, fine, that is called sun synchronous. Now, I will tell you some parameters, you answer which type of an orbit it is, okay? There is one, listen carefully and keep answering, okay? You can use shortcuts, but I want everybody to answer, right? Now, first question. There is a satellite which is orbiting at a height of 400 kilometers and going southwest to northeast. What kind of an orbit is that? 400 kilometers altitude and going southwest to northeast. What kind of an orbit is that? LEO. Okay, 500 kilometers but going north to south. So it is an LEO. In addition to being an LEO, it is also called as a, I repeat, 500 kilometers but north-south direction. Because it is 500 kilometers, it is LEO, but because it is going in the north-south direction, it is also a polar orbit. Okay, next question. Okay, there is one satellite, okay, anytime you see that 6 a.m., 10 a.m., 12 noon, midnight, 4 a.m., 4 p.m., 6 p.m., 6 a.m., anytime you see that, you can see the satellite. From my home, I can constantly see the satellite. That satellite looks as if it is not moving at all. That satellite is in which orbit? Everybody. That satellite is in which orbit? Very good, excellent. Geostationary. Geostationary, Saurabh. Not geosynchronous. It is geosynchronous also, but more appropriately it is geostationary. Next question. Are all the geostationary orbits, means it is looking static, is it geosynchronous also? Are all geostationary orbits geosynchronous? It looks constant, means it is going with the same speed as Earth? Yes. But are all the geosynchronous satellites geostationary? Every satellite that moves at the same speed, will it look as if it is static? Like a train which is moving at the same speed but in opposite direction, will it look as if it is static? Another train which is moving at the same speed as you but in opposite direction, will it look as if it is static? So are all geosynchronous ones geostationary? No. Very good. There is a satellite which is 10,000 kilometers height and going in the northwest to southeast direction. What kind of an orbit is it? a satellite which is 10,000 kilometers altitude but going in the southwest to northeast direction. What kind of an orbit it is? MEO. MEO. Okay. Like, do the satellites in the sun synchronous orbit travel at the same speed as the sun? The satellites in the sun synchronous orbit travel at the same speed as the sun? No, because the sun is not moving at all. There is nothing like same speed as the sun. Then they are matching with what? They are not matching with the sun's speed. They are matching with the sun's position. Not matching with the sun's speed, matching with the sun's position. Is that clear? Sun's time, solar time, sun's position. Okay. If you see this animation, you can see the satellite, okay, passing through that particular continent always at the dawn. Every day 6 a.m. you can see that. Okay. The satellite which you can see, for example, you go on to the terrace and you can see that satellite any time, then the satellite is in the GEO. You go on to the terrace at any time you cannot see that, but exactly at 6 a.m. you can see that. Then it is in the sun synchronous orbit. Is that clear? Right. Then, now, what is the usage of these orbits? I mean, applications of these orbits. Let us see that. Low Earth orbits are used for the, okay, like we can use them for remote sensing, okay, International Space Station. Why? Because if the International Space Station, astronauts should keep going there and coming back. Astronauts should keep going there and coming back. So it should be closer. Then imaging satellites, because close-up shot better resolution, imaging satellites with high resolution. For this type of satellites, low Earth orbit is suitable. Medium Earth orbit is suitable for navigation satellites like NAVIC, okay, IRNSS, GPS, okay. For such satellites, medium Earth orbits are suitable. Is it clear? And polar orbits are also used for same purpose, that is imaging satellites, high resolution, mapping, surveillance, environmental monitoring, etc. because they are also low Earth orbits. Are the applications clear? Then, now, sun synchronous orbits, they are used for environmental studies. It means if you want to study the changes in temperature at 6 a.m. in Delhi over 5 years. If this is the target, we have to use the sun synchronous. Is the application of sun synchronous clear? I want to study Delhi temperature, but not throughout the day. 6 a.m. temperature at Delhi, how it is changing in 5 years, over a span of 5 years. 3 years back, what was the temperature at 6 a.m. in Delhi? Today, what is the temperature at 6 a.m. in Delhi? For this kind of things, we use sun synchronous orbits. Is it clear? Environmental studies for a particular time at particular place. Done? Can we proceed? Right? I want to study the temperature at 6 a.m. in Delhi. I'm not curious about the temperature at other timings. Temperature at 6 a.m. particularly Delhi, over a span of 5 years. Then sun synchronous orbit is suitable. Okay? GEO can be used for that purpose. No. GEO can be used, I'll tell you. GEO can be used to study the temperature, okay, throughout the day. Throughout the day, not only at 6 a.m. It is constantly watching Delhi. Throughout the day you can study. That is the role of GEO. Is that clear? Constant monitoring. Means GEO used for constant monitoring. Is that clear? Right. Then geosynchronous is also similar to GEO but can have any inclination, that is any angle. And geostationary orbit, they stay fixed over one spot. So therefore they are ideal for weather and communication satellites. Weather monitoring and communication satellites can be kept in the geostationary. Clear till now? Okay. Also earth imaging, geostationary can also be used for earth imaging to cover large area. Okay. To cover large area, it means simple. Sometimes you want to take a close-up shot so that person's face you can see very clear. Sometimes you want to take a long distance shot so that your target is not to see that person more clearly. The target is to see how many people are there in that classroom. Is it clear? So if your target is earth imaging with high resolution of one particular place, where should I keep the satellite? Everybody. My target is earth imaging, but I want that image with very high resolution. I want super clarity of one place. Then where should I keep the satellite? Everybody please. LEO, not GEO. GEO is 35,786 kilometers, dear. Okay. How can you get a high resolution image? Okay. To cover large area, but high resolution is not needed. High resolution is not needed. Then we have to keep the satellite in the GEO. Okay. GEO is 35,786 kilometers. So from such a distance, if you take a photograph, you can cover large area. Is it clear? Okay. But resolution will not be good because clarity will not be good because it is a long distance shot. Done. Then for communication satellites, GEO is best for communication satellites. Like for television. For example, okay, let us suppose if I keep a communication site, if my TV antenna is receiving, listen this carefully, I want all of you to give the right answer. If my TV antenna is getting the signals from a satellite in the low Earth orbit, okay, can I keep that TV antenna fixed in one place or should I hold that antenna and run along with that satellite? Should I keep running? Yes, because low Earth orbit is very close to the Earth. So gravitation is very high. So therefore the speed is also very high. So the satellite will just keep moving like this. Okay, then it means I will not get the signals constantly. For example, if I have to watch a movie in a satellite television, I want that TV to get, I want my TV antenna to get the signals constantly. I can keep that TV antenna fixed in one place. Is it clear? Right? So tell me, for which type of purpose, for which type of satellites, the GEO is the best? For which type of satellites GEO is the best? communication satellites, and also earth imaging sort of satellites, but if your purpose is not high resolution but good coverage. And also we can use to study the weather monitoring of a particular place, constantly monitoring the weather in one particular place. For these three purposes we use the geostationary orbit. Clear till now? Next. Now next one and the last one, geostationary or geosynchronous. Geostationary or geosynchronous transfer orbit means what? Look at here, complete focus here please. Say this is Earth, I will just draw it once. This is Earth. Earth. Now look at here. This is your 35,786, that is GSO or GEO. Okay. Can you directly go from the Earth to 35,786? No, it is difficult. So what you will do, you will go like this, like this, like this, like this. These are called as GTOs, geostationary transfer orbits, the orbits that are used to transfer a satellite to the GSO or GEO. Is that clear? Right? Then, so here look at this. These geostationary transfer orbits, they are elliptical. Earth, they are elliptical. This point is called as apogee. Okay, this point is called as apogee. This closest point is called perigee. Apogee, perigee. Is that clear? Now, so here what we do is, I hope you all might have watched the Mission Mangal movie, Mangalyaan Mission Mangal movie. So in that Mission Mangal movie, they have shown the process of sending a satellite to the Mars, okay, Mars orbiter mission, just using a small vehicle called PSLV. PSLV is a very small vehicle. It cannot carry the satellite up to the Mars, but they have done that. How they have done it? Puri concept. I mean, switch off the stove when the oil is hot. That is the principle. So here, complete focus here. Okay, look at this. Let us suppose the satellite is launched. Okay, satellite is launched. So here what happens? Now you switch off the fuel. Why? Do you know the law of inertia? Newton's first law? Newton's first law, that is inertia. That is an object in motion continues to be in motion unless some force stops it. Unless some force stops it. Is that clear? Law of inertia. Inertia means inability to move its state. An object which is moving will continue to move. It cannot stop unless and until some force stops it. So now, okay, complete focus please. You launched the satellite and the satellite is in the orbit. Okay, now tell me, do you need, okay, all of you answer this question. Do you need fuel only to carry a satellite till the orbit, or do you also need fuel for the satellite to keep orbiting? Do you need fuel only to carry a satellite till the orbit, or you also need a fuel to maintain it in the orbit? Yes? Okay, so we need fuel. We need fuel only to carry a satellite till the orbit, but not needed to maintain it in the orbit. Is it clear? How it will move in the orbit without fuel? Okay, that is because of the inertia, Avinash. Okay, answer is here. Newton's first law. An object which is in the motion, okay, an object which is in the motion will continue to be in the motion unless and until some force stops it. Is that clear? Avinash, clear? Okay. Same way, an object which is, see, like inertia is something like, for example, you are going in a bus, okay, and you will get down from a running bus, okay, you will jump out of a running bus. If you get down from a running bus, will you stand like that, or you will try to run along with the bus? You will try to run along with the bus. If you do not run along with the bus, you will fall towards your center, your front, isn't it? Yes, why? Because you have inertia due to motion. You cannot stop immediately. Unless and until something stops it, you cannot stop. So therefore you have to run. If you suddenly try to stop, if you don't run along with the bus, you will fall towards the front, because you are still in that movement zone only. Okay. Law of inertia says any object which is in the movement will continue to move unless and until some force stops it. So you need fuel only to keep a satellite in the orbit. You don't need fuel to keep the satellite running. Clear till now? Right, very good. So, first what we are doing here, step 1, launch the satellite. Then what to do? Switch off the fuel. Why? Because the satellite is already in the orbit. Switch off the fuel. Then, okay, keep observing. It will go like this and then come back. Once it comes to the perigee, again start the fuel. Again restart the fuel. Fire. So that what happens, it is pushed a little away. I mean, it goes to a little farther orbit like this. Is it clear? Then again, fire. It will go to a farther orbit. Stop. Fire. Stop. Fire. Stop. Fire. Stop. Is it clear? It means every time it comes to perigee, again start the fuel. Then it will be pushed to the next level, little farther away orbit. Okay. So that like this, like 1, 2, 3, 4, 5, 6, 7, 8. Gradually, in a stepwise manner, it will go to that 35,786. Okay, altitude. Is that clear for all of you? Right? I repeat, step 1, launch the satellite. Step 2, now it is in the orbit. Then switch off the fuel because it can continue in the orbit. Step 3, once it comes back to the perigee, again fire the fuel, again start the fuel. Okay, why? Why should I start the fuel again? Okay, to push it to a little farther orbit. If it should continue in the same orbit, I don't have to fire the fuel once again also. Is that clear? If I want the satellite to continue in the same orbit, should I keep firing the fuel? Yes, everybody? If I want the satellite to continue in the same orbit, should I keep firing the fuel again and again? For the satellite to orbit like this, should I keep firing the fuel again and again? No need, it will continue to orbit. Then why are you firing it again? Why are you starting the fuel again? Because this time you want to push it to a greater distance. You want to push it to the next step. Then again it comes back to perigee. Again fire it. Again start the fuel. Again it will go to the next step. Like that, in a stepwise manner, it will go to the GEO or GSO. Is that clear? So, these are called as geostationary transfer orbits. They are not geostationary orbits. Geostationary tak पहुंचाने के लिए, to carry the satellite till the geostationary. These are used to transfer. Okay. So, these are called GTOs. Is that clear? GTO. Then, so we use GTOs, for example, if we want to go to the moon. We don't have a vehicle that can carry the satellite from the earth to the moon directly. Is it clear? We don't have a satellite that can carry we don't have a heavy vehicle that can carry the satellite from the earth to the moon. Yes, all of you tell me, do we have a heavy vehicle that can carry the satellite directly from the earth to the moon? Do we have a heavy vehicle that can carry the satellite directly from the earth to the moon? Everybody? No. Ashish, it is not moving at the same level. If you see, GTOs are elliptical. GTOs are elliptical. This is not GTO. GTO looks like this. Then this is perigee. This is apogee. Perigee is as close as LEO, okay, means maybe some around 200 kilometers. The apogee can be 35,786 kilometers. 35,786 kilometers. Okay, Ashish, clear? It is not a circular orbit, it is a elliptical orbit. You have a perigee, you have an apogee. Is apogee always 35,786? No. For this, the perigee is 200. The apogee can be maybe some 20,000 kilometers. Okay. So, the apogee keeps increasing. Perigee remains the same. It will become more and more elliptical. It will become more and more elliptical. Ashish, clear? Will it revolve fast at the distance at perigee? Of course, yes, Jyoti. Correct. Perigee is fixed. Apogee keeps increasing. For every next GTO, the apogee is at. For example, here the apogee is maybe 5,000. Here the apogee is 6,000. Here the apogee is 10,000. Here the apogee is 20,000. Here the apogee is 25,000. Then here the apogee will be some 30,000. Here the apogee is 35,786. Then how can we say the satellite is in the GEO? Satellite is Ashish. The satellite is not in the GEO beta. The satellite is in the GTO. Okay, GTO. T means transfer orbit. It is an orbit which is used to transfer the satellite to the GEO. It will carry the satellite to the GEO. These are steps to carry. GTOs are the steps to carry the satellite till the GEO. Is that clear? Ashish, clear? Yes, Ashish, clear? Perigee can be shorter than 200? Yes. Okay, 200 is not fixed. Perigee is like LEO. Is it clear? Perigee should be less than 2000. Okay. It means perigee as low as. Perigee as low as. I'll tell you. For a GTO, perigee as low as an LEO, apogee as high as means maximum height is 35,786. That is GEO. Is it clear? Ashish, I hope it is clear for you. So, in a GTO, perigee is constant and apogee keeps increasing. So, GTO is an elliptical orbit. GTO is an elliptical orbit. Okay? Right. When it passes through the perigee, can we say it is LEO? So, no, Ashish, it got a name called transfer orbit. It cannot be called it means, can I call me here as Bindu and here as some Arjun, here as some Karan, here as some Ashish? No, this is completely Bindu. So, that complete elliptical orbit is called as GTO. Clear, Ashish? It cannot be called with different names in different places. That complete elliptical orbit is called as GTO. It is not GEO. It is a step to GEO. Is it clear? It is not GEO. These are steps to GEO. Clear? Right. Then, I hope the geostationary transfer orbit clear. No, Saurabh, it is not based on the apogee distance or perigee distance. It is classified based on both of them. Okay? If there is no perigee apogee, then it is not a transfer orbit. An elliptical orbit in which, okay, you have a perigee and an apogee, that is called as a transfer orbit. Saurabh, clear? Yes. Done. Now, that is called geostationary orbit. Now, all of you tell me, do we have a heavy vehicle that can carry a satellite from the earth to the moon directly? Do we have a heavy vehicle that can carry the satellite from the earth to the moon directly in a single go? No. So, what we do is, we use this, geostationary transfer orbits. We use this transfer orbits like this, okay. At each step it will go little away from the earth. Listen this sentence carefully. At each step it will go little away. Then close. Close to what? Close to the moon. Okay, look at here. First what happens? Away. Look at this. away, little away, little away, little away, little away, 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 away. Now it is so far that it is not at all being influenced by the Earth's gravity. Okay, at this place it crossed the Earth's gravity. Then it is being attracted by the moon's gravity. Now closer, 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 closer to the moon. That is how we go. Is it clear? Okay, done. Look at this path once again. Okay, 1, 2, 3, 4, 5, 6, away. Okay, 1, 2, 3, 4, 5, closer to the moon, like that. Okay, that is how we reach the moon using PSLV. That is how we can also reach the Mars using PSLV. Using a very small vehicle with lesser fuel, using this switch on switch off concept, we can travel for more distances. Is it clear? We use the fuel only at the perigee every time. Okay, we don't use the fuel when the satellite is in the orbit. By this we can save the fuel, and in a smaller vehicle with lesser fuel we can go to larger distances. Okay, clear? Right. That is the story of transfer orbits. Then with that, orbits completed. After orbits, what we have to do is the launch vehicles. Okay, launch vehicles, right? Launch vehicles, we have different types of launch vehicles. Okay, the first one is called as, I'm just thinking, should we take a break now or we can continue? Yes, better we can take a break now. You will have a break till so you have a break till dinner break 20 minutes. 8:35 we will be back. 8:35 we will be back. Okay, mostly after this we will have another one small 5 minutes break, not more than that. So let us have right. Okay, so let us meet again at 8:35, right? Am I audible now? Yes. So welcome back after the break. Before the break, we completed the nanotechnology and started the space technology. In the space technology, we completed the orbits. What is an orbit and the types of orbits and what orbits are used for which purpose. So now let us continue with the satellite launchers. The launchers are also called as rockets. The types of rockets are the launch vehicles. Rocket, satellite launch vehicles, right? Then in the satellite launch vehicles, the first one is SLV. Satellite launch vehicle. This is the first generation. And now they are discontinued. We are not using them anymore. Second type are ASLV. ASLV means what? Augmented satellite launch vehicle. Augmented satellite launch vehicle. That is second generation. That is also discontinued. We are not using that anymore. Okay. So the next type we are using is called as PSLV. The third one is called as PSLV. PSLV means Polar Satellite Launch Vehicle. Is that clear? No, Saurabh. Remaining all except GTO, remaining all orbits are circular. They do not have perigee and apogee. Only GTOs are elliptical, only they have perigee and apogee. Okay. Now coming to that. So the third one is called PSLV. Can we proceed? It is the third generation launch vehicle. It is the first Indian launch vehicle to be equipped with a liquid stage. PSLV in total have 4 stages. What do you mean by 4 stages? Look at here. A launch vehicle will have 4 stages like 1, 2, 3, 4. And we ignite the stage 1. We ignite the stage 1 during the launch. During the launch. Is it clear? And we don't ignite the stage 2. When the stage 1 is completely burnt, when the stage 1 is completely burnt, then the burnt stage 1 will ignite the stage 2. And the burnt stage 2, when the stage 2 is burnt till here, that will ignite the stage 3. The burnt stage 3 will ignite the stage 4. And the stage 4 will keep the satellite. Stage 4 keeps the satellite in its orbit. Is it clear? In this we use, in the PSLV we use, first stage is solid fuel. Second stage is liquid fuel. Again we use solid fuel. Again we use liquid fuel. Is it clear? So PSLV has total 4 stages. In that, okay, they are solid, liquid, solid, liquid. What is the advantage with solid fuels? With solid fuels, the advantage is, okay, it will give greater thrust. Greater thrust. Okay, means what? Strong force. Strongly it will push it away from the Earth's gravity. Is it clear? But the disadvantage here is switch on off not possible. On off not possible. Is it clear? Means once ignited you cannot switch it off. That Puri concept, that GTO concept which I explained is not possible with the solid fuels. Is that clear? Okay. Then next you have liquid fuels. With liquid fuels it is exactly opposite. They will give lesser thrust. They will give lesser thrust, lesser push, but you have better control. We have better control. It means on, off, possible. Okay, whenever you don't want the fuel, you can switch it off. Whenever you want it again, you can switch it on. Okay, so that is the advantage of solid and liquid fuels. Is it clear? So this is PSLV. In the PSLV, we have different variants. First one is called core alone. Core alone means what? Only core. Only core means what? There are no, okay, strap-on boosters. There are no strap-on boosters. Is it clear? Strap-on boosters means what? Okay, look at here. This is the core. Then you have small rocket-like structures here. They are called strap-on boosters. Okay? They are called strap-on boosters. Okay? In the PSLV CA, you have only the core. There are no strap-on boosters. Second variant is called as PSLV G. It has 6 strap-on boosters. Each strap-on booster is having 9 tons of the solid fuel. Is it clear? Okay. Each strap-on booster is having 9 tons of the solid fuel. That is PSLV G. I hope these two are clear. Then PSLV XL. In this also you have 6 strap-on boosters and each strap-on booster contains 12 tons of solid fuel. Okay. Next one PSLV DL. PSLV DL will have 2 strap-on motors. PSLV QL will have 4 strap-on motors. So which one is the heaviest PSLV? PSLV XL is the heaviest PSLV. Okay. And PSLV is called as the workhorse of ISRO. We call PSLV as the workhorse of ISRO. It means most of the prestigious launches of ISRO are done in the PSLV. I hope the PSLV is clear. Okay, complete focus please, because it is a marathon session, it is not a slow session. You need to have complete focus, right? Then moving on to the second type of the vehicle. Okay, and because like we have to complete a lot of syllabus and this is the last session, so if you are not completely alert and if you miss a point, again and again repeating that is also not possible. So complete focus, let us speed up the process. Okay. The second type of vehicle is called as geosynchronous vehicle, GSLV. What is the title of PSLV? PSLV is workhorse of ISRO. That is a lighter vehicle. GSLV is called Fat Boy or Bahubali of ISRO. In the GSLV also we have variants like GSLV Mark II, GSLV Mark III. GSLV Mark III is now renamed as LVM3. LVM3 means Launch Vehicle. Launch Vehicle Mark III. LVM3. And it is renamed. Original name is GSLV Mark III. Okay. It has 3 stages. It is a 3-stage rocket. PSLV was 4-stage rocket, solid, liquid, solid, liquid. GSLV Mark III is a 3-stage rocket. Okay, first one is called the solid one, that is S200. I'll show you the vehicle. Okay, right. So the first one is called as S200. This is called S200. S200 because there are 204 tons of the solid fuel. It is having 204 tons of solid fuel. Is it clear? Then next this is called as L110. L110. means 110 tons of 110 tons of liquid fuel. Okay, and the upper stage, the third stage is C25. This is called C25, means 25 tons of cryogenic fuel. Cryogenic fuel. Is it clear? Yes, Devendra, it is functional. Okay, all forms of PSLV are functional. Only SLV, ASLV are discontinued. All forms of PSLV, core alone, G, XL, DL, QL, all are functional. Not only functional, that is the main vehicle of ISRO. Most of the important launches of ISRO are done using the PSLV variants only. Okay, right. Next, GSLV is a 3-stage: solid, liquid, cryogenic. Solid, liquid and cryogenic. Is that clear? S4, S200 means what? 204 tons of solid fuel. L110 means 110 tons of liquid fuel. C25 means 25 tons of cryogenic fuel. Okay. GSLV is the first vehicle in which cryogenic fuel is used. GSLV is the first vehicle in which cryogenic fuel is used. Third one, small satellite launch vehicle. Small satellite launch vehicle. See, when compared to PSLV, GSLV is the workhorse. Okay, when compared to PSLV, GSLV is heavier one or a lighter one? When compared to PSLV, the GSLV is a heavier one or a lighter one? Yes. GSLV is a heavier one. But the next one, fifth one is SSLV. It is very small, even smaller than PSLV also. Okay. So it means after GSLV, we did not try to make a heavier vehicle. Why? Because you tell me, do you always need a car, or sometimes you also need a bicycle or a bike to easily go to any smaller distances or lesser important works, right? Okay, so that is the reason why we use SSLV. SSLV is very small satellite launch vehicle. Okay, it can carry only 500 kg payload, 500 kg payload to only 500 kilometers, only up to 500 kilometers. Okay, right. And it has 3 solid stages and 1 final. It means solid, 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 liquid. See, PSLV is solid, liquid, solid, liquid. GSLV is solid, liquid, cryogenic. And SSLV is solid, 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 3 solid propulsion stages and 1 liquid final stage. Solid, 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 liquid. That is SSLV. This is heaviest. This is the heaviest we have. This is the workhorse of ISRO. I mean main vehicle of ISRO. This is the smallest we have. Okay. Why we need smallest vehicle? Okay, because if you want to carry a small satellite or if you want to go to a smaller distance, you don't have to waste a GSLV. Is it clear? And remember, all these are, okay, the rockets, we have different types of rockets we have are, as I am writing here, okay. SLV, ASLV, PSLV, GSLV, SSLV, even NGLV. All these are use and throw. It means single use. Single use. It means they will not come back. They will not come back. Is that clear? All these SLV, Augmented Satellite Launch Vehicle, Polar Satellite Launch Vehicle, GSLV, SSLV, the smallest launch vehicle, even NGLV. Okay, NGLV is a future rocket. Okay, that is partly okay. Let us leave NGLV. All these are single use. They will not come back. Okay, they will be burnt. I hope it is clear. They will be burnt. What will happen to these burnt stages? Okay, stage 1 and 2, they will fall back onto the earth. Is it clear? They will fall back onto the earth. The third and fourth stages, they will form the space debris. They will form the space debris. Is that clear? Because the third and fourth stages are very high above the, like at a higher altitude. So means they are above the gravitational influence. So therefore they will become the space debris. But the first stages, they will fall back onto the earth. But the rocket is wasted. We cannot use same rocket for multiple launches. So in that situation, tell me, should we only depend on a heavier rocket like GSLV, or we also need a smallest satellite to launch smaller vehicles, so that we need not waste a GSLV for a small satellite? Yes? Should we only depend on heavy vehicles, or we need a small satellite launch vehicle so that we don't waste money, resources, okay, on GSLV to launch a very small rocket? Yes or no? Okay, we want SSLV. Why? Because we don't want to waste a PSLV or GSLV every time. Okay, you know something, in one of the launches, ISRO launched around 104 satellites together. Okay, single launch, 104 satellites. That was a world record. So we are proud of that. But what is the disadvantage in that? That rocket behaved like a share auto. It means it waited till 104 small satellites gather. Lot of time waste. But if you have a small vehicle, instead of waiting till 104 satellites gather, a single small satellite can be launched. That is the advantage of SSLV. Is SSLV clear for all of you? Right. Next comes Agnilet. Agnilet is not an ISRO's rocket. It is the world's first single piece 3D printed rocket engine. Okay. There are two credits to it. Agnilet, one credit is it is the world's first 3D printed rocket engine. Is it clear? It is not manually manufactured. It is printed out using a 3D printer. Second credit is it is the first vehicle in which semi-cryogenic engine is used. Is it clear? First vehicle in which a semi-cryogenic engine is used. Then, what do you mean by a semi-cryogenic? Okay, I will explain what is a semi-cryogenic. Listen this carefully. Okay, first we need to know what is a propellant. A propellant contains two components in that. First one is called as the fuel. Second component is called as oxidizer. Oxidizer. Okay. First tell me, when you fill petrol or diesel in your bike or car, will you only fill up the petrol diesel, or you will also fill up some oxidizer? Will you fill up only the petrol and diesel, or you will also fill up some oxidizer in that? In your car or bike, will you also fill up some oxidizer? We use only the fuel. Okay, it means we use atmospheric oxygen for burning the fuel, isn't it? Combustion is chemically an oxidation reaction. A fuel cannot burn without oxygen. You don't fill up an oxidizer because we are using atmospheric oxygen. But in the space, the atmospheric oxygen is very negligible. That is the reason why we should also fill the oxidizer. Is it clear? Then, if both fuel and oxidizer are cryogenic, then it is called cryogenic engine. Is it clear? Cryogenic engine. Example, the fuel used is liquid hydrogen at minus 253 degrees Celsius, and the oxidizer is liquid oxygen at minus 183 degrees Celsius. Now tell me, it is a cryogenic or semi-cryogenic, right? Yes, all of you? If the fuel is liquid hydrogen at minus 253 degrees Celsius and oxidizer is liquid oxygen at minus 183 degrees Celsius, both fuel and oxidizer are cryogenic, so it is a cryogenic engine. Okay, so this is a cryogenic. But if the fuel is kerosene, and oxidizer is liquid oxygen at minus 183 degrees Celsius, then we call this as semi-cryogenic. Is that clear? We call that as semi-cryogenic. It means fuel is liquid, fuel is not cryogenic. Cryo means what? The word cryo means extreme cold. Kerosene is not extreme cold. So kerosene is a liquid fuel, not a cryogenic fuel. If the fuel is liquid, oxidizer is cryogenic, it is semi-cryogenic. If the fuel oxidizer both are cryogenic, then it is called cryogenic. If the fuel oxidizer both are liquid, then it is called liquid fuel, liquid propellant. Okay, is the meaning of the semi-cryogenic clear for all of you? Okay, right. So now it is the first semi-cryogenic engine. What is the speciality of Agnilet? World's first semi-cryogenic engine. World's first single piece 3D printed rocket engine. Okay. Here Agnilet. What is Agnilet? Agnilet is the engine. Okay. Agniban is the rocket. Tell me, what is the name of the rocket? Agniban. What is the rocket engine? Agnilet. What is the company name? Company name is Agnikul Cosmos. Agnikul Cosmos. That is a company name. Okay. And the company has got the first private launch pad. Its launch pad is called Dhanush. What is Dhanush? Dhanush is the launch pad, like runway, from where it is launched, from where the rocket is launched. Is it clear? May 30th, 2024, it successfully conducted the first test flight of the rocket called Agniban rocket. Agniban rocket's test flight was conducted in 2024. In a mission called Agniban Sorted Suborbital Tech Demonstrated Mission. Okay. Agniban is a two-stage, okay, 14-ton launch vehicle to lift. It is a two-stage rocket. Is it clear? Agniban is a two-stage rocket. Agniban two-stage rocket. Is it clear? And both the stages are semi-cryogenic. Okay. Both the stages are semi-cryogenic. Is that clear? Right? PSLV solid liquid, GSLV solid liquid cryogenic, SSLV solid liquid, Agniban only 2 stages, both are semi cryogenic. Okay, means they use kerosene as the fuel and the liquid oxygen as the oxidizer. That is Agnilet. And Agnilet is, this is a private rocket, not the rocket of ISRO, not the ISRO's rocket. Then next one, Vikram. Vikram is not a single rocket, it is a family of rockets. Okay, it is the first Indian company to, the company name is Skyroot Aerospace, rocket name Vikram, company name Skyroot Aerospace. It is the first company to be authorized for launching a rocket by the InSpace. Okay, what is InSpace? InSpace is a privatization wing, okay, authorization wing of ISRO, we can say. Is it clear? What is InSpace? Indian National Space Promotion and Authorization Center. Okay, means what the InSpace will do? InSpace will authorize. Authorize means what? Certify. Okay, the private companies. Is it clear? I mean, for which private company you should give permission to make the rockets and launch them. ISRO cannot give permission to any small private company to launch their own rockets, because if they fail, it is a discredit to the nation. Okay, it's not only a problem to that private company, it is an insult to the country also. I mean, like the other countries may develop the trust issues. Okay, so therefore InSpace will authorize, certify a company that it is it's capable of manufacturing the rockets, capable of launching them. Then only, okay, the permission will be given, license will be given to that company to manufacture the rockets and launch them. Vikram rocket, okay, and Skyroot Aerospace is the first company to get authorization from the InSpace. Okay, Vikram series are also private rockets. Is that clear? Then next one, RLV. Next rocket is RLV. I told you that all these are single use rockets. SLV, ASLV, PSLV, GSLV, SSLV, all are single use. But RLV is a shuttle. RLV is a shuttle. Okay, it comes back. It comes back and it can be reused for the next launch. Is that clear? What is the only relaunchable vehicle with ISRO? What is the only relaunchable vehicle with ISRO? That is RLV. SLV, ASLV, PSLV, GSLV, SSLV are not reusable. Okay, they are single use. Only RLV is relaunch vehicle. Is that clear? Yes? Then. And see, try responding once. Try to keep answering to each and every question that I am giving. With that, one benefit is your focus will be retained in the class. For any normal, silly, simple question I ask also, keep a rule that you have to give the answer. With that, your concentration will be retained in the class. Try to do that once. Okay? RLV is the only vehicle which comes back. Do we already have an RLV? No, this is a future mission. We do not have a shuttle. Does ISRO currently possess a shuttle re-entry vehicle? No. RLV is ready, but we are doing the testing. ISRO is putting its reusable launch vehicle through a set of tests. Okay, and this RLV is having first stage is solid. RLV's stage 1 is solid. Stage 2 is, okay, cryogenic or semi-cryogenic. Okay, means like, don't we know? We don't know. It is still in the developmental process. Is it clear? Stage 1 is solid. Stage 2 is either cryogenic or semi-cryogenic. Okay, it is a future vehicle. India currently do not possess a relaunch vehicle. Is that clear? Next, I said that we are doing the test of this RLV. First one is called as, the test is called RLV LEX. LEX means what? LEX means landing experiment. Landing experiment, LEX. Is it clear? For LEX they are using pushback. What is pushback? Is it the original RLV? No, it is a model. It is a model or prototype. It is a model or prototype of the RLV. It is not the original RLV. Is it clear? A prototype called pushback. Okay. The pushback will be carried in Chinook helicopter. Is it clear? Pushback will be carried in Chinook helicopter. Now imagine my right hand is Chinook helicopter and this is pushback. What is this pen cap? Assume the pen cap to be pushback. What is pushback? The model of RLV, not the original RLV. RLV is not ready. Okay, it is just a model of the RLV. Now Chinook helicopter will lift the RLV, okay, to certain height and leave it from there. And the pushback should search for the runway and land onto the runway. The test is whether the pushback can search the runway properly and make a safe landing. It means can it safely come back? That is the test. That is called landing experiment. Is that clear? Yes, clear for all of you? Okay. ISRO successfully carried LEX experiment in 2023, LEX 2 second landing experiment in 2024 and the third landing experiment also in the year 2024. Like this, 3 times Chinook helicopter carried the pushback and left it from there to check whether pushback can search the runway and safely land or not. Okay. 3 landing experiments were completed. For example, in the LEX 3 experiment, the Chinook helicopter lifted this to 4.5 kilometers. Chinook helicopter lifted the pushback to 4.5 kilometers above the ground, height 4.5 kilometers, half a kilometer sideways. Is it clear? Means not straight above the runway. Tell me, is the RLV now, is the pushback now 4.5 kilometers straight above the runway or little sideways to the runway? Yes, everybody? This is runway, my left hand is runway, my right hand is Chinook helicopter, this is pushback, 4.5 kilometers like this and then half a kilometer, 500 meters like this. Is the pushback now right above the runway? No. Okay. So, why it is taken half a kilometer sideways? To check whether it can search for the runway. Where is runway? Where is runway? Where is runway? Where is runway found? Landing. So, to check whether the RLV can search for the runway and land or not. Is it clear? And the LEX 3 is more difficult than LEX 2. Obviously, 10th class exam is more difficult than 9th class exam. Okay. So, the third test is more difficult than the second test. How? In the LEX 3, pushback carried it for more distance. Okay. More altitude and also more distance sideways. For example, okay, in the LEX 2, it is only 150 meters sideways, just only 150 meters sideways. But in the LEX 3, 500 meters sideways. Is it clear? Okay. So, that is LEX 1, 2, 3 experiments, landing experiment. Are the LEX 1, 2, 3 clear? Okay. After LEX 1, 2, 3, what is the next test that we are going to do? ORV. Okay. All of you answer. In the Lex 1, 2, 3, did the Pushpak go to the orbit or just 4.5 kilometers? Lex 3, only 4.5 kilometer. Remember, the low Earth orbit is also, okay, above 160 kilometers. It means, okay, Lex 1, 2, 3, okay, the Pushpak did not go. The Pushpak did not go into the orbit. Is it clear? Just the helicopter lifted it to certain height and dropped it. That's all. But now here, this is ORV. This is orbital re-entry vehicle. Here it will be sent to a bigger safe spacecraft will be sent to 400 kilo. Observe it. Okay, Lex 3, 4.5 kilometers. Whereas ORV, 400 kilometers. Lex 3 in Chinook helicopter. ORV in GSLV. GSLV rocket will carry it till the 400 kilometers orbit and will check whether it can come back from 400 kilometers or not. Means this is a more difficult test, isn't it? It is a more difficult test. Okay. So, clear till now? Right. So, that is how Lex experiments will not go. In the Lex experiments, will the RLV go into the orbit? In the Lex 1, 2, 3 experiments, will the RLV go into the orbit? No. In the ORV experiment, will it go into the orbit? Yes. And which rocket will carry it till the 400 kilometers orbit? GSLV. In the Lex 1, 2, 3, are we using any rockets? GSLV like rockets? No, just a helicopter will take it. Okay. At least in the ORV, are we using the final re-entry vehicle? No. That is also a model. Here also a model is used, but a bigger model is used. Okay. Then after that, the next planned tests are return flight experiment and scramjet propulsion experiment. Scramjet means what? Scramjet means, okay, using atmospheric oxygen. Using atmospheric oxygen. No oxidizer. So that also will be tested here. Done? Is it clear? Devendra Kumar and Gaurav brothers. There are some apps like WhatsApp, okay, and please suggest some other chatting platforms. I'm an old lady, I don't know many chatting platforms, okay, so that they both will offer the prayers successfully to each other, okay. Please suggest them some chatting apps, WhatsApp and funny, I don't remember any more chatting apps. Telegram also you can do the chatting. Okay, so there are multiple apps. Here we all are struggling to achieve something. So at least, okay, give space to us. You people happily enjoy in the chatting, right? Then now coming back to this. So that is our reusable launch vehicle. Is it clear? Then next one and the last one, that is new generation launch vehicle. The next one and the last one is new generation launch vehicle. No problem, Devendra. Thank you so much for mentioning that. Okay. So the new generation launch vehicle. This is going to be the heaviest. I mean, this is heavier than the GSLV. Means it will be the heaviest rocket, and it is also the future rocket. We do not have the GSLV as of now. Is it clear? And it is going to be a 3-stage partially reusable launch vehicle. It's not fully reusable. It is partially reusable. First stage is semi-cryogenic, second stage is semi-cryogenic, third stage is cryogenic. Is it clear? Tell me, what is the heaviest launch vehicle with ISRO? GSLV. Okay, and it is not yet ready, it is a future rocket. Okay, and it is a 3-stage rocket. First stage is semi-cryogenic, second stage is semi-cryogenic, and the third stage is cryogenic, which uses liquid hydrogen as fuel and liquid oxygen as oxidizer. Okay, heaviest launch vehicle currently is GSLV. Okay, NGLV is a future vehicle, but if we make the NGLV, then it is going to be the heaviest launch vehicle with ISRO. Currently heaviest launch vehicle is GSLV Mark III. Okay, and what are the 3 stages? Semi-cryogenic, semi-cryogenic and cryogenic. NGLV will have 3 times the present payload capacity. It means NGLV, new generation launch vehicle, can carry a satellite which is 3 times heavier than the satellite that can be carried by GSLV. Is it clear? NGLV, new generation launch vehicle, can carry 3 times heavier satellite, 3 times heavier payload than the GSLV. Right? Next, with only 1.5 times the cost, only 1.5 times cost, but 3 times heavier, means more economic and very heaviest economic. Okay, and also environment angle also advantage, because it is using green fuels, like liquid methane is used. It is using green fuels, plus environment friendly because it uses green fuels, plus partially reusable. Okay, 3 advantages. It is going to be heaviest. Second one, it is economic because it can come back. Not only that, with just 1.5 times the cost, it can carry 3 times heavier load. Okay. Third one, it is eco-friendly because it is using green fuels like liquid methane. Okay, and also it is partially reusable, partially reusable. At least some of the stages are reusable. So therefore it is also eco-friendly. So that is the story of GSLV. Okay. No, we cannot say it is the 5th generation, not like that. Okay, and it is a future rocket. Done. With that we completed the rockets, types of rockets completed. Types of orbits over, types of rockets over. Now we are discussing types of satellites. Is it clear? Can we proceed? Types of satellites. First, communication satellites. These are the satellites which are used for TV, television communication, internet communication, phone communication, etc. Communication satellites are used for our cell phone towers, receive signals from the communication satellites. TV antennas, your dish TV antennas will receive signals from the communication satellites. Your internet signals comes from the communication satellites. Is it clear? Okay. Satellites used for the communication purpose. Second one, remote sensing satellites. So they will, remote means what? Long distance. Sensing means what? Observing something, detecting something. Is it clear? Okay. They will keep monitoring the earth surface, keep an eye on the earth. They will keep looking at the earth's surface. Okay. They will keep monitoring the weather. They will keep monitoring the resources. Is it clear? Using sensors, cameras, etc. Remote sensing satellites will keep sensing. They are also called as Earth observation satellites. Earth observation satellites. or they are also called as imaging satellites. Imaging satellites. Is it clear? Third type of satellites are called as navigation satellites. They will give you the route planning. Okay, like for example GPS. What do you mean by navigation? Navigation means first it will locate where you are. Is it clear? For example, I will ask the route to Bangalore. Okay, then will it give me the route from Delhi to Bangalore or Hyderabad to Bangalore? It will give me the route from Hyderabad to Bangalore because I am now located in Hyderabad. Is it clear? So it will first locate where you are. From your place to the destination, it will plan the route. Not only the route, it will also tell you the time of arrival. Okay, positioning, route planning, time of arrival. Okay, so this is called navigation. For navigation purpose, the satellites we use are called as navigation satellites. Okay, so remember from what we have studied earlier, what are the best orbits for communication satellites? Tell me. Best orbit for communication satellite, so that you will not hold your TV antenna and keep running, so that you can happily keep the TV antenna fixed at one particular place. Disappointing, you people forgot. Simple logic. TV antenna. Will you hold the TV antenna and keep running? You will fix the TV antenna on your terrace and it will stay there itself. Then it is constantly getting the signals. Means the satellite is located in which orbit? The satellite is located in the geostationary. Is that clear? Very good, very good. Remote sensing satellites, also called as Earth observation satellites, they should keep monitoring the resources. They should keep monitoring. So best place is LEO, right? Because they should be close to the earth. Then only they can do the monitoring effectively. Done. Next, navigation satellites best orbits are MEO. MEO, you can also keep them in GSO, GEO also you can keep them. But the best is MEO. Is that clear? Right. These are the types of satellites. Then after that, here I have given examples of each one examples. 3 types: communication, remote sensing, navigation. First we are elaborating on communication satellites. Example for the Indian communication satellites are INSAT series, GSAT series and CMS satellites, communication satellites. These are the 3 examples. And applications of communication satellites: telecommunication, that is TV signals; education, okay, like teleschool programs like that; telemedicine, for example, you are in a remote forest, okay, and you don't have a doctor there, highly qualified doctor is not there, okay, then what happens? A normal, not a very well experienced doctor, a junior doctor in a forest will do the surgery with the help of a video conference from a specialist in a super specialty hospital in a city. Is that clear? That is called telemedicine. Is it clear? A junior doctor in a forest is doing the surgery. How? The junior doctor do not know how to do this surgery, but he is getting the instructions from a senior doctor in a city through video conferencing. That is telemedicine. Is that clear? Next, mobile satellite services. Okay, satellite television services. Is it clear? Satellite TVs. Satellite TV channels. Okay, then satellite navigation program, that is route planning, television services, disaster management. Okay, why disaster management? To plan the rescue operations. Okay, rescue operations planning. Is that clear? These are the examples and applications of communication satellites. I hope communication satellites is clear for all of you. Moving on to the next one. Remote sensing. What are the second type of satellites? Remote sensing satellites. They are also called as Earth observation satellites. They operate under the Indian remote sensing program. Okay, in India, remote sensing satellites are operated under the Indian remote sensing program. Clear till now? Then examples are IRS series. IRS means Indian remote sensing satellites. Okay, they are located in the low Earth orbit. IRS satellites are located in the low Earth orbit. Clear till now? Next, there are certain orbits satellites like Resource Sat 1 to 2A, Cartosat, okay, 1 to 2A 2B, Resat 1 and 2, Ocean Sat. See, obviously you can understand the purpose of it. Okay, Ocean Sat is used to monitor the oceans. Is it clear? That is to predict the cyclones. Okay, to keep monitoring the ocean related weather monitoring above the ocean. Okay, then it is called Ocean Sat. Resource Sat, it is used for searching like oil exploration, oil, mineral exploration, minerals, that is ores exploration. Is it clear? To search where do you have oil, to search where do you have gold, where do you have lithium. Okay, to search the resources we use Resource Sat. Cartosat is used for mapping purposes. Okay, because cartography means what? Mapping. Mapping means what? Whether you have rocks or mountains or plain areas or plateaus, etc. Is it clear? What kind of a terrain it is? Terrain mapping. That is called cartography. The satellite which is used for cartography is called Cartosat. Is it clear? Megatropics, these are used for clouds monitoring the clouds. Is it clear? So on the whole, they are all used for monitoring purpose. It means they will keep an eye on the earth. Therefore, they are called remote sensing from long distance. Therefore, they are also called Earth observation satellites. IRS satellites are in the LEO, and these are all in the sun synchronous orbit. Is that clear? We also have a few remote sensing satellites in the geostationary orbit also. Example, INSAT 3D, Kalpana, okay, INSAT 3A, INSAT 3D are Earth observation satellites are located in the geostationary. It means in India, the Earth observation satellites are located in the LEO, sun synchronous orbit. Some of them are also located in the GEO, geostationary orbits. Is it clear? They keep monitoring only one place. They keep monitoring only one place constantly. Is that clear? They keep monitoring only one place constantly. Okay, that is remote sensing or Earth observation. Okay, applications of remote sensing satellites. Before I explain the applications, I will first explain the working of remote sensing satellites. Is it clear? Working mechanism. The working of remote sensing satellites. Okay, so remote sensing satellites will work with the help of radars. Is it clear? Radars. A radar is located in the satellite. A radar is located in the satellite. Then first step what it will do, it will emit the radio waves. That is step 1. I will not repeat this, complete focus please. Step 1, the radar in the satellite there will be a radar that will emit the radio waves. I hope you remember radio waves. They are the electromagnetic radiation which is having longest wavelength. Okay, means very low frequency. Emit the radio waves. Step 2, the radio waves will hit some surface. The radio waves will hit the surface, and the surface can be clouds or ocean, okay, or ground or forest, okay, or the polar ice caps, okay, or a crop land, etc. Is it clear? The surface can be anything. They will hit the surface. Is that clear? Then the third step is the surface reflects the radio waves. Is it clear? Okay, it means again they will go back to the satellite. Okay. Then step 4. Okay. The radar will analyze the reflected radio waves and understand the nature of the surface. Is it clear? And understand the nature of the surface. I mean, by analyzing the radio waves, it will understand, is it an ice cap, is it an ocean, is it a land terrain, okay, or is it a cropland, is it a healthy crop or a dried crop, okay, whether you have lithium inside that soil or gold inside the soil or oil inside the soil, all these things can be analyzed. Is it clear? Why? Because okay, the different surfaces will reflect different frequencies of radio waves. Is it clear? This is the total secret. Because of this, it will understand what is that surface. Is it clear? It means, for example, okay, soil having, okay, underneath the soil if there is gold, okay, and the soil under which you have some lithium, will reflect different frequencies of radio waves. Same way, okay, a green crop and a dried crop reflect different frequencies of radio waves. Is that clear? So that you can understand whether it is a dried crop or a green crop. So that you can understand whether it is, same way, white color snow reflects one particular frequency of radio waves. If there is no snow cap, if the earth is not covered by the snow, okay, then the soil will reflect another frequency of the radio waves. Is it clear? Underneath the soil, if you have gold mine, then one frequency of radio waves. You have iron ore, then another frequency of radio waves. So depending on the frequency of radio waves which reach the satellite back, the satellite can understand what resources are present on the Earth's surface. This is how the remote sensing satellites work. Is the working of remote sensing satellites clear? Okay. Then, so remote sensing satellites can be used for crop area estimation. I told you green crop, dried crop, okay, soil, all will reflect different frequencies of radio waves. So based on that principle, we can understand how much crop area is there. Crop production, okay, because I told you green crop, dried crop, green crop will give more production, like that. Next, whether the crop is healthy or not. Soil mapping, it is black cotton soil or the red soil. Because black cotton soil, red soil, both will reflect different types of radio waves. Is the concept clear for all of you? Yes, everybody, please confirm. Step 1, radar will emit the radio waves. Step 2, they will hit the surface. Step 3, the surface will reflect the radio waves. Step 4, the radar will receive the reflected radio waves. Depending on the frequency of the reflected radio waves, the radar can understand the nature of the surface, because the different surfaces will reflect different frequencies of radio waves. Okay. So based on that, drinking water is present or not, because the soil with more water inside will reflect one type of radio waves. If the soil do not have water inside, then it will reflect another frequency of radio waves. Is it clear? Like that, urban mapping, okay, visualization, spatial information, large scale cartography, mapping of the earth. Large scale mapping will be used. This large scale mapping can be used to study the plate tectonics, to study the melting of polar ice caps, okay, to study the changes in the ocean levels. Is it clear? So this large scale mapping cartography can be used by studying all these things. Done. Then resources and environment. I told you how much forest cover you have, how much wetland you have. Biodiversity, is it a tundra, taiga, desert, forest, rainforest, tropical rainforest? Because different types of forests will reflect different frequencies of radio waves. Okay, so these are all the applications of remote sensing satellites. Now, defense satellites. Satellites used for the defense purpose. It means for the reconnaissance or for the surveillance, to keep a watch on a battlefield, to keep a watch on the enemies, okay, during the war. So this is defense satellites. These are the examples. The defense satellites are used for surveillance and mapping, and they are used dedicatedly only for the defense applications. They will not be used for the other purposes. These are the examples of defense satellites. Clear till now? Then moving on to the navigation satellites. Okay. Navigation is the process of accurately ascertaining one's position. As I already told you, it will first find out where you are located. Position. Then planning the route, following the route, and also giving the timing. That is called navigation. Tell me, which navigation satellites we all are using in our mobile phones? For route mapping, which navigation satellites we use? We regularly use GPS, but is GPS Indian navigation satellite system? Is GPS an Indian navigation satellite system? No, it is not Indian. GPS is by NASA, means it is United States of America. Okay, so regularly we can do that, but Can we depend on the GPS for all the situations? We cannot depend on the GPS for all the situations. Why? For example, during Kargil war, we asked some sensitive information about the region, which the USA refused to give. The GPS data USA refused to give. So from that experience we understood that maybe for the regular civilian purposes we may use GPS, but for sensitive situations we cannot always depend on GPS. We need our own navigation satellite system. Do you agree with this? Okay, so our own navigation system is nothing but Indian Regional Navigation Satellite System. GPS will have global coverage. Is it clear? GPS is having global coverage, but the Indian Navigational Satellite System is a regional coverage. It means not global, not the global coverage. Is it clear? It will only cover India plus 1500 kilometers around Indian mainland. Is it clear? Okay. Will the IRNSS give you global coverage? Can you use IRNSS wherever you go in the world? No. It will give the route planning only in India plus 1500 kilometers around India. That's all. It is therefore it is called as Indian Regional Navigation Satellite System. It is also called as Navigation with Indian Constellation, that is NAVIC. Navigation with Indian Constellation, that is NAVIC. The IRNSS is operating with 9 satellites launched, okay, but one failed. Currently there are 8 satellites in the IRNSS system. The Indian Regional Navigation Satellite System is working currently with 8 satellites. In that, 3 are in the geostationary and the 5 are in the geosynchronous. Is it clear? I repeat, Indian Regional Navigation Satellite System, also called as Navigation with Indian Constellation NAVIC. It is not global, it is regional. It is currently operating with 8 satellites. In that 3 are in the geostationary and other 5 are in the geosynchronous orbits. That is the story of IRNSS. Is it clear? And following countries currently have global navigation. USA is having global navigation. Which countries have global coverage? USA's GPS with 31 satellites. Russia's GLONASS with 24 satellites. European Union's Galileo with 24 satellites. China's BEIDO with 35 satellites. Japan's quasi-zenith, okay, with 7 satellites, and it is only regional system. So tell me, USA, Russia, okay, Europe and China. Only they have global coverage. Global coverage. India with IRNSS and Japan with quasi-zenith. They both are regional coverage. Is that clear? Okay. And USA is having 39 satellites, whereas IRNSS only 8 satellites. Therefore, not a global coverage. This is a story of navigation satellites. What are the applications of navigation satellites? Okay. Terrestrial means land, like our car, bike, vehicles, navigation. Aerial, it means route planning for the flights. Marine, that is route planning for the ships. Okay. Disaster management. During disaster I mean to plan the rescue operation. Rescue operations. Okay, it means how to reach the place of the disaster. From the place of the disaster to where you have to rescue the people. So totally planning the rescue operation. Vehicle tracking and fleet management. For example, a fleet of ships are going in the ocean. You have to track them. For that we can use navigation satellites. And you want to track a vehicle. For example, a child is going in a car. Okay, then you can keep tracking that car. Is it clear? Like that. Integration into the mobile phones. Yes, the navigation system we have in our mobile phones. We use GPS in our mobile phones only, isn't it? Precise timing and mapping, not only route, precise time it will give. Exactly by what time you will reach there, it can predict. Is it clear? And terrestrial navigation for hikers and travelers. Hikers means bikers, the people who go for biking, for them route planning. Visual and voice navigation, it means you can see the route. Also it will give you voice commands, that is take right after 10 meters, like that. These are the applications of navigation satellites. Okay. Next one is in the navigation only. It is called GPS aided geo augmented navigation, Gagan. As the name is reflecting, it is for route planning or navigation for flights. Is it clear? It is for navigation for the flights. Is it clear? It is developed by ISRO and Airports Authority of India. Okay, ISRO and Airports Authority of India together developed this. Why? For the route planning of the flights. Is it clear? This is to replace the ground-based navigation. It means earlier the flights used to get navigation from the ground-based control centers. But now the flights can get the signals from the satellites. Is it clear? Earlier, ground-based navigation, but Gagan is satellite-based navigation, and this is more accurate. Okay, it means when you have a flight, imagine this is a flight. I'm sorry for my ugly drawing of the flight. Earlier the signals used to come from the ground. Now the signals are coming from Gagan, means satellite signals. This is more accurate. Is it clear? Okay, because no disturbances for the signal. Is that clear? That is the purpose of the Gagan. Is that clear? Done. Gagan system is interoperational with other international systems like US, okay, Europe, Japan, etc. Is it clear? Okay. So the USWAAS, European EGNOS, Japan's MSAS and India's Gagan work together. Okay, they all will work together. Gagan is already operational through GSAT 8, GSAT 10, GSAT 15 satellites. These are the 3 satellites which are providing route planning to the flights. Is it clear? Currently, our flights are getting the navigation from GSAT 8, GSAT 10, GSAT 15 satellites. Done? Okay, this is about the navigation satellites. In the navigation satellites, we have NVS series. These are critical for the robust independent regional navigation system. What is NVS? It is IRNSS only, but second generation satellites in the IRNSS. Is that clear? Advanced second generation navigation satellites. Okay, clear? advanced second generation navigation satellites, right? Total plan is 5. Okay, total plan is 5 NVS satellites. Currently, 2 NVS satellites are launched, NVS 1 and NVS 2. All of you tell me, total, what is NVS series? NVS series is Advanced Navigation Satellites, second generation navigation satellites. Okay, better than this GSAT 8, GSAT 10, GSAT 15, etc. Better than that. Is it clear? Better than the currently used navigation satellites. Total how many NVS series we are planning? Total how many satellites we are planning in the NVS series? NVS series is a total of 5 satellites. They are second generation advanced satellites. But currently how many are launched? 2 are launched. Okay. First one is NVS 1. It is replacement for IRNSS 1G. IRNSS 1G. I told you that NVS series are the advanced second generation navigation satellites in the IRNSS or NAVIC. Is it clear? Indian Navigation Satellite System. Why? Okay, to replace the older satellites. Okay, which are either failed or completed the lifespan. Either failed or completed the lifespan. Is that clear? See, I told you that the IRNSS is currently Indian Regional Navigation Satellite System, or Navigation with Indian Constellation, is currently having 8 satellites. Is it clear? In this, some satellites are, total 9 launched, but 8 are functional. It means 1 failed, isn't it? 1 failed. And some of them, is it clear? 8 out of 9 are functional, isn't it? Means 1 failed. Or the other satellites are not failed, but their lifespan is completed. So you have to replace them with the new and advanced versions. That is the purpose of NVS. Is the NVS purpose clear for all of you? To replace the older satellites which are non-functional, which are failed or completed their lifespan. For example, the NVS 1 is to replace the IRNSS 1G, which is an older satellite. Done. Why failed? Okay, like see, nothing is, there are so many hundreds of failed. Why Chandrayaan 2 failed? There are more failed missions than the successful missions. Okay, why it will fail? Simply because nothing is 100% accurate. Okay, in fact, like ISRO is in a much better space research organization. I'll tell you one small thing. ISRO is the first space agency to launch a satellite to the Mars in its first attempt, whereas NASA did it in its 7th attempt. 7 failed attempts are there. Why? So many technical reasons can be there for that. Is that clear? Okay, of course, technical issues, right? And what is the function of NVS series? These are the advanced second generation satellites which can replace the failed or successful only, but lifespan is completed, their satellites. For example, NVS 1 will replace the IRNSS 1G. It incorporates L1 band, okay, L5 and S band. Then I have to tell you what is L1, what is L5, what is S. Okay. See, I already told you the meaning of the word spectrum, isn't it? Spectrum means what? A range of. Okay, spectrum means range of frequency or a range of wavelength, isn't it? A range of frequency or the range of wavelength. Then what do you mean by a band? Band is also same definition. Okay, that is a range of frequency or a range of wavelength. Then you may ask me, ma'am, in that case, what is the difference between spectrum and band? Okay, band is a part of the spectrum. Part of the spectrum. For example, if I compare spectrum with a sentence, band can be compared with one word. You have several words in a sentence. Like that, you have several bands in the spectrum. Is it clear? Example, L band, S band, etc. Is that clear? L band, S band, KU band, etc. Is it clear? I will show you that once. Look at this. This is L band. What is L band? I told you band is a range of frequencies. L band means what? 1 gigahertz to 2 gigahertz range. That range of, so what is it? It is a, okay, L band is nothing but a range of frequency, 1 gigahertz to 2 gigahertz. Is that clear? Okay. S band is another band. S band frequency is 2 gigahertz to 4 gigahertz. KU band is 12 gigahertz to 18 gigahertz. Is the band concept clear for all of you? Spectrum is a range of frequency. Band is also a range of frequency. But band is a smaller range. You will have several bands within the spectrum. Okay. We use different bands of, okay, we use, complete focus please. We use different bands in different radars. I hope you remember radars, how the radars work. Okay, radar will emit the radio waves, they will hit the surface and the surface will reflect the radio waves. Radar will analyze that. Okay, so when a radar is emitting the radio waves, different radars emit different radio waves. Is it clear? I mean, different radars emit radio waves of different bands. For example, one radar will emit the L band radio waves. The other radar will emit the S band radio waves. Is that clear? So like that, different radars will emit different frequency bands. Clear till now? Okay, because anyway we are discussing about the bands, let us complete this NISAR mission. Let us complete this NISAR mission because anyway we came till here. Okay. NISAR mission was launched 30th July 2025. Are you all following? NISAR mission was launched 30th July 2025. Launched in the vehicle called GSLV F-16. Launch site is Sriharikota. Launched from Sriharikota. Reached which orbit? Entered the sun-synchronous orbit. Okay. It is the first satellite to work in two different radar frequencies, L band and S band. NASA will give, what do you mean by NISAR mission? NASA ISRO synthetic aperture radar. Is it clear? Okay. NISAR mission means NASA ISRO synthetic aperture radar. NASA ISRO synthetic aperture radar. Is it clear? What do you mean by a synthetic aperture radar? Okay. See, radars are two types. Okay. First one, beam radars. Beam radars means they are fixed and they are like a pendulum. Okay, like this. It means the radar is fixed in one place and it can just keep moving like a pendulum. Is it clear? Second type are called synthetic aperture radars. They are mobile. They are fixed onto an aircraft. Or a spacecraft. Is it clear? Okay. Now tell me, can a beam radar study a larger surface? Can a beam radar cover larger surface on the earth? Or a synthetic aperture radar can cover larger surface of the earth? Yes, everybody please. This is earth and this is a satellite. Okay, and to that you have imagine this is the synthetic aperture radar and this can cover the total earth surface, isn't it? It can cover the complete earth surface. Is that clear? It can cover the complete earth surface, right? So synthetic aperture radars are the mobile radars. They are fixed to an aircraft or a spacecraft. So therefore they can cover larger surfaces. They can study larger surfaces. Beam radars are fixed. They will just move like a pendulum. So they can cover only this much surface. That's all. They cannot cover the total earth. That is a synthetic aperture radar. Usually one satellite will have only one radar, but the NISAR mission, NASA ISRO synthetic aperture radar, is having two radars. One radar works in the L-band synthetic aperture radar and ISRO will provide S-band synthetic aperture radar. Is that clear? Okay, like this. It will emit. NASA's radar emits L-band, 1 to 2 gigahertz radio waves, whereas the ISRO's radar, okay, emits S-band radio waves, that is 2 to 4 gigahertz radio waves. It means high frequency radio waves. Okay, then these two together is called as, the NISAR mission, NASA ISRO synthetic aperture radar. It is the first satellite which is using two different radars in two different frequencies. Is it clear? And it allows the mission to observe the wide range of changes from the flow rates of glaciers, how the glaciers are moving, how the polar ice sheets are melting, how the tectonic plates are moving, dynamics of the earthquakes. Okay, are the volcanoes going to erupt? Are there any changes in the biomass? Like are there any changes in the forest cover? Are there any natural hazards coming, or sea level is increasing or decreasing, groundwater is increasing or decreasing? Like that, it can study several things about the earth. Is it clear? That is NISAR mission. Beautiful, right? And it is designated to map the entire earth every 12 days. In 12 days, it will map the complete earth once. Okay? How many days it will take to map the complete earth? 12 days. Is it clear? So it means for 3 years it will work. So in 3 years it will map the complete earth multiple times. Isn't it? Total span is 3 years and it will take only 12 days to map the complete earth. So in the span of 3 years, multiple times it will map the earth. This is NASA ISRO synthetic aperture radar. So this band's completed. Electromagnetic spectrum also I have already explained. I told you first radio waves, then micro, then infrared. Then after infrared comes red. Okay. And then violet. After violet comes the ultraviolet, then X-ray, then gamma rays. Gamma rays are the high frequency. Radio waves are the low frequency. I hope all these points are clear. Hope you remember them all. Okay. Then, so with this NASA ISRO synthetic aperture radar completed. But can anybody tell me from which topic we migrated to NASA ISRO synthetic aperture radar? We skipped several slides like this. Okay, from which topic? Yes, can anybody tell me? Navik. That is second generation satellites in the NVS series. They are the advanced second generation satellites in the IRNS series. Okay, very good. NVS, advanced second generation navigation satellites in the IRNSS series to replace the older ones. Example, NVS 1 replace IRNSS 1G. And like NISAR mission, it is also using L5 and S bands. Is it clear? L5 and S bands. And it can cover, okay, it can penetrate the clouds, fog, rain, storms and vegetation. It can penetrate all those things and can study the earth and can keep watching the earth. For the first time in indigenous, okay, rubidium atomic clock is used. Then you may get it out, what is an atomic clock? About atomic clocks, okay, in another phase of Conquer Prelims, I discussed on the app. Okay, some of you might have watched it on the Unacademy app. Okay, I discussed, I have taken 3 sessions on only one topic, that is universe. In that I discussed about the dark matter, dark energy, matter, antimatter, star life cycle, pulsars, quasars, asteroids, okay, then particles like Higgs bosons, fermions, baryons, hadrons, etc. Okay, and then Large Hadron Collider, neutrino observatories, black holes, wormholes, time traveling, space-time fabric, Einstein's special theory of relativity, Einstein's general theory of relativity, all these topics with one title called universe I have taken in 3 sessions. In that I have also discussed about the atomic clocks. Any of you have watched that sessions? Yes, any of you watched those sessions? You're able to hear me? Okay, then do watch it. I have given the links for that sessions here. I'll show you the links. Okay, I provided the links for those sessions in this PPT. Okay, so go through that sessions also. That is very, very important and very, very interesting as well. Done? Okay, then. So now let us study the astronomical satellites. Some astronomical satellites. Astronomical satellites are the satellites which will study about the deep space. Deep space. Is it clear? Okay. Like first one is called AstroSat, but it is not very important. Another one is called XPOSat, X-ray polarimeter satellite. Okay, can we study about this? Yes, complete focus please. XPOSat, X-ray polarimeter satellite. Now, what is this X-ray polarimeter satellite? Okay, it will study the polarization of X-rays. Okay. See, I will explain this. You know that X-rays are electromagnetic radiation. X-rays are electromagnetic radiation. And every electromagnetic radiation will have an electric field and a magnetic field. Electric field and a magnetic field, right? And this electric field and magnetic field are perpendicular to each other. Is it clear? Okay, if one field is in this direction, the other field will be in this direction. Electric field and magnetic field are perpendicular to each other. Is it clear? Then, what do you mean by the word polarization? Polarization is nothing but the direction of electric field of an electromagnetic wave. Is the definition clear? The direction of the electric field is called as polarization. Done? Direction of the electric field. In which direction the electric field is there, that is called as polarization. Okay? Then XPOSat will study the polarization of see, every electromagnetic wave, it means radio waves, infrared, UV, X-ray, gamma rays, visible light, all electromagnetic radiations will have electric field, magnetic field. All electromagnetic rays will have polarization. But XPOSat will study the polarization of which rays? Everybody? XPOSat will study the polarization of which electromagnetic radiations? Polarization of X-rays. See, all of you do one thing. Simply follow one simple tip. The tip is, I may ask you very simple questions. I may just ask you to repeat what I said. I may just tell you one point and then immediately I may ask it. But still, okay, do give me the answer. When you keep a rule that you have to give me the answer, for that reason you will listen the class more seriously. I mean, you will be more alert and more attentive during the class. So try to follow this tip. You can more effectively retain the concentration, right? Okay. Now, so tell me, polarization is direction of which field of an electromagnetic wave? Fast please. Don't try hard, just keep answering. Automatically you will focus. Okay? So you are saying fun entertainment is your name and you are saying that you are trying hard to focus. Don't try hard to focus. Simply keep one rule. Keep responding. Keep saying, just type the letter Y. Yes, 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 yes. As if you say, ha, ha, ha. When your mother tells you a story, same way you listen to the class, you will automatically focus, right? Okay, and keep answering to don't try hard, try easy thing, easy tip. Okay, keep responding to my every word, you will automatically retain the focus, right? Try this. All of you tell me, what is polarization of an electromagnetic wave? The direction of the electric field. Okay. ExpoSat will study the polarization of which rays in the electromagnetic spectrum? Right? ExpoSat will study the polarization of X-rays. Very good, very good. Continue the same. ExpoSat will study the polarization of X-rays. These X-rays are coming from the X-rays from cosmic sources. X-rays from cosmic sources. Like, okay, see, ExpoSat is launched by ISRO, launched on 1st January 2024. Lifespan is 5 years. The objective is to study the polarization of X-rays, okay, why? To understand the nature as black holes, neutron stars, etc. It means it will study the polarization of X-rays coming from cosmic sources like black holes, neutron stars, etc. Then you will get one doubt, that is, ma'am, we heard that black holes neither emit the radiation nor reflect the radiation. But you are saying that the black holes will emit the X-rays. You are saying that ExpoSat will study the X-rays coming from the black hole. So ma'am, do radiations come from the black hole? Do black holes emit the radiations? Yes, black holes do emit the radiations. Is it clear? So it means in our school days when we heard that black holes will neither emit the radiations nor reflect the radiations, anything including the light, when it goes into the black hole, it will never come back. This is not correct. With our present knowledge, we know that even the black holes emit different types of radiations. Even this topic I discussed in my Mysteries of Universe, my favorite subject, on the Unacademy app in the free sessions. The links I have provided in this PPT, I will show you the links, but at any cost don't miss the Mysteries of Universe to study all these unexpected topics, that is black holes emitting the radiations and all those things, right? Okay, right. So now, okay, ExpoSat will study the polarization of X-rays coming from them. Why? To understand their nature. So on the whole, we use ExpoSat to study the nature of the black holes. We use ExpoSat to understand the nature of neutron star. We use ExpoSat to know whether it is a black hole or a neutron star. Is it clear? That's all. That is the story of ExpoSat. Done? Done, clear? I repeat 3 points. Okay. Every electromagnetic wave will have an electric field, magnetic field. Second point. These two fields are in perpendicular to each other. and polarization means the direction of electric field of an electromagnetic wave. Then XPOSAT will study the polarization of the X-rays coming from the cosmic sources. Means it will study the polarization, the direction of the X-rays coming from the black holes, neutron stars, etc. Why? Because using these X-rays it will understand, XPOSAT can understand the nature of that black hole. Is it a black hole or a neutron star? Is it a black hole or a white dwarf? Okay, what object it is, what is its nature, these things you can study using the XPOSAT. I hope XPOSAT is clear. It has two payloads, I mean two instruments called as POLIX and EXPECT. POLIX means polarimeter instrument in X-rays and EXPECT means X-ray spectroscopy and timing. These are the two instruments in the XPOSAT mission. So with that, XPOSAT mission is clear. How polarization EF of EMW. No dear, okay, Devendra Kumar, okay, polarization is not the electric field. The word polarity means direction. You know that? Polarity in general means, for example, I am more polarized towards Hindus or I am more polarized towards Muslims. So what does it mean? I am more inclined in that direction. Polar means direction. So polarization means direction. So direction of which field? Direction of electric field. Direction of electric field of the electromagnetic waves. Electromagnetic waves. Electromagnetic waves will have two fields. Polarization means direction. But polarization, that is direction of which field? The direction of electric field of the electromagnetic waves is called as polarization. Is that clear? Devendra, clear for all of you? And it will study, XPOSAT will study the polarization of the X-rays. These X-rays are coming from, okay, imagine like this. Let us suppose you have a black hole here. Then always perpendicular can influence. No, they are always in perpendicular directions. Okay? Electric field, magnetic field are in perpendicular directions. Now ignore the magnetic field. Then see the direction of the electric field. That is called the polarization. Okay, it is not about influence. There are two directions. Ignore one direction, check the other direction. That direction is called polarization. Okay. An electromagnetic wave will have two directions, two fields, electric field, magnetic field. They both are, if one goes like this, the other goes like this. They both are perpendicular to each other. Then ignore the direction of the magnetic field. Check the direction of the electric field. That is called polarization. And XPOSAT will study the polarization of X-rays. Devendra, clear? Okay. Then, now, just 1 second please. Okay, so that is the XPOSAT. Then let us suppose that it is a black hole and it is emitting the X-rays. The black hole is emitting the X-rays, right? Then this is our XPOSAT satellite, okay? And XPOSAT will receive that X-rays. Is it clear? Now XPOSAT will, okay, will study the polarization. That is the electric field's direction of this X-rays. by studying that, okay, by studying that, it will understand that, the X-rays are coming from a black hole. Okay? I repeat, listen carefully, more focus please. Just 1 second. One second please. Right. So, okay, I repeat, look at here, this is a black hole. The black hole is emitting the X-rays. In general, we think that the black holes do not emit any radiations, but actually black holes emit the radiations. The black hole is emitting the radiations. These X-rays will hit the XPOSat mission. What is it? It is a satellite. What is it? It is a satellite. The satellite called XPOSat. Then the XPOSat will study the electric field's direction of these X-rays. XPOSat will study the polarization of these X-rays. By studying these X-rays, it will understand the nature of the source. XPOSat understood that these X-rays are coming from a black hole. Or XPOSat will understand that these X-rays are coming from a neutron star. Like that. That is the role of XPOSat. Clear till now? There is no direction for the overall wave. There are two directions. Electric field direction is there, magnetic field direction is there. The wave do not have a single overall direction. Okay, wave will have the wave is oscillating in two directions. Okay, Devendra? I hope it is clear. Now, that is about the XPOSat. After that, we are moving on to the moon missions, that is lunar missions. Can we proceed? Moon missions or the lunar missions. Here, let us take a small break for around 10 minutes. Is it clear? Let us join back again at 10:40 p.m. Okay, we'll assemble back again at 10:40 p.m. to complete the moon missions or the lunar missions, right? Welcome back after the break. You're able to hear me? Am I audible, visible? Right. Thank you. So now let us continue with the moon missions. In the moon missions, first I have given a table of contents for Chandrayaan 1, 2, 3 because they are old. Okay, they are not very important for us. Is it clear? Avinash, regarding the notes, it is not decided by us. Okay, so the notes we will provide to the administrative staff and they will upload it wherever they want to upload. So I am sorry for that. So that is not completely in my hands, right? Okay, the administrative team will upload it, right? Then, so now Chandrayaan 1, 2, 3. So can we continue that? Chandrayaan 1 is only an orbiter and an impactor. Chandrayaan 3 is an orbiter and an impact probe, right? So what do you mean by an orbiter? So let us see different things that we have. Okay, orbiter means what? Imagine if this is the moon. Then an orbiter, explain it. Orbiter will orbit around the moon. Is it clear? It will just keep orbiting around the moon, right? It will not land on to the moon. Done. Then second type is like this one. Okay, it will touch the moon surface. This can be two types. It can be either impactor or soft landing. Is that clear? Either impactor or soft landing. Okay. Impactor means it will go and hit the moon surface. Soft landing means it will softly land onto the moon surface. Okay. Impactor was used in Chandrayaan 1. Soft landing is used in Chandrayaan 2 and Chandrayaan 3. Is that clear? Soft landing, in both the cases it will touch the moon surface. If it hits the moon surface, that is called impactor. If it slowly lands onto the moon surface, then it is called as soft lander, soft landing. Is that clear? Then, so in the Chandrayaan 1, what you have? Orbiter and impactor, not soft landing. Whereas in the Chandrayaan 2, orbiter, lander and then rover. So now let us see what is the rover. Rover comes out of, okay, rover comes out of the okay, this is like a rover. Okay, it will move on the moon surface, isn't it? It will move on the lunar surface. Is it clear? Orbiter will keep orbiting around the moon, not on the surface. Rover will have wheels, like a car is moving on the earth surface. The rover will keep moving on the moon surface. Done? After the soft landing, the rover comes out. In the Chandrayaan 3, we have propulsion module. Observe it clearly. Propulsion module means we don't have a orbiter. We don't have an orbiter. There is no orbiter in Chandrayaan 3. Why? Because it uses Chandrayaan 2's orbiter. Is that clear? Chandrayaan 3 uses the orbiter of the Chandrayaan 2. Why? Because Chandrayaan 2 is a failed mission, isn't it? In the Chandrayaan 2, okay, orbiter is successful, but lander and rover failed. But Chandrayaan 2's orbiter is still orbiting around the moon. When the Chandrayaan 2's orbiter is still orbiting around the moon, why should we send another orbiter? Waste. So, we use only propulsion module. What the propulsion module will do? Propulsion module will carry complete focus, and please follow that tip. Just keep responding. Say yes. Just keep typing the letter Y. Yes, 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 no, no, answer. Automatically your concentration will be retained. Okay, sincerely follow that advice. Okay, see what the propulsion module or I'll show you here. Imagine if this is the earth. Now earth till here, from the earth till here. From the earth till the moon orbit, that is called propulsion module. Is that clear? It will propel the spacecraft from the earth to the moon's orbit. What the orbiter will do? It will orbit around the moon. What the impactor or lander will do? It will go and touch the moon surface. What the rover will do? It will walk on the moon surface. Done? And you need not even say yes ma'am. Just simply type the letter Y. Simply keep it short. No problem. I don't want yes ma'am. Right? Thank you. Thanks for all the respect that you are giving. But simply type the letter yes. Be alert. Be attentive. That is more important for me. Okay? Right. So what which module will, you can just type the first letter, try that. Which module will propel the lunar mission from the earth to the moon's orbit? Which module will carry this from the earth to the moon's orbit? Propulsion module. You can simply type the letter P also, but just keep responding. Very good. Propulsion module. Okay. Then which module will orbit around the moon? Will orbit around the moon? Orbiter, right? Then which module will go and touch the moon surface? It can be hard or soft. Okay, if it is hard, it is impactor. If it is soft, it is lander. Okay. Then which module will move on the moon surface? Rover. Do we have an orbiter in the Chandrayaan 3? Chandrayaan 3 do not have an orbiter. Why Chandrayaan 3 do not have an orbiter? Because it uses the orbiter of the Chandrayaan 2. Why? Because anyway Chandrayaan 2's lander and rover failed. So the Chandrayaan 2's orbiter is simply orbiting the moon there. So we can use the same orbiter. Is that clear? That's all. That is Chandrayaan 1, 2, 3. Okay. Now look at here. What is the primary objective? Mapping the moon surface. Here the primary objective is soft landing on the moon surface. And here it is soft landing on the moon surface. Chandrayaan 3 is also soft landing on the moon surface. For Chandrayaan 1 they used PSLV XL. Chandrayaan 2 GSLV Mark 3. Chandrayaan 3 is also GSLV Mark 3, but it is renamed as LVM 3. Okay. LVM 3, GSLV Mark 3 mean the same. GSLV Mark III M1 means mission 1. M4 means mission 4. Is that clear? Mission 4. Okay. Components. How many payloads? There are 11 payloads. 11 payloads means 11 instruments. 11 payloads means 11 instruments. Here there are 8 instruments in the orbiter, 1 instrument in the lander, 1 instrument in the rover. Okay. And in the Chandrayaan 3 there is 1 instrument, 1 payload in the propulsion module, 4 payloads in the lander, 2 payloads in the rover. Okay. Outcome. Chandrayaan 1 was successful. Chandrayaan 2 is a partial success because orbiter is successful but lander and rover failed. Chandrayaan 3 is successful, and with Chandrayaan 3 India became the first country to make the soft landing on the south pole of the moon. Is it clear? India became the first country to make the soft landing on the south pole of the moon. Next, key innovations. Chandrayaan 1 confirmed the presence of water on the moon, and Chandrayaan 2 made the first attempt of soft landing. Chandrayaan 3 successfully soft landed on the south pole of the moon and brought us a world record. With that, ISRO became the first space agency in the world to achieve the soft landing on the south pole of the moon. Is that clear? Right. Now, after completing Chandrayaan 1, 2, 3, now let us see Chandrayaan 4. Okay, can we proceed? Chandrayaan 4. Chandrayaan 4 will have 1, 2, 3, 4, 5 modules. There are 5 modules in the Chandrayaan 4. The first module is propulsion module. It will carry this from the Earth to the moon's orbit. Isn't it? Then descender module. Descender module, it is like lander. It is like lander. It will land on the moon. It will make landing on the moon. Is that clear? But here there is a new module which is not used in the Chandrayaan 1, 2, 3. There is a new module which is not used in the Chandrayaan 1, 2, 3. Let us see what is that. That is called the ascender module. Look at here. Okay. Right. What is that called as? Ascender module. Okay. And what is this? This is impactor or lander is a descender. Descender. Observe the arrow mark. It is going from the orbit onto the moon surface. Whereas the ascender module is coming from the moon surface towards the orbiter. Is that clear? Moon surface to the orbiter. Like this. Is that clear? Why do we use ascender probe? Ascender probe is used to collect the sample and return the sample to the orbiter. Is that clear? To collect the lunar sample, collect the soil from the moon, and will again go back to the orbiter. Done? Then there is another new module here called transfer module. Is it clear? Transfer module, what it will do is, look at here. This is transfer module. Look at this. Transfer module It will facilitate maneuvers from the module's journey and the docking. Means it will go like this. Okay, means from the ascender probe to the orbiter. What is that called as? Transfer probe. Okay, and what do you mean by docking? Docking means, look at here. This is one component, this is another component. The two components fitting into each other is called docking. Okay, undocking, docking, undocking, docking. So transfer module will do the docking with the orbiter. It means it will hand over the lunar sample to the orbiter. Is that clear? It will hand over the lunar sample to the orbiter. Clear till now? Yes? So, okay, then next one, re-entry module. Re-entry module will, look at this. Which color should I use now? Okay. Re-entry module will come like this. Is that clear? What is that called? Re-entry. Means it will bring the lunar sample onto the earth. It will bring the lunar sample onto the earth. Done? I don't have an orange color there. Is that clear? What is that called as? That is re-entry module. Okay. Now your memory check. Okay. You can use only the first letter of the word, but I want everybody to answer. Name that module. Name that module. Okay, which will carry the spacecraft from the Earth to the Moon's orbit. Earth to the Moon's orbit. Everybody please. Earth to the Moon's orbit. Propulsion module. Name that module which will orbit around the Moon. Which will orbit around the Moon. Orbiter module. Is it clear? Very good. Name that orbit which will touch the Moon surface. It may hit or it may do soft landing. Okay, that is descender, impactor or lander. Is it clear? Descender, impactor, lander. Done? Descender, impactor, lander. Then name that module which will walk on the Moon surface so that it can collect the sample from different locations on the Moon. It will walk on the Moon surface so that it can collect samples from different locations on the Moon. Rover. Then after collecting the lunar soil from the Moon, name which module will go back to the orbit. Which module will go back till the lunar orbit? Ascender module. Which module will connect the ascender module with the orbiter? Docking of the ascender module with the orbiter so that the ascender module will give the sample to the orbiter. The connecting link between ascender and the orbiter, docking link, transfer probe. Then which module will bring the lunar sample back onto the earth? Which one will bring the lunar sample back onto the earth? Re-entry module. That's all. Like this, we have 5 modules in the Chandrayaan 4. And Chandrayaan 4 is a future mission. Chandrayaan 4 is a future mission. Is that clear? Then, orbital docking, sample collection. I already told you. Orbital docking, which module will do that? The transfer module will do that. This docking we have already demonstrated in the SpaceX experiment in January. Okay, space docking experiment already demonstrated the docking facility in the January 2025. Okay, so for sample collection we use robotic arms. In the Chandrayaan 4, robotic arms will collect the sample. Sample handling. Okay, fine. Chandrayaan 4 will bring the sample, lunar sample, to the earth. Then on the earth we need some laboratories to analyze that sample. Okay, so we are constructing a specialized facility is being developed by ISRO to store and study the sample. To store the sample and study the sample. I repeat, to store and study the lunar sample on the earth. ISRO is developing a new laboratory or a new facility. These are all the points about Chandrayaan 4. Now moving on to the Chandrayaan 5. Chandrayaan 1, 2, 3, 4 are purely ISRO's missions. But Chandrayaan 5 is not only an ISRO's mission. Chandrayaan 5 is it is also called as LUPEX. Okay, it is a joint venture of ISRO and JAXA. That is India, Japan together are constructing this. Is it clear? And Chandrayaan 5 is also called LUPEX. LUPEX means what? Lunar Polar Exploration Mission. Lunar Polar Exploration Mission, LUPEX. Okay. Launch date expected to be launched, estimated in 2028. Is it clear? Launch vehicle H3 rocket. It means Chandrayaan 5 will not be launched from ISRO. Chandrayaan 3 will be launched by a Japanese rocket called H3 rocket. Is it clear? The main objective is to study the moon's south pole. That is the reason why it is called Polar Exploration Mission. Okay? Polar Exploration Mission. The main target is to explore the moon's south pole. In this, lander is developed by ISRO and rover is developed by JAXA. The rover of the LUPEX mission is going to be very heavy when compared to the rover in the Chandrayaan 3. Is it clear? Chandrayaan 3's rover, LUPEX rover, which is heavier? LUPEX rover is going to be much heavier, bigger rover. Landing site is south pole of the moon. The mission duration is around 3.5 months. It will stay on the, Chandrayaan 3's rover stayed only 14 days on the moon surface, isn't it? Whereas LUPEX rover will stay 3.5 months on the moon's surface. Is that clear? It will stay 3.5 months on the moon's surface. And other scientific instruments are from NASA, and European Space Agency is also providing some instruments. So NASA, European Space Agency, Japanese Space Agency and ISRO, it's a collaborative effort by multiple countries. That is LUPEX mission. Okay. And in the LUPEX mission and Chandrayaan 3 and LUPEX, that is Chandrayaan 5. Okay. What is the common point? The common point is soft landing on soft landing on the South Pole. Soft landing on the South Pole, isn't it? But what is South Pole? Because it is, South Pole is unexplored. Unexplored. That is the reason why we have more curiosity around the South Pole. Is that clear? Right? That is the reason why Chandrayaan 2 tried soft landing on the South Pole but failed. Chandrayaan 3 made a successful soft landing on the South Pole. Again, LUPEX mission is also to explore the South Pole. Why so much curiosity around the South Pole? Because it is unexplored. We do not know much about the South Pole of the moon. Is that clear? There are two unexplored regions on the moon. One is, okay, look at here. If this is the Earth and this is the moon. This is the moon. Then, okay, this is North Pole, this is South Pole. Okay, so the South Pole, number one. Second one, this is called, okay, the far side of the moon. Far side of the moon, and it is also called as the dark side of the moon. Far side of the moon or the dark side of the moon. Is it clear? Okay. Why? Because moon will never face, it means we have never seen, okay, from any place on the earth till now, we have never seen the other side of the moon. It means we always see. We always see only one side of the moon. We always see only one side of the moon. Is that clear? Right. The other side is called far side of the moon. Right. Why do we always see one side of the moon? I have explained it here. Look at this animation. It is a beautiful animation to explain why do we see only one side of the moon. Due to a phenomenon called as tidal locking. Tidal locking means, okay, the time taken. I'll explain the tidal locking concept. Okay, tidal locking means for the moon's day is equal to moon's year. Is that clear? Moon's day is equal to moon's year. What do you mean by moon's day? Day means moon's, okay, rotation around its own axis, isn't it? Moon's rotation around its own axis. Moon's year means what? Moon's revolution around the earth. Is that clear? And both are 29 days. It means moon will take 29 days to, okay, complete one rotation around its own axis, and moon will also take 29 days to complete one revolution around the earth. Is that clear? But for earth it is not like that. How much time earth will take to complete one rotation around its own axis? 24 hours. How much time it will take to complete one revolution around the sun? 365 days. For earth they both are not the same. But for the moon they both are the same. Moon will take 29 days to complete one rotation, and also same 29 days to complete one revolution. So that is that is called tidal locking. So because of this reason, what happens? Look at that animation. Okay, check, this is the earth and this is the moon. Okay, now look at the moon. Okay, we always see the face of the moon. We are never seeing the back side of the moon, isn't it? Why? Because of this reason. Because of the tidal locking, we can never see the far side of the moon. This is how the moon is orbiting. Done? Clear? Check the animation. Throughout the orbit, at any time, can we see the other side of the moon? We are never seeing the other side of the moon, wherever you are located on the earth. Why? Because the time taken for its rotation is equal to the time taken for its revolution. Okay? So, that is the reason why. There are two unexplored regions. There are two unexplored regions on moon. Number one is South Pole. Number one is South Pole. Number two is far side of the moon. No, far side receive the light but not from the earth. Is it clear? Far side will receive the light from the other objects in the solar system. Okay? Far side does not receive any radiations from earth. And it is called dark side because, not because it is dark, but because we don't know about that. We don't know about this side of the moon. Is it clear? Like dark matter. We are dark about that. Not because it is, far side is not dark. Obviously, look at here. Can the far side receive the radiations from the earth? Can the far side receive the radiations from the earth? Anonymous member, I have also covered biotechnology in detail. One entire marathon I have taken only on biotechnology. Go to the Unacademy IAS English channel. Okay, find the first part of the marathon sessions. Okay, I have done biotechnology in one shot. Okay, so, but can the far side receive the radiations from the other sources in the solar system? Or is it completely dark? It can receive the radiations from the other sources. So, far side is not dark. Then why do we call it as dark side? Because we don't know about that. What are the two unexplored regions on the moon? Quickly tell me. You can use only the first letters. What are the two unexplored regions on the moon? Number one, South Pole. Number two, far side. In that, okay, Chandrayaan 3 and Chandrayaan 5 focused on the far side or the South Pole? Chandrayaan 3 and Chandrayaan 5 LUPEX mission, they both focused on the South Pole or on the far side? They both focused on the South Pole, not on the far side. Is that clear? Next. But China's Chang'e 4 mission landed on the far side. The world's first mission to make a soft landing on the South Pole, Chandrayaan 3. The world's first mission to make a landing on the far side, Chang'e 4 by China. Is it clear? Speciality of Chandrayaan 3, soft landing on South Pole. Speciality of Chang'e 4, soft landing on the far side. Okay. Chang E5 is sample return mission like our Chandrayaan 4. Is it clear? Chang E5 is a sample return mission. Why to return the samples onto the earth? So that on earth we can study more in detail using better instruments, larger instruments, more sophisticated laboratories will be there on the earth. Is it clear? Then that is international moon missions. Artemis mission. Okay, in the international moon missions we have studied the moon missions by China. Then after that we have to study the moon missions by NASA. NASA's important moon mission is Artemis mission. In the Artemis we have 3 stages. Number 1, Artemis 1. Okay, in the year 2022. Okay, Artemis 1 2022. Okay, no human beings, only human models went in that. Only human models. Is that clear? Artemis 2 this month. Okay, crew astronauts went into the lunar orbit. They orbited around the moon for 10 days. After 10 days, they successfully returned. Not returning the sample. Astronauts went there, orbited around the moon and came back. It is the first crewed flight test of the SLS rocket and the Orion spacecraft. Okay, what is Orion? Orion is the spacecraft and SLS is the rocket. Is it clear? Like this. This is SLS. Inside that there is, okay, this is Orion. Okay, spacecraft inside. Rocket means what? I hope you remember rocket means vehicle. Vehicle is SLS. Spacecraft is Artemis. Spacecraft is Artemis. Artemis 2, did the astronauts land onto the moon surface? No landing, only orbited around the moon. Artemis 3 is future. The plan is landing the astronauts onto the moon after more than 5 decades. Okay, more than 5 decades ago, NASA in its Apollo missions landed the astronauts safely onto the moon. Neil Armstrong, you might have studied, right? Okay. After more than 5 decades, NASA is determined to once again send the astronauts onto the moon. Clear till now? That is about Artemis. With that we completed the moon missions. After completing moon missions, now let us see the interplanetary missions. That is missions to the other planets. Missions to the other planets. Okay? Right. First one, Mangalyaan mission. With Mangalyaan we have a world record. Okay? That is, India is the first country to successfully launch a Mars orbiter in its first attempt. Is it clear? In the year 2013. Cost is $75 million, 450 crores, which is less than several movie budgets these days, isn't it? Okay, in just PSLV. How? Using that transfer orbits method. Is it clear? Using the Newton's first law principle. Okay, PSLV XL. Just 450 crores. And it is a Mars orbiter mission. Only the orbiter. Okay, successful in the first attempt itself. Done. Okay. Then now Mars orbiter mission completed its lifespan. Is it clear? Lifespan over. Lifespan completed. Because Mars orbiter mission's lifespan is completed, we are sending Mars orbiter 2, Mangalyaan 2. But I should not call it as, I am so sorry, I should not call it as Mars orbiter 2. It's not orbiter. It is going to be a lander. Not only orbiter, it will land on to the Mars. Is that clear? It will land on to the Mars. Right? Then, so name, okay, name is lander. Okay, the name is lander. Mission type, it is an orbiter, lander, rover, helicopter. Not only lander, even a rover comes out of that. It will walk on the Mars surface. Not only that, a helicopter also. Okay, look at this. Imagine, okay, this is Mars. This is the orbit. And here you have the orbiter. Okay, orbiter goes like this. And helicopter is here. Is that clear? What is this? This is helicopter. Means it will fly in the Mars atmosphere. Okay, to check whether Mars atmosphere support the flight of a helicopter or not. To study whether, okay, can we fly the helicopter in the Mars atmosphere or not. Okay, so what all components will be there? You will have a, okay, you will have an orbiter, lander, rover, not only that, helicopter operated by ISRO. Proposed duration is 1 year. Manufactured at UR Rao Satellite Center. Okay, launch date is around 2030. Okay, rocket is going to be PSLV XL or LVM3. Okay, not yet decided. Either PSLV XL or LVM3. Is it clear? Launch site Satish Dhawan Space Center. Okay, clear for all of you? Then next one is, with that we completed the missions to the Mars. The next one is mission to the Venus. Mission to the Venus, that is called Shukrayaan. Just like Mars orbiter is called Mangalyaan, this is called Shukrayaan. ISRO is also planning an orbiter to the Venus. Okay, only orbiter to the Venus. Is that clear? Then after that we have Jupiter Icy Moons Explorer, JUICE mission. It is by European Space Agency. But it will not study the Jupiter. It will study Jupiter's moons. Is it clear? Called Ganymede, Callisto and Europa. Is it clear? Will the JUICE mission is by which space agency? European Space Agency. Like the Mars orbiter mission studied the Mars, like the Shukrayaan study the Venus, will the JUICE mission study the Jupiter? No, it will not study the Jupiter. It will study the Jupiter's satellites, that is Ganymede, Callisto and Europa. Is that clear? Okay. Then the mission is set to reach the Jupiter in the year 2031. If you see these dates, NGLV, okay, Chandrayaan 4, Chandrayaan 5, okay, and JUICE mission, all these are the future missions. It means this content will be valid even for the next decade also. After 10 years also, this particular class remains valid. Is that clear? Remains useful. Okay. And now this is JUICE mission. Okay. Are we only studying the Jupiter's moons, or there are any missions to study the Jupiter also? Yes. NASA's Galileo will study the Jupiter. Same way NASA's Juno. Okay. Galileo and Juno studies Jupiter. Whereas, okay, JUICE mission studies Jupiter's moons. Jupiter's moons means Jupiter's satellites. Is that clear? Then next, interplanetary missions by other countries. This is just a list that you have to by heart. Okay, nothing, no concept to explain. Mars missions by NASA, Perseverance rover, Ingenuity helicopter, Maven orbiter, InSight lander, Curiosity rover. Okay, these are all the interplanetary missions by the other countries. Just a factual content for your preparation, you can go through that. Can we proceed? Then next, with that interplanetary missions completed. Then the next concept is called Bharatiya Antariksha Station. What does it mean? It is space station. Okay, space station only for ISRO, not International Space Station. Exclusively the Indian Space Station. Why? Two reasons. One, the International Space Station is about to complete its lifespan. Second one, because of the issues between Russia and USA, the International Space Station is in vulnerable situations because of the political issues between Russia and USA. Is it clear? Third one, there is no guarantee that USA will cooperate whenever we need a space station. So it is always better to have our own space station, that is called Bharatiya Antariksha Station. Is it clear? Bharatiya Antariksha Station is going to be a hub for studying the microgravity effects. Okay, and what do you mean by the word microgravity? Microgravity means very less gravity, means negligible gravity. Okay, and we will do the life sciences experiments also. It means we will also study the impact of this microgravity on the human body. We will also study the impact of microgravity on the human body. Okay, and impact on the human health, etc. And phased development, it means can we send the Bharatiya Antariksha Station in a single launch? Not possible, it is going to be very large. We cannot send the Bharatiya Antariksha Station as a single piece. So we will send the Bharatiya Antariksha Station in different phases. Is it clear? First module will be launched in the year 2028. Total there will be 5 pieces. We are going to send the Bharatiya Antariksha Station in 5 pieces. These 5 pieces, 5 modules will go there, and then in the space they will dock into each other. They will fit into each other in the space. That is how, just like for example in some Amazon or IKEA, if you purchase any furniture, it will come in bits and pieces and you have to assemble it after you receive it. Same way, we will send this Bharatiya Antariksha Station in 5 modules. The 5 modules will go and in the space they will fit into each other. First module will be sent in 2028, okay, tentative date, and the last module will be sent in 2035. So this class is going to be relevant even for more than a decade. I hope it is clear. Okay, right. Then it orbits the Earth. Already I told you low Earth orbit is suitable for the space stations. So it will orbit in the low Earth orbit at an altitude of 400 to 450 kilometers. International collaboration. European astronauts will be working along with the Indian astronauts in the Bharatiya Antariksha Station. Once our space station is ready, in the space station, Indian astronauts will anyway work along with them European astronauts also will work there. So it is also an effort for the international collaboration. That's all this is about the Bharatiya Antariksha Station. Okay. Then next topic is rockets based on the nuclear technology. This is very interesting topic. Okay. And some of you are asking, this class may prolong till what time? It will prolong at least till 1 a.m. Minimum till 1 a.m. Okay. Later I don't know, it may go till 1:30 also, right? Then rockets based on the nuclear technology. Okay. First one, most important one is Voyager. Is it clear? Okay, Voyager, right? Like forget about my effort. Look at this. This Voyager was sent in the year 1977. Means about to complete 50 years. Next year it will complete 5 decades. And it is still orbiting. And it is still orbiting. Okay. Imagine their effort. Okay. Right. So, Voyager 1 was sent only to study the Jupiter and Saturn. That's all. Means this is like our Hanumanji. Okay. Means when you ask, when Rama just wanted Hanuman to visit Lanka, okay, he just lit fire to Lanka. Same way, here to the Voyager, the given task is only to study the Jupiter and Saturn. It studied the Jupiter and Saturn and then it crossed our solar system and went into the interstellar space. Okay. Same way, Voyager 2 was sent only to, the given task is only go study Uranus and Neptune. Okay, that's all. But what Voyager did? Studied the Uranus and Neptune, then crossed the solar system and entered into the interstellar space. Is it clear? So Voyager 1, Voyager 2 are the spacecrafts that travelled the farthest point in the space till date. Okay? The man-made objects that travelled the farthest point in the space are the Voyager 1, Voyager 2. And the spacecrafts that lived in the space for maximum duration 50 years are also Voyager 1, Voyager 2. Okay? Then you will get a doubt. Yes. Okay. The doubt is that our Sevarthi Hema got that doubt. What is that wonder fuel that maintained this particular spacecraft for 50 years? Did they really fill up gallons of kerosene in that? What is that wonder fuel so that, okay, it kept moving for more than like around 50 years? Simple. The fuel is a radioisotope. Is it clear? The fuel is a radioisotope. Is it clear? Plutonium 238, strontium 90. Okay. So here plutonium 238 will undergo decay. Okay. Decay is different, fission is different. I will show you the difference between the two. Okay. Nuclear fission means one nucleus splitting into two like this. Like cutting one apple into two pieces. Decay means like this, small pieces. Not cutting an apple with a knife into two pieces. Biting an apple piece by piece like that. That is called decay. I hope the difference between decay and the fission clear. The difference between decay and the fission is clear for all of you. Decay means one atom splitting into two pieces. Sorry. Fission is one atom splitting into two pieces, like cutting one apple into two pieces with a knife. Whereas decay is losing small particles, like biting into an apple piece by piece. Okay. Plutonium will undergo decay. Okay. The decay will release heat energy. This occurs in a component called as heater unit. Is that clear? Okay, what is happening in the heater unit? In the heater unit, the plutonium will undergo decay, producing the heat energy. There is another unit called as generator unit. Generator unit. Here that heat energy is converted into electrical energy. Is that clear? Now heater unit, generator unit together is called as RTG. RTG means radioisotope thermoelectric. Why this is called thermoelectric? Because heat energy is converted into electrical energy. Thermo means heat, electric means electrical energy. Okay. I repeat, RTG means radioisotope thermoelectric generator. RTG means radioisotope thermoelectric generator. It has two components, heater unit, generator unit. Heater unit, radioactive decay will undergo and it will release heat energy. In the generator unit, the heat energy is converted to electrical energy. Okay, and this occurs very slow. That is the reason why the Voyagers could survive for 50 years. In just one more year, it is going to complete. They are going to complete their 50th birthday. They are going to celebrate happy birthday to you. Right? Next. Now, unlike the solar powered, with the solar power, what is the problem? Our Chandrayaan 3's rover slept after 14 days. But with RTG, it could survive for 50 years. Okay. So, regardless of the spacecraft's distance from the sun, constant supply of the energy will be there with the RTG. Is that clear? Okay. The twin Voyagers likely to run out of the power in the near future, and NASA is targeting to celebrate its 50th birthday. Is it clear? So currently Voyagers are running in the energy saving mode. Okay, like sometimes when your mobile phone's battery is very less, you will keep it in the energy saving mode. So like that, Voyagers are working in the energy saving mode. Okay, then when I studied about Voyagers, the first doubt that I got is, what is that miracle fuel which could sustain it for 50 years? When I understood that it is radioactive decay, the second doubt that I got is, then why don't we use this in every spacecraft? Okay. Then obviously the answer is obvious, because radioactive leakages can be very harmful. Accidents are possible. You know how dangerous the radioactive material is. They cause cancers. They are very harmful to the humans and environment. So obviously that is the reason why we cannot use this in every spacecraft. Then I got another doubt. Okay, we cannot use it in every spacecraft. But are there any other spacecraft in which we used this? Yes. Okay, and BARC and ISRO, Baba Atomic Research Center and ISRO joined the hands. They both together are making a RTG based rocket. Is it in future? We are also going a rocket with the same. We are also going to make a rocket with the same principle. Is that clear? Baba Atomic Research Center and ISRO together are making a radioactive decay based rocket, just like that in the Voyagers. Done? Okay, then I told you that we have two types of thing, radioactive decay and nuclear fission. Fission means what? Cutting into two halves. Decay means what? Losing the pieces. Okay, now like these two, that is Voyagers and the ISRO bark joint venture, are based on decay. Then I got another doubt. Okay, decay fine. Are there any spacecrafts that are using the nuclear fission also for energy? Yes. You tell me, decay versus fission. Which gives more energy? Guess it. Nuclear decay versus nuclear fission. Which process gives more energy? Is that clear? Fission, no, fission gives more energy. Fission gives more energy. Okay, because it is literally splitting the nucleus into two. Okay, so fission gives more energy. Okay, so and fission is more dangerous also. Okay, fission is more dangerous also. This is the principle which is used in the atom bombs. It is a principle used in atom bombs. Is that clear? Okay. Then NASA collaborated with the, just like ISRO with BARC, NASA with their defense agency called the United States Defense Advanced Research Projects Agency called DARPA. Is it clear? Just like ISRO BARC, NASA and DARPA. Okay, their space agency, their defense agency. They both developed Draco. Okay, Draco. What is Draco? It is a nuclear fission based rocket. Is it clear? Okay, in the year 2026, it is scheduled in the year 2026. Is that clear? Okay, what is the significance to minimize exposure? Why minimize exposure? Because when we use the nuclear fission, it gives enormously high energy. That high energy will, okay, push the satellite into the space. So it means you can reach other planets. You can reach the other planets in a very short duration. So, if you want to send astronauts into the deep space, into the other planets and all, then it will take lesser time. Okay, instead of traveling years together, okay, the journey that takes 3 years with a normal rocket, this Draco will complete in 1 week. Super fast they can reach the deep space. Deep space means far away places in the space. Is it clear? Because it's like an atom bomb. Okay, Rebecca is asking why fission based reactors are dangerous. Because nuclear fission is a principle which is used in atom bomb. It releases enormously high energy. Okay, that blast releases enormously high energy, and also the radioactive waste which is cancerous. That is the reason why it is harmful, and that is the reason why we don't use it regularly. Rebecca, clear? Okay. Then concerns, safety concerns, accidents are possible, launch risk. During the launch, if it fails, it is like blasting an atom bomb on the earth. By chance, if the Draco fails during the launch, it is just like blasting an atom bomb on the earth. Is that clear? Okay. Then I got another doubt. So is it only Draco or there are any other missions that used the nuclear fission? Okay. Project Rover, Project Orion, Project Nerva also used nuclear fission, okay, to propel their spacecrafts. Is it clear? But Okay. Radiation will not push. Heat energy, enormous amount of heat energy will be released. That heat energy will push it. Radiation will not push. Okay, Saurabh? Heat energy will push the rockets. Okay. Project Nerva also just like Draco, but unlike Project Nerva, okay, which uses weapon grade uranium, Draco uses less enriched uranium. Is it clear? Nerva uses weapon grade uranium, whereas Draco uses low enriched uranium. So therefore it is less risky. Okay. And if you want to know what is low enriched uranium, what is high enriched uranium, high assay, low enriched uranium, weapon grade uranium, etc., watch my second one-shot marathon in which I discussed nuclear technology and information and communication technology. Okay. I am doing this complete science and technology in 3 sessions. First session I completed biotechnology. Second session I completed nuclear and ICT. This is the third and the last session. In this session I am discussing nanotechnology, space technology and some parts of defense technology. Is it clear? Right. Next. Next concept is solar storms and solar probes. These are the probes to study the sun directly. This time we are directly trying to study the sun. Okay. Let us first understand about the solar storms. Solar storms. Okay. Look at this. Imagine this is the sun. Okay. This is corona. Corona. What is corona? Corona is the outermost layer of sun's atmosphere. Is it clear? Outermost layer of the sun's atmosphere. Keep responding, just keep typing the letter Y if it is clear. Corona is the outermost layer of the sun's atmosphere. From the corona, okay, solar, okay, from the corona, solar wind, okay, what is that? Charged particles. Is it clear? Charged particles are coming. Okay, that is called solar winds. Solar wind. Charged particles means which particles? See, look at this. Solar wind, charged particles. Which particles? Okay, electrons, protons, etc. Is it clear? Electrons, protons, etc. Clear? Next. Same from the sun's corona. Okay. Radiations are also coming out. Radiations like X-rays, gamma rays, etc. Is that clear? X-rays, gamma rays, they are called as solar flares. Is that clear? Solar flares. Then, from the sun's corona, even some matter or mass is also coming. That is called coronal mass ejection. Coronal mass ejection. Okay. This mass is coming in form. The mass is coming in the plasma form. The mass is coming out in the plasma state. Plasma state. Okay. What is plasma? Plasma is, note, plasma is the fourth state of matter. Plasma is the fourth state of matter. Okay. Like solid, liquid, gas, then plasma. Okay. Much hotter than the gas. Okay. Solid. For example, you take ice. Solid form, ice, cool. Water, liquid form, little hotter. Water vapor, gas form, much hotter. Plasma, much more hotter. Okay. Matter or mass in the form of plasma is coming. That is called coronal mass ejection. All of you observe the arrow marks. Tell me, all these three are coming from where? Everybody pick up the speed. All of them are coming from where? They are coming from the sun's corona. Is it clear? From the sun's corona. Okay. And they are coming towards what? Okay, they are coming towards what? Okay, imagine this is the earth. Is it clear what is this? Earth. Okay. And now around the earth, what you have here? Imagine this is the magnetosphere of the earth. Magnetosphere of earth. Is that clear? This one. This is magnetosphere of the earth. Done? Now, what is happening? All of you quickly answer these questions. So, solar wind. What is solar wind? Charged particles. What is solar flares? Radiations like X-rays, gamma rays. What is coronal mass ejections? Mass or matter in the plasma state. Okay. All of them are coming from where? From the sun's corona. Towards where? Towards the earth. And what they will do? What they will do? Okay. Now check here. Solar wind, solar flares, coronal mass ejections, all the three will drag the sun's magnetic field. The sun's magnetic field. Okay. Towards the earth's magnetic field. Is that clear? Okay. This charged particles, that X-rays, gamma rays, that mass is dragging the sun's magnetic field towards the earth's magnetic field. I repeat, the solar winds, the solar flares, the coronal mass ejection, all of them are dragging the sun's magnetic field towards the earth's magnetic field. Is it clear? Okay. Then what happens? The sun's magnetic field will disturb the earth's magnetic field. Is that clear? The sun's magnetic field, okay, will disturb the earth's magnetic field. Clear for all of you? Okay. The solar wind, solar flares, coronal mass ejections will drag the sun's magnetic field towards the earth's magnetic field. So that dragged sun's magnetic field will disturb the earth's magnetic field. Okay. Now, such Such disturbance is called as, solar storm. Such disturbance is called as solar storm. Okay, if it is, see, coronal mass ejection, plasma. Okay, it is called solar storm if it is a minor disturbance, and it is called geomagnetic storm if it is a major disturbance. If the sun's magnetic field causes a minor, small disturbance in the earth's magnetic field, that is called solar storm. If the sun's magnetic field causes a major disturbance in the earth's magnetic field, then it is called geomagnetic storm. Is that clear? That's all. Okay. Then, now the geomagnetic storm is a major disturbance. Okay, solar storm can last for a few minutes, whereas geomagnetic storm can last for a few weeks. Solar storms are S1 to S5. It means small intensity solar storm is called S1. High intensity solar storm is called S5. Geomagnetic storms are G1 to G5. Small intensity geomagnetic storm is called G1. High intensity geomagnetic storm is called G5. Okay, is that clear? That's all. Now, what is the effect of the solar storms? What is the effect of the solar storms? Remember, simple. Okay, anything that uses okay, electricity or magnetism or electromagnetic fields, electromagnetic field, okay, gets influenced. Is it clear? It means, will the GPS get affected? Yes. Why GPS will get affected? Because electromagnetic radiation, sorry, not field, electromagnetic rays. GPS uses radio waves, so they will get affected. Okay. Do we get tsunamis? No. Okay, we don't get tsunamis because tsunami is water. How can the solar storm influence water? Okay, it will use only electricity, magnetism and electromagnetic radiations. It cannot cause tsunamis. Can it affect the power grids? Yes, because they use electricity. Power grids are using electricity. Okay, and do we get aurora? Yes. Okay, that is northern lights and southern lights. Is it clear? Okay, what is that? These charged particles, when they interact with the Earth's atmosphere, we can get beautiful lights. These charged particles, the coronal mass ejections, when we see all this material which is coming, okay, see, look at this. These charged particles, radiations are coming towards the Earth. When they come towards the Earth and when they interact with the Earth's atmosphere, with the dust and all, you can see beautiful colors. They are called aurora, or the northern lights, southern lights. Is that clear? Yes, we get aurora, correct. Forest fires? No, okay, because solar storm is not like, don't imagine that sun is throwing some fire towards the Earth. No, sun is not putting any fire towards the Earth. Okay, it is just magnetic field. Okay, it means sun's magnetic field said, I love you to the Earth's magnetic field. That's all. Nothing more than that. It's not a fireball coming from the sun. Okay, then, so orbits of the satellites will get disturbed? Yes, because these orbits are controlled by the radio waves. All our satellites are maintained with the radio waves. Radio communication will get affected? Yes, because radio waves are electromagnetic waves. But not only this, even the birds' migration also gets affected. Okay, because birds have a natural compass. Okay, they can sense the magnetic field. I mean, with the help of this natural compass, they know whether they are moving towards the north or towards the south, like that. So that natural compass will get disturbed because it is using magnetism. It is based on the simple electricity, magnetism, electromagnetic waves, aurora, that's all. These are the effects of the solar storms. Clear? Then, next. Aditya L1. Aditya L1. What is Aditya L1? Aditya L1 is used to study the solar storms. Is it clear? Aditya L1 is used to study the solar storms. Okay. Why this is called Aditya? Look at here. This is our Aditya. The name Aditya because it is observing the sun, because it is a solar probe. Okay, and it is called L1 because it is located at Lagrange point 1, Is it clear? It is located at Lagrange point 1. Is it clear? No, Ganesh, they are not visible to the birds, but they can sense it. They can feel it. Okay? Clear? So tell me why this is called, in the name Aditya L1, Aditya word justifies what? It is a solar probe. L1 word justifies what? It is in the Lagrange point number 1. It is in the Lagrange point number 1. Okay, what is Lagrange point? What is Lagrange point? Let me explain that. I hope you remember, like in an orbit, okay, I said that this is momentum and gravitational force, isn't it? Two forces in a regular orbit. Two forces, that is gravitational force and momentum of the satellite, okay, balance each other, isn't it? Okay, but Lagrange point, okay, Lagrange point is a special orbit. Lagrange point is a special orbit. Here, three forces balance each other. Here, three forces balance each other. What are the three forces? Okay, the gravitational force of the sun, the gravitational force of the earth, and the momentum of the satellite. Is that clear? Okay, look at here. Gravitational force of the sun, gravitational force of the sun. Look at here. Gravitational force of the earth, gravitational force of the earth. Okay, then look at here. The momentum of the satellite, okay, or the spacecraft. Momentum of the spacecraft. So three forces balance each other. Is that clear? That kind of a special orbit is called as Lagrange point. Okay. Then in a Lagrange point, is the Aditya L1 static? No. Aditya L1 is not static. Aditya L1 is moving. Okay, like this. Aditya L1 moves around the sun. Did you understand? Yes, around the sun, like Earth. Okay. Aditya L1 orbits around the sun like Earth. Is it clear? Yes, orbiting around the sun. Done? Okay. Then what is fixed? Distance is fixed. It means, will it move like this? No. Will it move like this? No. Okay. I hope you understood what is fixed, not what is not fixed. Aditya L1's, okay, keep answering. Aditya L1's distance from the earth, fixed or not? Will it keep coming close to the earth, coming close to the sun like that? Yes? Fixed. Very good. Fixed. Right. Is Aditya L1's distance from the sun fixed? Aditya L1's distance from the sun is fixed? Yes. But is Aditya L1 static or is it orbiting around the sun? It is orbiting around the sun. Clear? Why it is orbiting the sun? To keep watching the sun. To keep watching the sun. Is it clear? To keep constantly monitoring the sun. Why to constantly keep monitoring the sun? Why to constantly keep monitoring the sun? To check if any solar storms are about to come. To check if any solar storms are about to come. Okay. If any solar storms are about to come. Is that clear? Just 1 second, please. Right? So constantly it keeps observing the sun to check if any solar storms are about to come. Okay, you're able to hear me? Oh. Okay, is my audio video clear? Right, thank you. So that is Aditya L1. Done? Then if you observe, look at this image once. Look at this image. This is Aditya L1, right? And this is moon. Now tell me, is moon closer to the earth or Aditya L1 is closer to the earth? Is moon closer to the earth or Aditya L1 is closer to the earth? Moon is closer to the earth. It means moon will not come. Okay, in between sun and Aditya L1. Is that clear? Moon will not disturb Aditya L1 watching the sun. Means imagine our Aditya L1 like a boyfriend stalking the girlfriend's sun. Okay, and moon is the other third person, should not come in between when he is staring at the sun. Okay, so the moon should not disturb Aditya L1's sight on the sun. Is it clear? Okay, that is the story of Aditya L1. And Parker probe. Parker probe is a similar solar mission by NASA. Okay. And it is launched using the Delta IV heavy rocket. Okay. And it was launched in the year 2018 with a cost of 1.5 billion US dollars. Is it clear? The cost was 1.5 billion US dollars. Okay. And it is just 6 million kilometers away from the sun. See, sun, earth. Total distance is, okay, 150 million kilometers. Then, okay, the Parker probe traveled, okay, 144 million kilometers. Did you understand? Parker probe traveled 144 million kilometers. Just 6 million kilometers away from the sun. Means, okay, the Parker probe literally flies in the sun's corona. It will literally fly in the sun's corona. And it will collect the sample from the sun's corona. Is it clear? It will collect the sample from the sun's corona. Clear till now? 24 loops means 24 times it will orbit around the sun. 24 loops means 24 times orbits the sun. And NASA said it is like touching the sun. It almost touched the sun. It might not have touched the sun, but it literally touched the sun's atmosphere. Okay? It is almost like touching the sun. It is the first ever mission in the world to touch the sun. Is the Parker probe clear? Then, European Space Agency's Vigil mission. Vigil mission is having, okay, two things. Okay, at L1 you have Aditya, and also Vigil mission. Is that clear? No, it won't get burnt. It is having heat protection systems. That is the greatness. Okay. Now look at here. What are the two solar probes located in the L1 Lagrange point number 1? One is Aditya L1, ISRO's. Second one, European Space Agency's Vigil mission. Okay. Whereas Aditya L1 we have only one, and Vigil mission is also located here. It means Vigil mission, European Space Agency's Vigil mission is having two probes. One is at the L1, the other one is at the L5. L1 will keep observing the sun in one angle, L5 will keep observing the sun in the other angle. So that if the solar storms are coming from any angle, we can predict that. Is it clear? Fixed means what? Distance fixed. But it is not static, it is orbiting around the sun. It is orbiting around the sun. Okay? Then you may ask me, okay ma'am, Aditya L1 is at the L1, Vigil mission is at L1 and L5. Then Parker probe is located in which Lagrange point? No, Parker probe is not located in the Lagrange point. Okay, Parker probe is somewhere here. Is that clear? Parker probe is much closer to the sun. Done? Understood? Then moving ahead. Okay, NISAR mission is the next one that we have already completed. I hope you remember NISAR mission. NASA ISRO synthetic aperture radar. Okay, L-band radar is provided by NASA, S-band radar is provided by ISRO. Together it is NISAR mission. 12 days it will complete one complete mapping. In every 12 days it can do one mapping. Like that in 3 years, multiple times it will completely map the earth. Okay. Next one is called, next topic is James Webb Space Telescope. James Webb Space Telescope. What is this? Simple. Our older Hubble Space Telescope completed the lifespan. Hubble Space Telescope's lifespan is completed. So we made a new telescope that is called James Webb Space Telescope. It is by Canadian Space Agency and European Space Agency. $9.7 billion, imagine the cost. Okay. It is the largest and most powerful space telescope till date. Much powerful than the Hubble Space Telescope. It was launched 25th December 2021 in the vehicle called Ariane 5 rocket. Okay, and the launch site European Space Agency's spaceport in French Guiana. From there it is launched. Okay, where is it located? It is located at Lagrange point number 2. See, this is James Webb Space Telescope. Here you have Aditya and Vigil. Here you have another Vigil. Here you have the Parker. Okay, and L2, here you have the James Webb Space Telescope. It is the largest and most powerful space telescope till date. Is that clear? Is it static? No. Fixed position, fixed distance from the sun. But it will also keep orbiting around the sun like this. Is it clear? Okay. This is James Webb Space Telescope. This is Earth. Okay. This is sun. Just like Earth is orbiting around, look at here, just like Earth is orbiting around the sun, okay, the James Webb Space Telescope is also orbiting. Same way, our Aditya L1 is also orbiting. They are orbiting, but fixed distance from the sun and moon. Clear? That is the story of the James Webb Space Telescope. Okay. After James Webb Space Telescope, next topic is NASA's DART mission. What is DART mission? Simple. It is double asteroid redirection test. See, let us suppose if an asteroid is coming towards the Earth, what should we do? Wait and watch? No. So what should we do? Okay, kick it so that you can just push it away from the earth. Kick it and push it away from the earth. That is what the DART mission will do. Okay, look at here, I will show you the DART mission. Okay, complete focus here please. What is this? This is Didymos. Can you see that? What is this? Didymos. What is this? Dimorphos. Clear? Don't look at the image overall. You will not understand. Check here. What is this object? Didymos. What is this object? Dimorphos. It is a double asteroid. Therefore, it is called as double asteroid redirection test. What are the two asteroids? Didymos and Dimorphos. Didymos and Dimorphos. Is it clear? Then, okay. Now, check here. Complete focus, please. This dimorphos is close to Earth. Is that clear? So, what the DART mission is doing? Check this. What is this? This is DART mission. DART. It will come and tangentially hit the dimorphos. Okay? Means if the dimorphos here, DART will come like this. When it comes like this, what happens? The dimorphos will be, see, when the DART mission is hitting it here, then the dimorphos will be moved this side. Is it the other side? Are you getting this point? So, if you observe, this is the original orbit of the dimorphos. Original orbit of the dimorphos, which is close to Earth. Is it clear? Original orbit is close to Earth. But now what you have done with this? Okay, check this. This is the new orbit of the dimorphos. New orbit. It is away from the Earth. It is away from the Earth. Is that clear? Yes, clear for all of you? Right. So, DART mission will hit the dimorphos and move it away from the Earth. But when you are doing this much, एक selfie तो बनता है. So, NASA also sent Licia Cube. This is a camera. This camera will take the pictures before and after pictures. Is it clear? Licia Cube is a camera. It will take the photograph of dimorphos before being hit by the DART, and the photos of dimorphos after being hit by the DART. Old original orbit, new orbit. Okay, that is DART mission and the Licia Cube. This is by NASA. Is it clear? NASA sent DART mission to kick the dimorphos and push it towards the Didymos, means push it away from the Earth. Licia Cube will take the photograph before pushing and after pushing. That's all. This is double asteroid redirection test, that is DART mission. Okay, done. Next one, crops. What is this crops? You might have heard about the SpaceX mission. In the SpaceX mission, there is one payload called crops. Okay, it is developed by Vikram Sarabhai Space Center to demonstrate germination of a plant called cowpea. Okay, a pulse, a legume. Okay, so what they have done? In the SpaceX mission, there is one payload. In that payload, okay, what they have done is there is one payload called crops. I repeat, SpaceX mission. In that there is one payload called crops. In that payload, okay, what they have done is germinated a plant. So can we germinate a plant in the space? After this we should say yes. Yes, we can germinate a plant in the space. Okay, done. Next one. ISRO's Himalayan outpost for the planetary exploration. Okay, Himalayan outpost for planetary exploration called HOPE. Okay, it is a 10-day space analog. It is a 10-day space analog. Means what? We are not going into the space, it is on the earth. In the country India, in the state Himachal Pradesh, is it clear? Or not Himachal Pradesh, okay, Himalayans, where it is in Ladakh. Is it clear? But this place will simulate means imitate. That place in Ladakh is very similar to Mars or moon-like conditions. Okay, so here if you keep an outpost, the astronauts can practice staying in the moon and Mars by simply going to Ladakh. Is it clear? That is Himalayan outpost for planetary exploration called HOPE. Clear till now? Then Proba 3. What is this Proba 3? It is European Space Agency's Proba 3 mission. Okay, it is very interesting. Okay, let us check this once properly. In this Proba 3, there are 2 satellites. Tell me how many satellites are there in Proba 3? Keep answering. How many satellites are there in the Proba 3? 2 satellites. One is called occulter. The other is called coronagraph. Is it clear? So, now look at this. Imagine this is the earth. This is the sun. Okay. And this is the occulter. It is the occulter. Occulter will create an artificial eclipse. Did you understand? Okay. Occulter will create an artificial eclipse. Right? Means it will come in between the earth and the sun. You can't see the sun, isn't it? Okay. From the earth can't see the sun. Done? Understood? Clear till now? Once the occulter blocks the sun, coronagraph will take the photograph. Will take the photograph of the sun's corona. Is that clear? Proba 3 will have 2 satellites. One is occulter and the other is coronagraph. They both are 150 meters apart. Okay? And it will create an artificial solar eclipse. Okay? Occulter will create an artificial solar eclipse. And once the occulter blocks the sun, then the coronagraph will take that is the reason why it is called coronagraph. It will take a photograph of corona. That's all. Launch date December 5, 2024. ISRO is using PSLV XL rocket. Okay. Then you may ask me, ma'am, it is by European Space Agency. Correct. But launch is by PSLV XL. Okay. We launched it. European Space Agency's rocket, we launched it. Methodology: occulter spacecraft blocks the sun's direct light, allowing the coronagraph to take the image of the corona. Status: okay, it is following successful demonstration. ESA reported a loss of contact with the coronagraph in March 2026. Okay, it took the photograph and then we also lost contact with the coronagraph. Means lifespan completed. That is Proba 3. Okay, then last topic, but don't get super excited. This is not the last topic in this session. It is just the last topic in space technology. After that, we also have defense technology. Okay, the class will extend minimum till 1:30. Okay, may go till 2 o'clock also. Okay, right. Space debris. What is space debris? Space debris means what? Do you remember PSLV is having 4 stages, and I said first 2 stages will fall back onto the earth and the second 2 stages will form the space debris? Used up stages. Okay. Old satellites. Old satellites or failed satellites. Failed satellites. Okay, all these things will form the space junk or the space debris. Is it clear? So they keep orbiting the earth, at high speed. Means they are just like bullets. Though they are small pieces, because of their high speed, they are almost like bullets. Okay, and they can harm the satellites and astronauts. Is the problem clear? That is the problem. Such things will become the space debris. Done? Used up stages of the rockets, old satellites whose lifespan is completed, failed satellites, they all will become the space debris or the space junk. Okay, they are small pieces, but they are orbiting around the earth at a very high speed. So they behave like bullets. If they hit any satellite or any astronauts, they will get injured or damaged. That is the problem with space debris. And what is Kessler effect? A NASA scientist called Donald J. Kessler, in the year 1978 proposed that it will cause a chain reaction. It means, imagine, if one space debris hits one satellite, then that satellite is broken into 100 pieces. Now the 100 pieces will hit 100 satellites. Then the 100 satellites will be broken into 10,000 pieces. Then the 10,000 pieces will hit 10,000 satellites. Then the 10,000 satellites will be broken into 1 lakh pieces. This is how the space debris will form more space debris. So the amount of the space debris just goes on increasing. This chain reaction is called Kessler effect or the Kessler syndrome. Clear till now? Then, it means because of this space debris, in future the space activities can also become impossible. Is it clear? I mean, our younger generation cannot get the benefits of the space technology like we are getting. Is it clear? So, we need to take some steps to clear the space. Space mein, jadu marna. I mean, clear the space like a vacuum cleaner. Clear the space. That is steps taken for the space debris. Now let us see what are the steps taken by ISRO and what are the steps taken internationally. ISRO is a member of Interagency Space Debris Coordination Committee. Means what? What is Interagency Space Debris Coordination Committee? Multiple countries, multiple space agencies will keep a coordinated effort of warning each other. For example, if we observe a space debris approaching the NASA's satellites, we will warn NASA. If NASA observes that a space debris is coming close to our satellites, then the NASA should warn us. Same way we warn European Agency, like that. Interagency Space Debris Coordination Committee. This committee will keep a coordinated effort of different space agencies to warn each other about the space debris. Is that clear? Then, ISRO is also using multi-object tracking radar. Means, a radar that tracks multiple pieces of space debris. Why it is tracking the space debris? To protect. Why this radar is tracking the space debris? To protect our satellites from the space debris. Is it clear? Then ISRO is also doing Project Netra. It is a network of space object tracking and analysis. Okay, Project Netra will be tracking and analyzing the space debris. Okay, it will keep monitoring whether any pieces of space debris are coming close to our satellites. Okay. Then now international efforts, simple. One is remove debris. Remove debris. It is coming from the International Space Station, means by NASA. What it will do? It will capture the space debris. Okay, see, imagine this is the Earth. This is the orbit around the Earth. Here you have space debris. Then the remove debris will push them towards the Earth. Then it might be surprising for you, ma'am, if this removed debris is pushing the debris towards the Earth, won't these pieces of debris fall on our heads? Won't they harm us? No, they will be burnt as they enter into the Earth's atmosphere. When they enter into the Earth's atmosphere, they face enormous amount of the friction. That friction will literally burn them. Okay, so that is what remove debris is doing. Is it clear? Clear for all of you? Abhitesh, I'm sorry, we are following a uniform pattern. The entire team is following a uniform pattern and I'm using the same color code that the team suggested. Is it clear? So here my contribution is only, okay, click on the stream button, shout, 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 and then go away. Remaining everything you should talk only to the administrative team. Is it clear? I know, but okay, like I am not the one who is deciding all those things. Done. Coming back to this. Okay. In my class, please focus only on the subject. In my class, please focus only on the subject. Right? Now, so tell me what remove debris is doing. It is holding the this one pieces of the debris and pushing them towards the Earth. Clear? Done? Then European Space Agency with startup company Clear Space. It is also doing the same. It is having 4 robotic arms. Okay, with robotic arms it will hold the debris and throw it towards the Earth, so that they will fall into the Earth's atmosphere and they will be burnt. They will fall into the Earth's atmosphere and get burnt. Clear till now? Right. NASA's space debris sensor orbit the Earth from the on the International Space Station. Same way, United Nations has established a committee on the peaceful usage of the outer space. It means preventing the space weaponization. Space weaponization means if you use any weapons in the space and you destroy the satellites, then what happens? The satellites will be broken into multiple pieces and then create more debris. Okay, so COPUS will see to it that okay, the space will be used for peaceful purposes only. Okay, then now look at here. We completed space technology, but not all. SpaceX, POEM 1, 2, 3, 4, Gaganyaan mission, and the Gaganyaan mission tests, ISRO's Vyomamitra, all these are already discussed in the Conquer Prelims phase 1 and phase 2. In the phase 1 part 2. What is this? 2025 current affairs. Is it clear? The phase 1 of Conquer Prelims is 2025, entire complete 2025 year current affairs. So in that phase 1 part 2, I discussed these topics related to space. And I am giving you the link of that class here. By chance, if you missed that class, you can watch using this link. Is it clear? Then next, same way, gravitational waves, LIGO, LISA, neutrino observatory and other universe related topics I discussed in the mysteries of universe. I discussed in the mysteries of universe. Okay, this is Conquer Prelims phase 4, which I have taken as 3 sessions, 26th, 27th, 31st of March, and these are the links of those 3 classes. Okay, in that I discuss special classes, free sessions on Unacademy platform. Anybody can watch them, not only the plus users. Is it clear? Okay, then with that we completed the space technology. Okay, now moving on to the defense technology. Okay, can I just continue like this, or you need a small break here? Yes, please. We are going to start the last topic, that is defense technology. Five minutes break. Okay, let us take a small 5 minutes break. Let us assemble by sharp 12:46. Okay, 12:46 sharp I will be back. Welcome back after the break. Hope I am audible, visible. Please let me know in the comments, am I audible, visible? Okay, thank you. So let us now continue with the defense technology. In the defense technology, first type is ballistic missiles. Ballistic missiles. See, defense technology is one topic which is completely factual, and also you have enormous amount of information. Okay, it is like digging a mountain to catch a rat. Means hardly you will get one question from this, but you have to read huge chunk of information. To be frank, the defense technology is like that. There is nothing much we can do about it. Okay. So now with that disclaimer, let us continue with defense technology. Let us try to cover a few important topics from this. First, we are discussing the types of missiles. In the types of missiles, the first type are called ballistic missiles. In India, okay, the ballistic missiles are made under the Integrated Guided Missile Development Program called as IGMDP. Integrated Guided Missile Development Program. Under that program, we made the ballistic missiles. Now let us see what is ballistic missiles. Okay, ballistic missiles, say for example, you are launching from here. They will jump like this and hit the target. And this is the launch site. Okay, and they follow the trajectory. Trajectory means what? The route of a trajectory of a projectile. What is the trajectory of a projectile? Okay, actually from my 11th class when I studied, this is the only one sentence I remember from my 11th class. The trajectory of a projectile is parabola. I don't remember anything other than this point from 10th class, 11th class, sorry. The trajectory of a projectile is nothing but parabola. That is the reason why you can see some emotion in my face when I say this sentence. The trajectory of a projectile is parabola. It will follow the parabolic pathway. It will jump from the launch site and reach the target. And these ballistic, kya bola? Okay, so right. So it will go from the launch site and reach the target, and it will jump like this. These ballistic missiles are called as the strategic missiles. These ballistic missiles are strategic missiles. Strategic missiles means what? They are large scale. They can cause mass destruction. They can cause mass destruction. Therefore, army cannot decide to use them in the battlefield. In the battlefield, army cannot decide to use them. Civilian political leader, that is, the government should approve the usage of the ballistic missiles. Is that clear? And they attack the bigger targets like a city. An entire city can be destroyed. Okay, then now in the ballistic missiles we have short range ballistic missiles. Again, as I told you, this is fully factual. Prithvi 1, Prithvi 2, Prithvi 3, Dhanush, Prahar, Pralay, Agni 1 and Shaurya. These are all short range ballistic missiles. It means from the launch site, okay, the launch site and the target. Okay, short distance between the two. Short distance between the two. Is that clear? Thank you so much for observing that, Lalita. Thank you. Thanks for the concern. So from the launch site to the target, the distance is less. That is called short range ballistic missiles, SRBMs. Example, Prithvi 1, Prithvi 2, Prithvi 3, Dhanush, Prahar, Pralay, Agni 1, Shaurya are the examples for that. Clear till now? Second type are called IRBMs. IRBM means intermediate range ballistic missiles. Intermediate range ballistic missiles. Okay. Examples, Agni 2, Agni 3, Agni 4. Range of 2000 to 3500 kilometers, 3000 to 5000 kilometers, 3500 to 4000 kilometers, like that. And payload, it means how much weight of the explosive it can carry. Is it clear? Agni 2 can carry 1000 kg explosive. Agni 3 can carry 2500 kg explosives. Agni 4 can carry 1000 kg explosives. Is it clear? And it is, you can also see two-stage solid fuel. This we have seen in the space technology. Two stages means what? Like this. Okay. Two stages means like this. During the launch we ignite the stage 1. When the stage 1 is completely burnt, then it will ignite the stage 2. Is it clear? Both use solid fuels. It is also like Agni 4 also two-stage solid propulsion. And it will use conventional and nuclear warhead. Then what do you mean by the word warhead? Warhead or payload. Warhead or payload is nothing but the explosive here. This explosive can be, now look at this. Okay, they can carry conventional explosives and also nuclear bombs, atom bombs. Conventional explosives, nuclear bombs. Both can be carried by this IRBMs. Is it clear? What is this? This is range. Range means what? This distance. Okay. Launch, target. The distance between these two is called as range. Okay. Payload. Payload warhead means what? Explosive. Okay. And all of them are two-stage and carry both conventional means normal bombs and also nuclear bombs. Done? IRBMs over, intermediate range ballistic missiles over. Now ICBMs. ICBM means what? ICBM means intercontinental ballistic missile. Okay, means they are long range ballistic missile. The range is so long that you can even attack on a target which is located in the other continent. You can also hit a target which is located in the other continent. Is it clear? Okay. Example, Agni 5. Okay. Agni 5 is an ICBM. Okay. Agni 1 is SRBM, short range ballistic missile. Agni 2, 3, 4 are IRBMs, intermediate range ballistic missiles. Agni 5 is ICBM, intercontinental ballistic missile. Okay. Agni 2, 3, 4 are two-stage rockets. Whereas Agni 5 is three-stage rocket. All three use solid fuel. All the three use solid fuel. Is that clear? And okay. Thank you so much. Okay. Current affairs we have already done in the earlier marathon, Abhitesh. Okay, we'll give you those details at the end of this class. Okay, end of this class I will talk to you. Right, speed 24 Mach. 24 Mach means 24 times 24 times the speed of the sound. Is that clear? Okay, it will travel at 24 times the speed of the sound, and it can carry nuclear warhead also. Here, I'm sorry, all the electronics are running out of charge. So you have a brief interruption. I hope everything is fine. Okay, and it can carry nuclear warhead, range 5,500 kilometers. Therefore, it can go to other continent also. It can even go to the other continent as well. Payload capacity 1500 kgs of the payload it can carry. Okay, and another interesting point, this is going to be very interesting, complete focus please. It is having MIRV technology. MIRV means multiple independent targetable re-entry vehicle. Multiple independently targetable re-entry vehicle. Okay, means what? I will show you that using this image. This is such a beautiful image. Let us try to understand this. Okay, see, Agni 5, the trajectory of a projectile, the Agni 5 goes like this. Then if you observe 1, 2, 3, multiple explosives are coming out. Multiple explosives are coming out. Then look at here. Imagine here it crosses the Earth's atmosphere. Imagine this is the Earth's atmosphere. Okay. Okay. Now Agni 5 crossed the Earth's atmosphere, right? Is the step 1 clear? Agni 5 crossed the Earth's atmosphere. From that 1, 2, 3 multiple warheads. See, look at here, 1, 2, 3, 4, 5. Multiple warheads separate. Then each one will re-enter the atmosphere. Is it clear? Okay. Each warhead independently re-enter the Earth's atmosphere. Is that clear? And hit multiple targets. Means one missile but multiple targets. One Agni 5 can hit multiple targets. Each warhead independently re-entering into the atmosphere. Okay. Don't think that it will come back. Okay, I mean we have launched it's not like, see, launch site, target, it will hit the target and then it will come back. No, wrong. It will not hit the target and come back. In this context, re-entry does not mean that. In this context, re-entry means, okay, look at here. It crossed the Earth's atmosphere. This is the Earth's atmosphere. Imagine this line. It crossed the Earth's atmosphere. Then each okay, warhead is independently re-entering the Earth's atmosphere. Therefore, it is called, okay, therefore it is called multiple. That is the reason why Prerak, for you only I brought this image. Okay, so each warhead is independently re-entering, multiple independently targetable re-entry vehicle. Is that clear? Then it has, and you know something, it can hit 12 different targets. Okay, one Agni 5, 12 targets. Is it clear? 12 times it will go and it will come back 12 times. 1, 2, 3, 4, 5, 6. Like that 12 times it will re-enter into the Earth's atmosphere. Clear? Then this Agni 5 was flight tested in the mission Divyastra. Okay, mission Divyastra is the name of the flight test of this Agni 5. Okay, and only USA, Russia, China, France, United Kingdom have this MIRV technology. In India, we have MIRV technology with Agni 5. What other countries have MIRV technology? Okay, USA, Russia, China, France, UK also have this MIRV technology. Clear till now? Is Agni 5 clear? Then, now Agni Prime. Agni Prime, don't think that Agni Prime came after Agni P, Agni 5. So, Agni 5 is long range when compared to Agni 4. Agni 4 is 4,000 kilometers. Agni 5 is 5,000 kilometers, isn't it? Agni 5 is 5,000 kilometers. Then don't think that Agni Prime is 6,000 kilometers, not like that. Agni Prime range is only 1,000 to 2,000. It means it is a like a SRBM, short range ballistic missile. Is it clear? It is like an SRBM or it is like the IRBM. Okay, it's like SLBM, SRBM or IRBM. Okay, but not ICBM. And it is a two-stage, nuclear powered but canisterized ballistic missile. What do you mean by canisterization? Canisterization means keeping the missile in a can-like casing box. Is it clear? Keep the missile in a box. Like, for example, this is the canister. And you have the missile inside this. Missile. What is the usage of the canisterization? With canisterization, the advantage is it is safe. Okay, it means we can avoid the accidental launch. Is it clear? Sometimes what happens? By mistake, the missile can be launched. Such things can be prevented. We can avoid the accidental launch. Okay, that is Agni Prime. Okay. Then, now Agni Prime, yes, test completed in the year 2024. Agni 6 is future. Agni 6 is future. It is going to be 9,000 to 12,000 kilometers range and payload up to 3,000 kilometers. Speed 24 times the speed of the sound. Is that clear? So what is the longest range ballistic missile? Agni 6. Do we already have it? No. It is a future project. Okay. Is Agni Prime longer range than Agni 5? No. Agni Prime is not Okay, longer range. It is like an SRBM or IRBM. Okay, then that is about the ICBMs. Okay, next one, submarine launched ballistic missile. Submarine launched ballistic missile. It means, okay, like they will be kind of yeah. Imagine this is the ocean, okay, and you have the submarine here. Submarine, and the ballistic missile will go like this, will hit a target. Okay, the target need not, the target can be here also. It can hit the target like this, or it can hit the target like this also. Okay, the target can be another submarine, or the target can be a surface ship, but it is coming from the submarine. That is called submarine launchable ballistic missiles. Okay, SLBM. Is that clear? Example for the submarine launchable ballistic missiles are factual content. K-15 Sagarika, K-4, K-5, K-6. These are submarine launchable ballistic missiles. Range is given, payload capacity is given here. Okay, some details are also mentioned here. After we completed the ballistic missiles, the second topic is air-to-air missiles. Is it clear? Right. We'll see air-to-air, but ballistic missiles are surface to surface. Isn't it? They are launched from one surface and hit the target on the other surface, not the air. Surface to surface. Whereas these are, the second category are air to air. Example, Astra Mark 1, Astra Mark 2. It means, for example, one country in a fighter jet, the other country's fighter jet. They both will launch the missiles on each other. These are called air-to-air missiles. Astra Mark 1, Astra Mark 2. Okay, 110 kilometers, 160 kilometers. Same way, these are Astra Mark 1, Astra Mark 2, they both are indigenous ones. Whereas India is also having Israel's air-to-air missiles called Python 4, Python 5. 15 kilometers, 20 kilometers range. Mach 3.5 means what? 3.5 times the speed of the sound. Mach 4, 4 times the speed of the sound. They are air-to-air missiles. Two countries' fighter jets launching missiles on each other. Clear till now? Then, now surface to air missiles. Okay, means like this. Surface to air. When I hear this word surface to air, I will remember Ramayana and Mahabharata. Okay, in Mahabharata you can see two groups of soldiers standing on each side, and they will put the arrows. Okay, one arrow in this direction, the other arrow coming in this direction. Now these two arrows will do this kind of dance there in the sky. Is it clear? And one of them will fall down. Do you remember this particular scene in old movies or Mahabharata serial? Is it clear? Right. So this is like that. It means, for example, okay, say here India, and this is some enemy country, and the enemy country launched a missile. What kind of a missile? It can be ballistic missile or some missile. Okay. Now from India we have to launch another missile, surface to air missile, and this will intercept. Intercept means stop it. Okay, in the air itself. Intercept in the air itself. That is called as surface to air missile. Examples for the surface to air missile: Trishul, Akash, Maitri, Barak 8. Okay. Range is given here, payload capacity. Payload capacity means how much explosive they can carry. Okay. Then Akash is a surface to air missile. We have Akash new generation. Akash new generation, it is tested in 2021. It is extended range. It means Akash is 30 kilometers, but Akash new generation is 70 kilometers. Okay, and also it travels with a speed of 2.5 Mach. It means faster than the original Akash. It is developed by DRDL in Hyderabad. Okay, clear? Surface to surface, no prereq, not like that. Surface to air missiles we use for that purpose. Okay. Then, now anti-ballistic missiles. Anti-ballistic missiles are also surface to air. Okay. Then, all anti-ballistic missiles are surface to air, but all surface to air are not anti-ballistic. So anti-ballistic ones are larger surface to air missiles. Is that clear? Because I told you ballistic missiles are strategic weapons. Okay, and they are large scale, they cause large scale destruction. So to stop them, your surface to air missile also should be very strong, isn't it? Like if the other team soldiers, if they launch Brahmastra, then we also have to put a Brahmastra from this side. Okay, it means an equivalent missile should be launched. So therefore, every surface to air missile is not anti-ballistic. I mean, every surface to air missile cannot stop the ballistic missiles. Every surface to air missile cannot intercept the ballistic missiles. Is that clear? Right. Still you are thinking that I am from South India after listening to my Telugu slang English for 10 hours. You are still thinking that I am from South India. That's great. That's great, Bihar. Right. Okay. Then, so I feel my English absolutely sounds like Telugu. Right. Then coming back to this. So, are all the surface to air missiles anti-ballistic missiles? No. But are the anti-ballistic missiles surface to air? Yes. Then, okay. Now, in the anti-ballistic we have Prithvi air defense missile, advanced air defense missile. Okay. Check this. Prithvi air defense missile, advanced air defense missile, Prithvi air defense vehicle. Okay. Here, if you observe 3000 kilometer range, 80 kilometer, then you may ask me one doubt. That is, ma'am, what is this 3000 kilometer and what is this 80 kilometer? 3000 kilometer is the distance, whereas 80 kilometer is the altitude, that is height. Okay. It means like this. This distance is 3000 kilometers, whereas this height is 80 kilometers. Is that clear? Same way, this is okay, 150 to 200 kilometers distance, 30 kilometers altitude. 3000 kilometers distance, 120 kilometers altitude. So now tell me, can you guess and tell me which one is more efficient? Prithvi Air Defense Missile, Advanced Air Defense Missile, or Prithvi Air Defense Vehicle? Everybody? This one. No, not like that. All are important. Again, when I say this, I will remember one movie scene. Okay, it's a Telugu movie. So in that, the villain wants to kill the hero. But he is hero, right? Killing the hero is very difficult. So the villain wants to be extra sure to kill the hero. So that he will plan to keep some 30 Scorpio vehicles. And the villain's friend will ask, why do you want 30 Scorpio vehicles? He will say, I will keep 10 Scorpio vehicles in the first place. So that, okay, these vehicles will kill the hero. By chance, if the hero escapes, then I will keep another 10 Scorpios in the next spot. At least there he must be killed. If he again escapes, then I will keep another 10 Scorpio vehicles in the third spot. There he must be definitely killed, the villain says, isn't it? So same way, you first try to intercept it at 120 kilometers height. But if you fail to intercept it there, at least intercept it here. You failed to intercept it there, then at least intercept it here. It means we need that last minute saviors also. So we cannot say which is more effective. Is it clear? Yes, understood all of you? All are needed. Then 5-layer protection over Delhi. Delhi is our capital city. So we need multiple layer protection. Layers means don't think that Delhi is having some 5 blankets. It is not like that. Okay. First layer is our BMD layer. That is our AAD and PAD. Okay. This Prithvi Air Defense Missile and Advanced Air Defense Missile. Is it clear? Those two together will form the first layer. Is the first layer clear? Second layer is S400. Second layer is S400. The third layer is Barak 8 surface to air missile. Barak 8 is also surface to air missile. That is the third layer. Okay. Fourth layer is Akash medium range. Okay, look at here. Akash is also a surface to air missile. Akash is the fourth layer. Fifth layer is NASMAS 2. Okay, which is an integrated air defense weapon system. This includes radars, missiles, launchers, fire control center, etc. Is it clear? Okay, yes, Ganesh. So it means, okay, here we are keeping 5 spots to kill the target. First spot AAD, PAD. If that fails, S400 will destroy. If S400 fails, Barak 8 will destroy. If the Barak 8 fails, Akash will destroy. If the Akash fails, NASMAS 2 will destroy. This is the 5-layer protection over Delhi. Okay, it is the anti-ballistic missile defense system. Is that clear? Okay. Right? Then, now let us see more about S400. Let us see more about S400. During Operation Sindoor, our journalists with love and affection called this as Sudarshan Chakra. Is it clear? Its name is S400 Triumph. We have purchased it from Russia. At this time only, Trump even got angry on India that we have purchased this S400 from Russia. As an alternative, USA offered Patriot Pack and THAAD. Okay, they are the alternatives to S400 in the opinion of USA, but actually no, they are not the alternatives. S400 is far superior and much cheaper than Patriot Pack and THAAD, which are offered by USA. Is it clear? Okay. It is one of the most advanced air defense systems. It can intercept drones, ballistic missiles, rockets, fighter jets, okay, like that, like Osama bin Laden's flight attacking on the Twin Towers, like that. Flights, fighter jets, rockets, ballistic missiles, okay, cruise missiles, okay, drones, helicopters, any aerial threat it can destroy. That is S400, okay. And response time is just 9 to 10 seconds and you can launch it within 5 minutes. Within 5 minutes after you observe this missile, you can launch it, okay. And it can simultaneously track. It can track 300 objects in 600 kilometers range and target 36 objects in 400 kilometers range. In 400 kilometers distance, 36 different objects can be destroyed by S400. Is it clear? In 400 kilometers range, 36 different targets can be destroyed using the S400. Okay? Next, Project Kusha. Project Kusha is an Indian project to manufacture something similar to the Israel's Iron Dome or Russia's S400. Is it clear? Project Kusha is an Indian project with the target of manufacturing something similar to Israel's Iron Dome or Russia's S400, so that we cannot forever depend on the other countries. At one point of time, we should have our own defense systems. Is it clear? It is an Indian initiative developed by DRDO to create long-range surface-to-air missiles, surface-to-air, like S400. Okay, then next one. Look at this question. Next. What is terminal high altitude area defense? THAAD sometimes in the news. It is an American anti-missile, American surface to air missile, which is offered as an alternative to S400. But S400 is far superior to this THAAD and also much cheaper than the THAAD. Okay. Next, IGLA S. What is IGLA S? It is V-Shrods. V-Shrod means very short range air defense systems. Very short range. They are man portable, means you can keep it on your shoulder launched. Man portable. Human beings can take it, keeping on the shoulder, and I can launch it from the shoulder. Very short range air defense systems. Is it clear? And they also use infrared so that they can even find the targets in the night time. Okay, using infrared cameras they can even find the targets during the night time. Okay, next one, fourth topic. Anti-tank guided missile. What is anti-tank? Anti-tank means here the target is the military tank. Is that clear? Okay. In the military, army will have a tank hitting that tank. Anti, after that any word comes, that is the target. Anti-tank means it will hit the tank. Example, Nag. Okay, the two examples are Nag and the Dhruv is the Air Force version of Nag. Okay. Then Helena, helicopter launched Nag missile. Helicopter launched Nag missile. Okay, means imagine This is the military tank. Military tank. And this is a helicopter. It's a now from the helicopter it will hit the tank. Okay, helicopter launched Nag missile, army version. Same Helena, Indian Air Force people call it as Dhruvastra. Is it clear? Indian Air Force people call it as Dhruvastra. Okay, and upgraded variant of Helena is called as SANT, standoff anti-tank missile. Okay, I repeat, Helena means helicopter launchable Nag missile. Helicopter launchable Nag missile. It is launched from the helicopter and will hit the tank. Means it is like air to surface. Can I say that? Air to surface. From the helicopter to the military tank. Is it clear? And the same Helena, Air Force people call it as Dhruvastra. And the advanced version of Helena is called SANT. These are all anti-tank guided missiles. Clear till now? Anti-tank guided missiles. Then next we have Spike, okay, and Milan are also anti-tank guided missiles. Means they are air to surface, right? Next one, cruise missiles. Fifth category they are called as cruise missiles. Cruise missiles means what? They are tactical missiles. Tactical missiles means what? They are smaller missiles. So, there is no need of the government's approval. Military in the battlefield can decide to use them. Is it clear? Military in the battlefield can decide to use them. They are not strategic weapons. They are tactical weapons. And they do not follow the laws of gravity. Then who will follow the laws of gravity? Ballistic missiles. Ballistic missiles follow the laws of gravity because they jump like this. So gravitational force is the reason why they are coming back, isn't it? Is Nag surface to air? No, air to surface. Nag is anti-tank. Anti-tank means what? Target is tank. Okay. So from the air to the tank. From the air to the tank. Is that clear? Right. Then cruise missiles are surface to surface. Cruise missiles are surface to surface. But they don't jump like this. Cruise missiles will go, okay, like this. Cruise missiles have this kind of capacities. I'll tell you. Cruise missiles will have, say, imagine this is the terrain. Terrain means what? Land. And a cruise missile will go like this. Okay? Means close to land. That is called, that capacity is called as terrain hugging. Terrain hugging. It goes so close to the earth as if it is hugging the earth. Is that clear? It goes so close to the earth as if it is hugging the earth. We can also use the word sea skimming. Okay, look at here. Imagine this is the sea and the cruise missile goes like this. means close to the sea. That is called sea skimming. Sea skimming capability. Okay. Now tell me, ballistic missiles versus cruise missiles, which are large scale missiles which can cause mass destruction. Everybody? Ballistic missiles versus cruise missiles, which will cause mass destruction, large scale destruction. First, ballistic missiles, which needs a government's approval to be launched. Which one needs government's approval to be launched? First, you can use shortcuts. Ballistic missiles. Which one are much stealthier? Stealthy. The word stealthy means cannot get detected. Cannot get detected. Secret. Okay, chupke they can go. Right? Which one are stealthier? Cruise missiles. Because ballistic missiles jump like this. Imagine there is a classroom. The hyperactive student will be caught by the teacher first. The student who is silently doing the things will not be caught easily. So, cruise missiles are stealthier than ballistic missiles. Cruise missiles are stealthier than ballistic missiles. Which one do you feel are more accurate? Ballistic missiles are more accurate or cruise missiles are more accurate? Ballistic missiles are more accurate or cruise missiles are more accurate? Cruise missiles are more accurate. Is it clear? Cruise missiles, both are accurate, no doubt Saurabh correct, but comparatively cruise missiles are more accurate. Okay, because in the ballistic missiles, the second half of the journey is controlled by the gravitational force, whereas cruise missiles are navigated. Cruise missiles are navigated throughout their journey. Navigated throughout the journey. Is it clear? Therefore, they are more accurate. Is that clear? Then, cruise missiles examples. In the cruise missile example, subsonic. Subsonic example, Nirbhay. Okay. Subsonic means what? Simple. Subsonic means slower than the speed of sound. And Nirbhay is 0.7 Mach. It means only 70% of the speed of sound. Is that clear? That is the meaning of subsonic. Supersonic means faster than the speed of the sound. Okay, supersonic meaning faster than the speed of the sound, 2.8 Mach. Clear? Hypersonic means, okay, more than 5 times the speed of the sound. Okay, hypersonic means more than 5 times the speed of sound, and this is just simply faster than the sound. I mean, it can be 2 Mach, 3 Mach, 4 Mach, anything. If it is above 5 Mach, then it is called hypersonic. Hypersonic, BrahMos 2. Do we have BrahMos 2 already? No, it is under development. It will have 7 Mach speed. BrahMos is 2.8 Mach speed. Is it clear? Subsonic Nirbhay supersonic BrahMos, hypersonic BrahMos 2. These are all the cruise missiles that we have. Is that clear? And now, what do you mean by air breathing engines? Here I have to explain it. Air breathing engines means, okay, I will explain the meaning of air breathing engines. Now tell me, we discussed already that in our car or bike, we fill up only the fuel. We do not fill up the oxidizer, isn't it? In the spacecraft's propellant means fuel plus oxidizer. Fuel plus oxidizer, isn't it? But in the defense propellant is only fuel, because atmospheric oxygen can be used. Is it clear? Atmospheric oxygen can be used. Clear till now? Okay. So in this we have first type. They are called turbofan. They use turbofan to compress the air. Means like our flight, okay, if you go to any, like if you travel in a flight, okay, then you can see below the wings, you can see large fans quickly, like fastly rotating, isn't it? Those are called turbofans. What those fans will do? They will compress the air. When they compress the air, what happens? The oxygen concentration increases. To increase the oxygen concentration. Is that clear? These are the first type. Second type are called as ramjets. Second type are called as ramjet. Ramjet, there is no turbofan. There is no turbofan here. It will use forward movement of the spacecraft. It is given here. Look at this. Ramjet. Okay. It does not include the rotary compressor or turbofan. It uses the engine's forward movement to compress the incoming air. See, look at here. The missile is going like this, okay, and the air is coming like this, okay. Forward movement of the missile compresses the incoming air. Okay. See, the vehicle is moving like this, air is coming. Vehicle moving like this, air coming. Vehicle moving like this, air is coming like this. Then what it will do? The vehicle will compress the incoming air, so that the incoming air will be compressed. When the incoming air is compressed, okay, the oxygen concentration will increase. There is no need of a separate turbofan. Is it clear? Okay, right. Then what is scramjet? Scramjet also same concept like ramjet only, but works at hypersonic speed. Means a ramjet that works at hypersonic speed is called scramjet. Is that clear? And dual mode ramjet, it means when it is slow, it works like ramjet, and when the speed increases, it will shift to the scramjet model. Okay? When the missile is going slow, it works like a ramjet. When the missile picks up the speed, it will work like a scramjet. What is scramjet? A ramjet that works at a high speed, hypersonic speed. And what is a ramjet? A ramjet that will compress the air using the forward movement of the missile without using any turbofans. Is that clear? Let me summarize. Normal turbofan engine will use turbofan to compress the air. Number 2, ramjet will use forward movement of the missile to compress the incoming air. Scramjet will also use forward movement of the missile to compress the incoming air. Okay, but the scramjet is that ramjet which works in the hypersonic speed, and dual mode ramjet is something which will act like a ramjet in the slow speed, and when the speed picks up, it works like a scramjet. That is called dual mode ramjet. Clear till now? Then BrahMos we have already discussed. BrahMos new generation, important. BrahMos new generation. Okay. Its weight is 1290 kilograms and it is much lesser compared to the original BrahMos. Tell me, original BrahMos is heavier or BrahMos new generation is heavier? Original BrahMos is heavier or BrahMos new generation is heavier? Yes, please. BrahMos original is heavier. Okay. So, in a fighter jet like Sukhoi 30 Mark 1, you can keep 3 BrahMos NG instead of just 1 BrahMos. It means one fighter jet called Sukhoi 30 Mark 1 fighter jet. How many BrahMos you can keep? Only 1. But in the same Sukhoi 30 Mark 1 fighter jet, how many BrahMos NG you can keep? 3. Is that clear? In a fighter jet called Sukhoi 30 Mark 1, how many BrahMos you can keep? Only 1. But BrahMos NG, 3 you can keep because these are lighter ones. Whereas in the land and ship based system, in a ship, how many BrahMos you can keep? 3. But how many BrahMos NG you can keep in a ship? 8. So that is the advantage of BrahMos new generation. Okay. Also its speed is more. BrahMos is 2.5 Mach. BrahMos NG is 3.5 Mach. Is it clear? Yes, Prerak. Yes. BrahMos 2 will do that. Okay. BrahMos 1 do not need the dual mode. Okay. Right. Then battle tanks. Okay. Tank means military tank. Example, Arjun Mark 1, Bhishma tanker, Zorawar tanker. These are some battle tankers or battle tanks. Okay. Next one which is important is anti-radiation missile or Rudram 1. Anti-radiation missile or the Rudram 1. Is it clear? Torpedo, how it is different from the missile? Torpedo is launched from the submarine to attack on the other submarine. A missile which is launched from one submarine to attack the other submarine is called torpedo. Okay. Then now let us see what is Rudram 1. It is anti-radiation missile. See, for example, look at here. India's missile is going like this, right? And here you have enemies' radars, and they can detect the India's missile, isn't it? They can detect the India's missile. So what Rudram 1 can do? Rudram 1 will detect the enemy's radars, will track the enemy's radars, and will neutralize the enemy's radars. It means the Rudram 1 will kind of like switch off the enemy's radars. Is it clear? The radars will be neutralized. It means they cannot detect our missile. Is that clear for all of you? And it is air to surface missile. It is air to surface missile. Okay, it will neutralize the radars located on the surface. It is launched from the air and it will neutralize the radars located on the surface. Okay, then this is very interesting. Once it locks the target, let us suppose our Rudram 1, okay, detected the enemy's radar. Rudram 1 detected the enemy's radar. Now the enemies came to know that we detected their radar. So what they are doing? They only switch it off so that it won't be destroyed. Is it clear? But our Rudram is very great. It means once it locks the target, it is capable of striking the target accurately even if the radiation source switches off. Even if they switch off the radar, it can still detect the radar and hit that. Is it clear? So that is air to surface. Air to surface, anti-radiation. Anti-radiation means it will block the anti means it will block. Anti what? Anti-radiation. Which radiation? Radio waves. Radio waves from what? From the radars. Is that clear? Then same way Rudram 2, same but advanced version is Rudram 2. Is that clear? Rudram 1, Rudram 2, they both are anti-radiation missiles. They are launched from the air and will detect the radar on the surface. They will detect the radars, track the radars and neutralize the radars. Okay, and they can detect that radar. Okay, they can hit the radar even if the radar is switched off. Once it fixes, locks the target, even if the target is switched off, it can still detect that. Is it clear? Thank you so much, Jatinya. Thank you so much for the concern. Okay, soon I will do that. That is Rudram 2. Now, okay, important, very important and very interesting. What is this? Anti-satellite missile test. See, after this word anti, you keep whatever it is. Anti-satellite means what? Satellite is the target. Anti-tank means what? Tank is the target. After the word anti, whatever you keep, that is the target. Means anti-satellite missile is like a space war. Okay? We launch a missile into the space. Satellite. Is it clear? So from the surface, it goes straight into the space and will attack the satellite and will destroy enemy's satellite. It is like a space war. What is the problem here? The problem is it creates space debris. Okay, and if one missile destroys a satellite of a country, the problem is not only for that country which became the target. The space debris can destroy the satellites of any country. If ISRO launches an anti-satellite missile, the debris formed can unfortunately hit our own satellites also. So this kind of space war should not be encouraged. Anti-satellite missiles should not be encouraged, should not be permitted. Okay, isn't it? Next, Mission Shakti. This is tested in the year 2019. Here, see, just for a test, if I destroy some China's satellite or America's satellite, will they keep quiet? No? Okay. So what we have done, we launched our own satellite called Microsat. Is it clear? ISRO launched a satellite, okay, and then, okay, DRDO destroyed that satellite. ISRO, DRDO. Is it clear? ISRO launched a satellite called Microsat and the DRDO destroyed it using the Mission Shakti, anti-satellite missile. And is it against the international laws? No, we did not violate any international laws because in the Mission Shakti there are no explosives. Moreover, we did not destroy the satellites of any other country. No explosives are there, and also we did not destroy the satellites of any other country. Okay, we destroyed our own satellite and no explosives. Then you may ask me, ma'am, without explosive, how did we destroy the satellite called Microsat? Okay, without explosives, how did we destroy? Just by hitting it. Is it clear? It means with high speed from the ground, if something comes into the space and hits that, due to that kinetic energy itself, the satellite will be blasted. That is called kinetic kill technology. No explosives. India became the fourth country after USA, Russia, China to have this capability of anti-satellite mission. Okay, the problems are space debris, space weapon. This we created, but we did not violate the rules against space weaponization. It is not a weapon of mass destruction. India has a commitment of Outer Space Treaty and the Outer Space Treaty prohibits all the countries from using any objects of nuclear weapons or weapons of mass destructions. I repeat, India signed the Outer Space Treaty. In Outer Space Treaty, there is a provision that we should not use any nuclear weapons or weapons of mass destruction in the space. It means we have a commitment that we should not use any nuclear weapons or weapons of mass destruction in the space. And did we violate that particular commitment? No, because we did not use any weapons of mass destruction. Till there it is okay, but should we feel proud about it? At least I don't feel proud about it because it creates space debris. Maybe it did not violate any international law, but it is not a good experiment to do. But what to do? A disarmament should be non-discriminatory. It means if USA, China are having the anti-satellite missiles and India do not have, can be risky. It means when we have problematic neighbors with high capabilities, even if you do not want, it becomes mandatory to have that capability. Is it clear? So, disarmament should be non-discriminatory. It means if they don't have anti-satellite missiles, we also do not want anti-satellite missiles, like that. Is it clear? Both the Prerak, conventional weapons also. For example, ballistic missiles are the weapons of mass destruction, but always need not be nuclear. Even the conventional missiles can be weapons of mass destruction. Okay. Last topic in the defense technology, that is Sanjay BSS. What is this Sanjay BSS? It is not a missile. It is battlefield surveillance system. Do you remember in the recent past, in the conflict between India and Pakistan, after 2 days of Operation Sindhur, they announced a ceasefire. After the ceasefire, also Pakistan launched some drones and some missiles towards India. But we could immediately intercept. Then did you get the doubt that when you believe that they ceased the fire, so how are we ready to intercept them? When Pakistan launched the missiles or drones in unexpected way, how are we prepared? Okay, because of the Sanjay BSS. What is it? It is a battlefield surveillance system. Okay, what it will do? It is developed by Indian Army and Bharat Electronics Limited. It is inaugurated in 2025 by the Indian Defense Minister in Delhi. It is an automated system designed to integrate data from various ground and aerial sensors. Many radars, sensors, cameras will be there. And it is an electronic system. It means it is a computer system. It will analyze all that data and will take a decision. Okay? It is an automated system that will analyze the data from multiple sensors and will take the decision. Okay? So that is how all these sensors in the, I repeat, lot of sensors like radars and cameras are doing the surveillance of the battlefield. The data from all these cameras and radars is taken up by the computer systems, analytics, okay, that is electronics for data analysis. By analyzing this data, the Sanjay BSS can take independent decision of launching a missile to intercept the enemy's missiles. Is that clear? I repeat, there are several radars, cameras or sensors. All of them are doing surveillance in the battlefield. They keep tracking the battlefield. The data from all these cameras, radars and sensors will be analyzed by the electronic systems. Based on the analysis of this data, Sanjay BSS will take the decision of launching a missile to intercept the enemy's missile. Is that clear? Okay. Which type of data? Data about the drones, data about the missiles launched by the enemies, data about the missiles, helicopters, drones launched by the enemies. Is that clear? Bhanu Yadav, is that clear? Then lastly, Pinaka. What is this Pinaka? Okay, look at this. This is Pinaka. What is Pinaka? Look at here. It is a multiple launch rocket system. Okay, MLRS. Multiple launch rocket system. See, 4, 4, 8, 16, 32. Okay, you can see 32 and 32 rockets can be launched from this. Is it clear? 32 rockets can be launched from this. Multiple launch rocket system, Pinaka. Pinaka is the name. Is it clear? It is not one rocket. It is a vehicle from which multiple rockets can be launched. I repeat, Pinaka is not one rocket. It is a vehicle from which multiple rockets can be launched. Okay. So let us see that multiple launch rocket system developed by DRDO. It is capable of launching 12 rockets in 44 seconds. The system is usually mounted on a truck because of the high mobility. Okay, it is mounted on a truck for the high mobility. Very fast it can go and can release multiple rockets. Pinaka 140 kilometers, Pinaka 2 75 kilometers range. Satellite guidance to enhance the accuracy. It means this truck is guided by. This truck is guided by, it means navigated by the satellites. Is it clear? The truck is navigated by the satellites. Okay, it can carry a variety of warheads including high explosives, etc. Okay, not the nuclear weapons. Okay, traditional high explosives, conventional weapons. Clear till now? Then now, okay, another small announcement here, that is, did we complete entire defense technology? Not really. Indian Navy related means what? Submarines, warships, that is destroyers, cruisers, frigates, okay, amphibious assault ships, etc. Okay, submarines, destroyers, frigates, cruisers, aircraft carriers like Vikrant, Vikramaditya, Vishal, etc. Okay, and then air force related, that is fighter jets, helicopters, drones, and some other miscellaneous topics related to defense will be discussed on 19th April and 20th April at 11 a.m. as special classes on Unacademy platform, not the YouTube. Unacademy platform, it is a free session, not only for the Plus subscribers, any students can watch that. Is it clear? By the way, I am saying that this is free session not only for the Plus subscribers, but don't hesitate to be a Plus subscriber. Just imagine if our team is doing this much work on free platforms like YouTube and the special classes. Imagine what all wonders will be done on the Unacademy platform. I'm sorry, I cannot resist myself from saying this. Is it clear? Just imagine how much effort we keep for our dedicated students on the platform. Okay? Right. So don't hesitate to be a Plus subscriber. But anyway, this particular class is also for the non-subscribers. Anybody can watch that class. Here are the links for those two sessions. Is it clear? Here are the links for those two sessions. On 19th April, 20th April, 11 a.m. on Unacademy platform. Let us meet there again. That's all for today's session, and that's all for this phase of Conquer Prelims. We are left with, it means I am left with only one phase of Conquer Prelims, that is phase 5, that is 2026 current affairs. With that, I will be soon in front of you again. That's all for today. If you like this session, don't forget to let me know in the comment section. Thank you so much. All the best. Good night. Take care. Bye-bye.